Yeah.
Mahesh, good morning. Can you hear me?
We are able to hear you, sir.
Okay. Directors join. Directors come.
Sir, if not yet come, sir. He will be there in another 5 minutes, sir.
Okay. Right.
So, ISRO director is joining?
That is a CBPO director is joining.
Yeah, he is a member now. He is also a member in Sudhir Kumar. Sunil Kumar received from our LPS.
LPS looks like because already. Can we check the credential of Sunil?
Sunil Kumar.
He's from ISRO or?
Yeah. Is he from ISRO?
नमिता जी, सुनील कुमार अपनी टीम के तो नहीं है?
Yes, already joined.
Sir, Sunil Kumar sir and Anand Padmanabhan sir, they have some prayer meeting than this, sir. So they might join anytime in between the meetings, sir.
Oh, okay.
And he's different.
Krishna ji, good morning.
Good morning, sir.
So Krishna sir, good morning, sir.
Hello. Sir, this is SAC Ahmedabad. Am I audible?
Yeah, you are audible.
Okay, sir. Thank you.
Now we are getting good bandwidth at the other side also, so there shouldn't be any problem. So the PPT. Okay.
Who? Angela is also from ISRO. Yeah. Angela from SAC.
Sure. नहीं मेरा तो सिस्टम ही हैंग हो गया।
कल मैं भी यही प्रॉब्लम फेस कर रहा था हम लोगों ने ऑलमोस्ट 20 मिनट्स भी लॉस्ट इट 25 मिनट्स
कल भी यही हुआ एनके तो सिस्टम बिल्कुल ही नहीं चल रहा दिख रहा है कुछ प्रेजेंटेशन करना चाहता
It's surprising because
नहीं मेरे को लग रहा
years back I delivered a series of lectures for NTSU, North Dakota State University.
हाँ एमटी बोलिए हेलो 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 हाँ बोलिए एमटी
वेबएक्स में भी दिक्कत आ रही है वेट करना
WebEx पता नहीं मुझको तो
भैया मैं
मेरे
सॉरी गुड मॉर्निंग सर यस सर शाह
They said that they will have to upgrade their system for those lectures. And our NKN facility was better than that of that university.
Hello.
So a lot of difficulties during screening because faculty members from
MNIT Jaipur. Am I audible?
Yes, you are audible. May I know who is speaking? May I know who is speaking? Or
Hello, video is visible?
Pardon?
Yeah, you are
Video
audible.
is visible?
Yeah.
Okay.
Ramana, good morning. Dr. Ramana, good morning.
Sir, good morning, sir.
Dr. Ramana ji, good morning.
Good morning, Dr. Krishna.
He's from NRC.
Okay. Are you showing some slide because slide is not yet visual?
Presenter.
Presenters.
आपकी चरण
No, he's asking us. Let's say affirmative. That's it.
अटेंड कर मैं काम कर चला वो टेस्टिंग के लिए वहां से ऑफ कर प्रेजेंट करना भेज दी हाँ मुझे ये दिखाना था फोटो कॉपी करना है ना कहाँ है बोलो सबका भी हाईलाइट किया
Madam, good morning. Okay, okay. Okay. Change the law. Okay. The madam will join in.
Yes, Dr. Kanupriya is asking.
The madam will join in another 5 minutes.
Okay.
We can.
Let's say straight.
Start.
अब मुझे वापस ऑन करा दो इसके वजह से दिक्कत आ रही है कैसे करूँगी मैं तो सीधे स्पीकर आ कर पा रही हूँ एग्जिट कर अनिर्बन पानी भी है दिखेगा देखना होगा कोऑर्डिनेटर वाले से मुझे स्पीकर वाले से बात वो करना पड़ेगा लॉग
स्पीकर से मत करिए और बॉडी
नहीं
हम ये अब इस पर मेल पे जो है ना क्लिक कर
उसी से किया था
तो इसमें बाय डिफॉल्ट से होगा स्टिक करना
फिक्स पे गई यस
ये मैं वेब पेज पे मत जाइए आप सीधे लिख के जाइए
Reach the.
पे जा रहे तो पूछ रहा नहीं ना कुछ
Okay.
मेल पे आपके पास लिंक है उस पे क्लिक करना
No problem.
नहीं कनेक्ट
No problem, okay.
otherwise ये ऐप में स्टिक
Just take entry, right? Okay. Wait, for 5 minutes we can wait.
ये पीछे बैठा हो
Good
I don't
morning
get the
from SAC Ahmedabad. Good morning,
good
Dr.
morning,
Paul.
Dr.
Good morning, everyone.
Good morning.
Good morning, Dr. Namita ji.
गुड मॉर्निंग मैम
Good morning.
This is Kanupriya Satse from MNIT. Good morning, everyone.
वेलकम
Good morning. Good morning.
I hope we are audible from SAC.
वेरी मच
Yes, you are audible.
Okay. Thank you.
Shall we start? Should we?
Now we can start. Just wait, I think Sudhir ji joined.
I am here.
Good morning. Sunil ji, good morning. Alok here.
Yeah, hello, good morning.
Good morning.
Sudhir ji yet to join. Yeah.
Just 3 minutes to start.
Alok, I have a small request. I have a couple
Yeah.
of meetings in between. I will,
No problem.
in between, I'll join anyway.
Yeah. Sure, sir. Vrinda ma'am, are you there, Dr. Vrinda? Okay. Narayanan. Narayanan Appu sir, are you there?
I don't think he is not there.
Okay. Then Anant Padmanabhan. Yeah. Anant Padmanabhan sir, are you there?
to join.
Dr. Ramana, are you there? I think Ramana should join.
Yes, sir. Yes, sir. Good morning, sir.
Good morning. Good morning. I think 3, still like the 4, 5, and then we'll jump 6, 7. I think quorum we can.
Yeah.
Okay.
Professor Rohit Goyal, he previously coordinated. He helped us in all the screening.
अभी फोन आया
जयपुर से बाहर था।
अच्छा अच्छा
15 दिन से।
15
Son has gone to Canada.
हाँ कर दो सबको जो भी पूछ रहे कर दो
I think
We can allow them to please
yeah, definitely.
share and join.
I think there must be these people whom you've been contacting constantly.
No, only Sudhir sir is left. Dr. Vranda will join in.
Okay, we'll just take probably a couple of minutes. लोकल में अपने सबके बाकी और मन रखना चाहिए।
Good morning, Sudhir sir. Alok here.
हेलो जी नमस्कार कैसा है
बढ़िया sir. Thank you.
थैंक यू लॉट ऑफ ट्रैफिक सुबह में
Always there.
Okay, sir. We were waiting for you. I think with your permission, we'll
No,
start.
I told Paul to start.
No
Bangalore
problem.
traffic is most unpredictable.
No issue.
So on behalf of our director, Professor Hadi, who is also the chairman JPMC, I'm A.B. Gupta. I welcome you all to this meeting of RSES and JPMC rather, sorry. We have an onerous task ahead because there are 7 student projects, 12 new project proposals, and 4 old projects to be evaluated for their performance in a day's time, and that too under the condition that the day ends at 4 p.m. because both our ISRO partners have to go back this evening itself. So what we did was we held a prior meeting to take away all the administrative matters. So it is evaluation meeting entirely with so many projects to be evaluated. And they have already undergone a very strict screening and first stage evaluation. So with that thing in background, I would request all the people as resource persons to please restrict your questions to minimum possible so that we are able to complete the task within time. So a very hearty welcome from Pink City of Jaipur and from MNIT, which has been very popular for its hospitality. But I would urge that one meeting should be held in our campus. And I am sure that your friends, Dr. Paul and Dr. Srivastav, would endorse this decision, though they are here for a very short period. So all the details will be told by the coordinator later on. So I hand over the mic to the co-chairman JPMC, Dr. Alok Srivastav from ISRO. Alok.
Good morning to all of you, all the members, all the presenters, Director CBPO, Dr. Gupta sir, Dr. Namita ma'am, Dr. Paul available here with me, and all the members who are remotely participating in this GPMC meeting. I welcome you all at MNIT Jaipur Hall. So heartening to note that so many projects are there and our academicians, they're having a great interest in the projects which is having significant impact on space programs. So nice to see that, but the only issue, if at all I see at present, is limitation of the fund at present. But I'm pretty sure that the small barrier which we are having about that, with the intervention, with the review mechanism, with their aggressive approach in completing the task, I'm sure that ISRO will be having a kind of pressure to even accommodate them also. So what right now I feel that what we require is a dedication to accomplish the proposed projects based on timings, because justification needs to be given for releasing the funds maybe every quarterly or every half yearly. That depends upon the management. Dr. Paul and Sudhirji may guide us in that direction. Today's meeting, we will review all the projects critically, and not many query, but certain things which are highly essential for the sake of looking at the progress and their relevance in the present context of ISRO programs. That part only we will be trying to address. So with that, I think I once again thanks Gupta sir and Dr. Namita and all the members here for joining us for a whole day review program. Anyway, for ISRO, it is nothing new. We stretch beyond. And I think sure is the scenario with an MNIT, I'm sure. So the only thing is for others, it may be real taxing, but we'll be releasing them as and when their review is over. So we won't force you to stay beyond. So with that, I think opening remark, I put back the forum to Dr. Namita ma'am. Thank you.
Thank you, sir.
We can also hear from any other GPMC members would like
Yeah.
any few words.
Sudhir sir, a few comments from your side before we took over from GPMC.
Thank you, Raji. Gupta ji, namaskar, sabhi ko. See, I don't want to give much spend on this one because time is already late. Only I urge the team or the review committee team only to look into the proposals, very qualitative proposals. Post reforms, ISRO is more mandated for carrying out the research. But at the same time, on the other hand, when we are liberalizing the process, but there are strict impositions as far as the finance is concerned from the departments to follow very strictly the deliverables, because they have been insisting that any project should have a different deliverables and a different timeline and schedules. So these are all the three things department. I just only conveying the message of the government to the fora, because normally research would go in a bit uncertainty way, because this is obvious. So I request the MNIT team to give more focus on the qualitative projects with a subjective, not subjective, objective deliverables. Stick to the time schedule as well as the fund, so that we can take this program in multiple. Thank you.
Sure, sir. Thank you. Thank you so much for your remarks.
Yeah. Any other member? Dr. Sunil, Dr. Branda? Any comments?
Go ahead. Anyway,
Okay.
time is short. We'll go ahead.
Yeah. Okay, ma'am.
So, Namita ji.
Thank you, sir. I welcome again all of you. So this is about the action taken report of first JPMC meeting held on 21st January 2021 online. It was again in the chairmanship of Professor A.T. Gupta. So there were lots of minutes, and what we have done, the 4 ongoing projects are doing well, and report has been received from ISRO people. The next agenda was action taken on some of the institutes to be associated. One of them is IIIT Kota. Yes, it's working well. We have added it. Vivekanand Global University was not doing, means ISRO people was there earlier. Now he has left, so he is not part of that. And I have circulated all the action taken report by mail only. So you can download and see as well. The next was the consideration of requirement of full-time staff on consolidated salary. This is under process because of overhead funds to be received. We have to hire a person. Right now, a person is there. He is on manpower. The next is recommendation of honorarium to web portal developers, Mr. Tejpal Singh and Vikas Jana. So this 24,000 is to be given to them. Still, it is pending. And we have review committee meeting. In this cycle, we have received 75 projects from 16 institutions, those are associated. Out of 75 projects, we have reviewed them at the RCC level. 32 were strong, except we sent all these 32 to ISRO people. Out of 32, we received the 10 came with a strong recommendation and 3 from Yukti Sanchita. So total today, we are going to review 13 projects. Apart from that, we invited call for proposals for student projects for MTech and BTech. Total 37 call for 37 projects received. Out of 37, we had a RCC rigorous committee. It took around 8 hours in a day. Four experts were there in the committee, and it was around 20 minutes for each project taken. 30. Then we sent 12 projects, 6 from circuit branches and 6 from non-circuit branches to ISRO. Out of 12, 7 has been given strong recommendation. Today they are going to present. So this is the minute, means this is to be done today. 17 from student proposals and 13 from 7 from students and 13 from research projects, faculty projects, new projects, and 4 ongoing projects. Those are to be. We have received the recommendation from ISRO people. So this is all about the review meeting, today's meeting, and I hand over to the. I mean, we can ask, if with your permission, we can ask one. First person is Dr. Rajesh Kumar Rai from MNIT Jaipur. Development of high entropy alloy components from this, and the LPSC is a response coordinator.
Good morning, all of you. I am Narayan Murthy from LPSC. I am joined by Mr. Raviranjan. Both of us are here.
Welcome,
Thank you.
sir.
Good morning.
Good morning, Narayan Murthy, sir. I request all the presenters to stick to time and all others to mute their mic. Thank you. Yeah, over to Dr. Rajesh, please.
For your information, we have given 10 minutes for presentation and 5 minutes for questions. Restricted.
Rajesh, you are muted.
Sorry. So, good morning to all of you. My name is Dr. Rajesh Kumar Rai. Today, I'm going to present my proposal, which is under the Yukti Sanchita scheme. So, I'm going to share my slides. I will start with that. So, is that my PPT
Yes.
is visible?
Yeah, slide is visible and you can proceed, please.
Okay. Once again, a very warm good morning to all of you. Today, I'm going to give a project proposal which is on development of aluminum, cobalt, chromium, iron, nickel, titanium, high entropy alloy for the high temperature aerospace application. This project is proposed under the Yukti Sanchita scheme of Space Technology Incubation Center and Liquid Propulsion System Center, Tiruvananthapuram ISRO, and Regional Academy Center for Space, MNIT Jaipur. As I said, I am Dr. Rajesh Kumar, who is a PI for this project, and along with me, Professor Chandran Srivastava, who is a professor at the Department of Materials Engineering, IISc Bangalore. The following are the outlines for this project. For first few minutes, I will discuss about the origin and motivation behind this project, followed by the objective, methodology, deliverable, scope, budget, and activity tasks. So now, first of all, we need to understand, what are the characteristics that is needed for the high temperature structural material, because this project is all about developing a high temperature material. So the following characteristics should be required for a high temperature material. It should have a good creep and fatigue resistance, should have a reasonably well the microstructural stability, it should have a fair enough oxidation and corrosion resistance. It should have a lighter, and apart from that, it should have uh, a high room temperature ductility as well. And of course, the other thing is strength. So we could have a good strength as well. Now coming to this is a typical schematic of a cross section of gas turbine engine, and you can see that these are the hot sections of the gas turbine, where the temperature is above 600 degrees and so. And you can one can see that in the hot sections of gas turbine engine, mostly we use nickel-based propeller. And the reason why we use the nickel-based propeller over there is as follows. If you see that in this curve, if you see that the curve that is showing here is a specific strength versus temperature, you can see that the nickel-based propeller has the ability to withstand their strength to a very high temperature. This is a prerequisite for the high temperature material. Now, this is a typical equation for the efficiency of any engine or any components. You can see that here T1 is the temperature, inlet temperature. This is the temperature that's what the material is going to expose. So as much as temperature a material can expose, could have that engine could have a better efficiency. Keeping these in mind, one can say that one can increase the efficiency of a component if we use the temperature bearing capability of the material that is used there. This is the one way. The other way is we can have a material which has high temperature capacity. In addition to that, it should be a cost effective, so that that can be done by substituting some of the expensive elements that is used for making a high temperature materials, and one can also cut down the weight by using some lighter material for that. In that way, one can improve the efficiency or the performance of a high component material. Now, as I mentioned here, nickel-based superalloy are a first choice, or it's a vital material as far as the high temperature applications in the aerospace industry. And here we can see that typically over last 7 or 8 decades, how the nickel-based superalloys has been evolved. So we have started with basic wrought nickel-based superalloys, and we started doing a solid solution strengthened nickel-based superalloy. Then we comes with the precipitation hardened nickel-based superalloy, which is widely used nowadays. And even with the precipitation hardened nickel-based superalloy, we have tried to adopt the different processing route so that we can eliminate the grain boundary. So we have we have a next version is directionally solidified, where we reduce completely the transverse grain boundaries, and then we have a single crystal versions, which is here. So in that way, since I have mentioned that the creep is a very important property for the high temperature application, so if you remove the grain boundary, so it will improve the creep resistance of the alloy. But now it has been seen that we are in the verge of maximum exploitation of these alloys as far as their temperature bearing capability is concerned. So we are nearly touching the threshold. And the reason for that is, we have a limited scope for such a alloy to manipulate or to alter their compositions. So now the focus is shifted basically to replace the expensive metals, the elements that is used like the rhenium, moly, some other elements to making these alloys. So I mean, why we have such a the basic, I mean, the restrictions in the composition space of nickel based super need to be understood. So here, if you will see that it's a typical conventional allying strategy, and this we call basically the conventional dilute alloy. So, and this is in the custom since over centuries and centuries. So here, what we do that in conventional alloy design, we took a major constituents or a major allying element that is called the principal allying element. And here we say that this gray balls are the principal allying element, and we add a small fraction of other allying element to it. So that's why it's called the diode, because the secondary elements are in the minor quantity. We added it in the minor quantity. And why we do so? Because if we add a more and more allying elements, so there will be a restriction to I mean, they would have a tendency for the clustering. This is a typical free energy, you know. It's basically a free energy of mixing when we look to different atoms and allow them to mix up. So this is the free energy of mixing. There should be a mix at the top. So you'll see that unless if you increase the number of allying elements, so they will cluster down. So therefore, if they don't cluster, then we would have an increase in the enthalpy of the system. So and clustering leads to the formation of number of intermetallic compounds. If you see that, if you come to the mid of the composition range of this is a typical aluminum nickel, you know, phase diagram. You will see that in most of the conventional phase diagram, we will get things like that, where we have intermetallic compounds that is formed in between, and that has a adverse effect as far as property is concerned. So to get rid of that, you know, we need to have a new allying strategy where we can, you know,
Dr. Rajesh, I can request you to speed up, please. I think we are on. Is it the last slide?
Yeah. It's in the introduction session itself, the last.
No,
But
but
Rajesh,
we are having only
this is
10
Narayan
minutes.
Murthy. I think these things are not required. What you are going to do, you please talk. Okay.
Yeah, that's it, sir.
Because these are all very highly fundamental things. So please go to your work.
Okay. So in view of that, we use a multi-principal component high entropy where we have a more flexibility in terms of composition, and also we can have a number of different alloys and which could have so different properties. So therefore, the most attention has been paid to design material that can replace the super alloy using the hot section of the aero engine. In this context, we are just using a high entropy alloy, as I mentioned. These alloy can provide a cost-effective solution for the super alloy. And it has been seen that, you know, high entropy alloy can withstand a significantly high temperature, like a super alloy. Whereas there is one issue that their strength deteriorated if we exceed the temperature 700 degrees and so. So these things need to be you know, addressed. So to tackle those problems, what we have done in this project, we have used the concept of super alloy. We have applied the concept of super alloy in making the high entropy alloy, where we have a matrix of high entropy super alloy, and then we will be precipitated some precipitates over there so that their strength remains intact at the high temperature. With that, the objective of the current work is to just develop aluminum, cobalt, chromium, iron, nickel, titanium based high entropy alloy, which is expected to have a better customized and balanced property than the contemporary nickel based super alloy like iron 7. Whenever we design a new alloy, so we
Rajesh, please don't read each bullet. I have finished already whatever you presented. You please concentrate on the deliverable from your side.
Okay. So, so what we will, so in order to do that, what we will try to, how would we do it? So we're following.
Rajesh, sorry, I'm Chandan here. What the committee is telling is that you don't straight away go to what is the deliverable.
Okay.
What you are going to provide as a solution to the problem, exactly to that point, right?
Okay. So basically, we are going to design aluminum, cobalt, chromium, iron, nickel, titanium based high entropy superalloy that could have a better customized property as compared to the iron 718 superalloy, which is used for in the space material, especially in the space vehicles. And we will try to optimize the process parameter and technique for realization of that. We will do the mechanical property evaluation of the alloy at room temperature and of course at the surface temperature, which is at the 650 degrees Celsius. To the in-depth microstructural and mechanical characterization, we will once the things will be optimized, then we will deliver. We will cast a 10 kg high entropy alloy, three blocks of 10 kg high entropy alloy, which will be one of that. Those will be supplied to the LPSCs. This is the budget here. So at the different sections we have these are the budgets that we have been put. For the personal, we need to have 8.63 lakhs, and then the operation and maintenance and the other accessories for the equipments that will be used there. Then there is some fund is needed for the travel contingencies, and since we have a design a new alloy, so we have to procure a number of commercial pure elements. So for that, we need to have expend a significant amount of money, and then we will do some of the services outside. So for that, we have this problem, and this is the fixed amount that we used to pay for the institute. So this is our budget. And these are the deliverable milestone and the fund required as far as the milestone. So for the first half of the first year, we need an advance of 15 lakhs to pay the salary and all those things that I have mentioned over there, and we have to procure the raw material. And so by the end of first year, we will optimize the composition and parameter for the casting. In the second half of the first year, development and microstructural characterization of as-cast alloy will be done. The first half of second year, there will be mechanical characterization, which is of course the tensile and hardness, and some of the fatigue property will be evaluated. And at the end, we will do the mechanical property evaluation, writing, and the final presentation. These are our PNC chart.
Okay. Thank you. I think I'll request Narayan Murthy ji and Dr. Sunil to initiate the question session. I have only one point, sir. This turbine place where he is just mentioning the temperature 600. If I remember correctly, that should be around 1200 to 1500. Whether this input is given to him from our side, and second thing is basically the support from LPSC. So that is my two query. Anyway, after your question, I have few more I'll ask.
Sunil sir, shall I give my opinion?
I think Narayanamurthy can proceed because I am on to the another meeting at 10 o'clock.
Okay,
sir. Called.
Okay,
Okay, please proceed.
Okay, sir.
So I will come back. Okay.
Right, Dr. Sunil.
Okay.
Thank you.
So, Chairman and members, okay, so we have gone through this proposal. Okay, we have gone through and internally we have reviewed also. This proposal has strength. Okay, it is basically we are using nickel-based superalloys in a number of systems like gas generator, gas engine, or turbo pumps, Okay,
Right.
both in regular, ongoing projects as well as future also, we are using number of nickel-based superalloys. And the maximum operating temperature, for example, for an alloy like iron 780 is 650 degrees centigrade. Beyond that, it will not be able, the strength and ductility will go down. Now, the proposal is on development of a high entropy alloy based on, alloy which is having superior properties, maybe in terms of the strength and operating capability. Okay, so if it can be used beyond 650, it will be definitely a suitable material for many of the applications. Second thing is the density, because of the addition of aluminum into the material, the density will be lower than the presently used superalloys. Okay, so there are two advantages. One is the operating temperature capability beyond 650. Second thing is the density. So these two advantages will be useful for replacing some of the components that we are using. So the strength lies in these two. And this is a new type of material. These are new type of materials that are being proposed as alternative to the conventionally processed ingot metallurgical materials. So that is also another attraction. So the proposal can be considered, and we have Dr. Rajesh Kumar, and of course we have Dr. Chandan Srivastava. So both are Dr. Chandan will take care, I think, mostly of the characterization part of it. So
yes.
Having all the expertise, whatever is required to carry out the project. So with the support of both IISc and NIT Jaipur, I think this project, they can handle the project very well. And the cost of the project also is reasonable. Okay, so because the processing is very critical, it is not easy. So they have to do a lot of experimentation. Whatever they have proposed, the budget also is suitable. So from our side, we are supporting, and we request the committee to positively consider the project for approval.
Okay.
And one question that was asked is the temperature. Actually, okay, maximum temperature what we are using is around 650 degrees centigrade only. It is not 1200 to 1500 where materials will start melting. So this is the reply to the previous question.
Okay, thank you, Naramurthy sir. Any other member, any other comments? Okay, Dr. Rajesh, can you go back to the budget slide? I am finding that budget is little higher side.
And year-wise breakup is also required.
Yeah, I think you have proposed around 27. I felt it. Overheads we can slightly reduce it. It's around 4.5 lakhs.
I cannot exceed 3.
Actually, this is not okay, in my opinion. Plus, to start with also, can we bring down below 25? I think this is more appropriate. And the second part is, I'm really very happy that this kind of configuration is bringing up. Since time doesn't permit me to, I'll reserve the question separately for Dr. Rajesh. But I think we can clear this proposal based on our LPSC remarks, because we are looking for this kind of high entropy material. We'll clear it. Only thing is I'm not clearing the budget sake. So I request that this should be really brought down below 25. Because this overheads and this kind of, even this technical aspect, I don't have any these things. The 4 lakhs is okay. But this overheads this, and I start with the two things. If you can slightly bring down, it can come down below 25. I think I request Dr. Paul to look at it jointly so that it can be brought down. Okay, Rajesh, I think congratulations. Thank you very much. We will proceed further.
Thank you. Thank you. Thank you.
Thank you.
Thank you, sir. Thank you.
Sir.
Thank you. We'll go to the next one from Dr. Vinay about detection of trace elements using microsensor.
Good morning, sir.
Welcome, Dr. Brindam.
She is a GPMC.
Ma'am, Brindam, ma'am, you are muted.
Yes. Good morning, sir.
Good
I
morning.
was here when he presented and throughout the deliberations. I also agree with you.
Thank you. Thank you, ma'am.
Thank you, madam. Thank you, sir. Thank you.
Thank you. Yeah, over to Dr. Vinay, please.
Okay, sir.
Please concentrate only on the deliverable, Dr. Vinay. Only 10 minutes presentation. Thank you.
Okay. Sir, my screen is visible, right?
Yes. And please spend minimum time on introduction and other things.
Sure,
Straight
sir.
away propose methodology and deliverables.
Okay, okay, sir. Okay, sir. So good morning, everyone, to all the panel members and expert members from MNIT and ISRO. So I'm Dr. Vinesh Palaparthi. I'm from DRCD Gandhinagar. And we have a co-PI, Dr. Kuldeep Singh from MNIT Jaipur. So in this proposal, we are planning to propose a multi-sensor array which can be used to detect the trace elements in a human space flight. So this is an agenda of today's presentation. So I'll just quickly skip this part and come to objectives. So as everyone knows that there are different trace elements such as methane, ammonia, nitrogen dioxide, carbon monoxide, which arises mainly because of the fires or flames which happens in the human space flight. These are the important elements to be noticed out in a human space flight cabin. So for this purpose, we are proposing an eNose electronic nose platform which can detect the methane, ammonia, nitrogen dioxide, carbon monoxide with the help of a 2D material, 2D nanomaterials, which we are going to use graphene oxide, which can sense these 4 trace elements at a time with the help of an nano microsensors. Besides this, since we are developing our own sensors, so we have to develop our own interface electronics for that. For this purpose, we are going to make the low power circuitry with a power gating scheme to ensure that power is optimized during the operation of the system. Besides this, we'll have a hardware, dedicated hardware, which will be used for a low false detection. Apart from these 2 things, we are going to implement an artificial intelligence machine learning algorithm. So mainly we are using this algorithm to enhance the sensor selectivity, because since we have to target the different elements, trace gases in a medium, so there could be the overlap between the gases, or there could be the sensor to sensor interference. To abate those concerns, we are going to use the PC and K-mean algorithm. Apart from that, we're going to have a portable device and hardware which will be given to the team for testing purpose, and with a typical form factor of about 5 centimeter by 4 centimeter by 3 centimeters. And finally, we are going to validate the sensor and system performance with the facility available at ISRO and IIT RAM. And we'll also benchmark the measured data from the sensors with either with a commercial sensors or a standard protocol, which typically ISRO follows. So novelty is that we have a multi-sensor platform where we are detecting the multi-elements, methane, ammonia, nitrogen dioxide, and carbon monoxide with help of a 2D nanomaterials as a sensing film, and application of PC and K-mean algorithm to enhance the sensor selectivity and a low power in-house interface electronics. So how we are going to develop this technology is that, first of all, we have to make the nanomaterials, 2D nanomaterials. So for this purpose, we are going to use a graphene oxide. So with the help of a team from Guwahati University, Professor Heyman, so they are experts in graphene material synthesis. So we are going to use a graphene oxide which will be functionalized with a different composites, so that it will be selective to the target analytes, which is say methane, ammonia, carbon monoxide, and nitrogen dioxide, and we will do the surface characterization. Subsequently, we will design the sensors. So the sensor is nothing but we have a silicon substrate. On the silicon substrate, we have an interdigit electrodes as shown here. So in a single silicon chip, we're going to have 5 different sensors. So this is an actual photograph of the sensor, which we have already fabricated in our lab. So this has a single silicon wafer along with the 5 interdigit electrodes on a single silicon wafer, and we have taken electrical contacts to measure the sensor change in resistance, and can broadcast 4 different nanometers functions with 4 different chemicals, so that it will be selective to the particular target analyte. So apart from this, so this is a simple sensing mechanism which we thought that how the fabricated sensor will sense the particular target analyte. So if I just start with a CH4 sensing, so if you take an SNO2 and RGO nanocomposite, so the researchers have claimed that it will be selective to an CH4 sensing, whereas for ammonia, if we use a PANI polymer along with RGO, so that will be selective to the ammonia, and subsequently for NO2 and CO sensing. This involves a bit of chemistry. I'm not going into details of the chemistry of this, but the main objective of showing this particular schematic is that, as I said, that since we are going to target a different trace elements in a single device, so there could be the overlap among the trace elements, or there could be the sensor to sensor interference. And so to avoid any false detection, we are going to implement the principal component analysis PC and K-mean algorithm, which ensures which enhances sensor selectivity more. So that is the application of an AI and machine learning algorithm in this particular proposal. Apart from this sensor development, as I said, that we are going to design our own interface electronics. So the novelty of this electronics is that this electronics has a self-healing concept. So for example, if the sensor or a system fails in an actual condition, so it has some kind of a redundancy components in the system, and those components are considered as a primary components of this entire system. For example, LDO or say amplifier and oscillators. So if one oscillator fails, or if one LDO fails, we have a backup mechanism to trigger that LDOs or an oscillator. So that's the novelty of this particular hardware. And once we are done with this hardware, we are proposing a small portable device which we can give it to the ISRO team, and they can test it under in-situ conditions. But of course, based on the feedbacks and recommendation which we have received from an ISRO about an interface and all those things. So I will address all the comments which we have received in subsequent slides. So how this project is relevant to the ISRO? So most of the onboard human space flight systems which has a fire suspension system. So we need a such system for the early detection of these trace gases, and early detection will basically help the astronauts for consuming. They don't want to consume just trace elements which will be hazardous. So we want an indigenous system, a portable system which is ease of use, and it can be easily interfaced with the existing ongoing facility which the human space flight has. So this is an expected outcome. So again, based on the feedback which we have received from the ISRO team. So these are the trace gases. So we have two outcomes for the proposal. One is the fabrication of the sensors along with the 2D nanomaterials, and second is the system. So that's why I have divided into two different categories. So first outcome is about the sensor. So when we are proposing the sensor, we are proposing that we are going to detect ammonium, methane, carbon monoxide along with the ranges specified in this table, and the resolution and accuracy of about 1%. And the sampling rate or the rate is about 60 seconds, or the response time is expecting about 60 seconds. So we have claimed the resolution of the response time of about 10 seconds to 120 seconds. So 60 seconds is doable, because the initial testing which we have carried out with our sensors, we observed that the sensor attained its maximum value, about 80% of its maximum value within a 60 seconds time frame. So that can be doable. Apart from the sensors, we are going to have this portable device which will have this entire electronics along with the data visualization and the alarm system to notify the astronauts. So these are the expected outcome. These are the budget. So major amount is has went to the manpower and an equipment, and rest of the amount is mainly for the consumables. So as suggested by an ISRO team, the components which you are going to use, so it should be of a space grade components or a military grade component. So by default, the price of the single IC will increase. And the overhead we have restricted below 3 lakh or close to 3 lakhs as suggested. So this is a time chart. This is very important. So we have proposed this for 2 years, for 24 months. So initial 6 months, we are going to synthesize the graphene nanomaterial, and we are going to functionalize the graphene with composites as proposed in the literature, so that it will be selective to an ammonia, methane, carbon dioxide, carbon monoxide, and nitrogen dioxide. So this involves a bit of time where I'll be collaborating with Professor Hemant Kalita from Guwahati University.
Okay, Dr. Vinay, I think we have read the slide. You are
Yes,
taking one by one. You go ahead next.
Okay, sir. So these are the comments which I have received from ISRO. Right. So based on the comments, so as suggested that we have to focus on the trace gases, that is ammonia, methane, carbon monoxide, with the resolution and accuracy as mentioned. So we will avoid by this table. The second comment was about the sampling rate. Shall we adjust to 60 seconds? Yes, of course, we can adjust it. So we have two different ways. Either we can tune the sensing film or we can tune the circuit. So that response time will be about 60 seconds. Third comment, which was very important, that how we establish the calibration protocols and stability of the sensor. So for this purpose, we have to generate the different sensor transfer characteristics. So where we'll be using the ISRO SAC facility or IIT RAM, the university here at Ahmedabad, where we will expose the sensor with different concentration, with different ppm levels, and we will observe the sensor change in resistance. Subsequently, we will generate the different sensor transfer characteristics such as hysteresis, stability, selectivity, response time, and so on. And for benchmarking, what we have planned is that the values which are measured using our sensor, we are going to benchmark that values either with the commercial sensors which are available in the market, or if there are any standard methods which ISRO or IIT RAM follows, we will try to establish the benchmarking protocol with that standards. And as far as stability is concerned, since we are going to use a graphene oxide as a sensing film, and we have already tested the stability of the graphene oxide for agriculture applications, where we have observed the sensor stability is about 4 months. But of course, that was for an agriculture application, and the conditions are totally different in this proposal. So we have to explore the stability of the sensor if we use a graphene. But we believe the stability will be higher because graphene has a carbon, and the carbon is considered one of the stable material, right? So, if we believe the stability will be very high for this particular sensor. Then comment 4 was whether there will be dedicated sensors for the target gases. Yes. So as shown in the photograph, we'll have a single silicon chip which will have 5 different IDs, and we can dropcast the graphene oxide functionality with different nanocomposites. Comment 5 was whether is it any data available on effect of temperature, pressure, humidity, and space radiation. We have the data for effect of temperature, and we observe that sensor capacitance changes only by 3% when the temperature has changed from 20 degrees to 70 degrees. But of course, this is not the condition for the space application. So we have to again test the effect of temperature, pressure, and humidity, and space radiation. So again, I think for this purpose, either we are going to use the ISRO facility or an IIT RAM facility to test this specification. Comment 6 was that it was told to us that there's already the power supply socket available for us, which is 28 to 42 volts.
Move on, Dr. Vinay, you are very slow in, you are reading each and every bullet. You give gist actually.
Okay, sir. So most of the comments, which we have, which we have received are addressable. And one important comment was about the role of comment number 12, that is the role of artificial intelligence and machine learning. So to improve the sensor selectivity, we are going to use this particular technology. And finally, comment 14, what is the deliverables that we have to give it to the ISRO. So the method for sensor fabrication and testing protocol, the documentation we will give it along with the different sensor transfer characteristics, the entire PCB design files of entire system, and an hardware, which the ISRO can use it for and under in situ conditions.
Okay.
That is the difference.
Okay, Dr. Vinay. Yeah, comment from ISRO member. HSFC, anybody is there?
Sir, yes, sir.
Yeah, please go ahead for your comments.
Yes, sir. Actually, Vinod sir is the co-PI. He is having one more meeting. So, I mean, subordinate Ravi Shankar along with me, Srijit is there.
Yeah,
And
Srijit, I think, I'm Alok here. I think you go ahead, Vinod, then you will discuss separately.
Yes, sir. Actually, this is a good proposal in the sense that the current whatever TraceGate monitoring sensors in ISS and other things, they are all bulky systems using mass spectrometer or FTI. Yeah? Even whatever we are proposing for Gaganyaan also is electro-optical sensor, which are brought out sensors. So this whatever the size and the dimensions whatever they are proposing, it is quite interesting, and they have submitted the proposal and we have given some feedbacks also. It's a interesting proposal, sir, and this can be considered.
No, only I have 2 comments. I think anyway, bus and interface both up to 28 to 42 as well as MIL that our interface. I think that way it is okay. But whatever I was just looking for is the specification and that validation. These 2 parts, because we are having usually residual gas analyzer, but we don't have any absolute reference. So I'm not sure whether, and time is too short actually, and RH compatibility and other temperature compatibility for that electronics, 1553 interface. I'm not very sure. It's given only 5 months. So 18 to 20 months are there. You have to follow it very rigorously with them to get it.
Okay, sir.
Okay, sir.
Otherwise, I'm little hesitant in this. The only reason is that the kind of time he has given and the issues which are there, because it's a single chip. For
Right.
all the 5 elements, he's going to use that, and in case that because it's only single film coating, so I think I don't know whether it's an absolute sensor for that. The way he's telling it's absolute, but how he is going to compare it, I'm not sure about it. So some kind of because we don't have any ready-made systems. All are what we are having and what we are going to use in our HSP. That also is nothing but residual analyzers. So I think you please look at it, Srijit, you see that. And he has not talked about size of the electronics. He talked about the sample size, that 543.
Okay.
So please look
Sir,
at it. Okay?
Okay, sir. Right, sir.
Okay. And this budget also 22, I think.
Budget.
Can you just go back? I think we can contain within 20, or I'm fine. Just a moment.
Sir,
Just a moment.
I'm
Please.
Dr. Yeah, yes, sir.
Yeah, go ahead.
Okay, Dr. Abba, please wait. I will come back to you. This manpower, actually, this is for Gandhinagar, no? Gandhinagar, what you have calculated for HRA, that is, it should
Yes,
be
sir.
27%, you know. So that we will have to correct it. And this our contingency also, please don't put more than 20,000 per year now. Because contingency is, there is a recent order from DOS telling that contingency and institutional overhead will be released only after the project period. So even if you project it now, so you are not immediately going to get it. So if it is required also, if consumable is there, you add in consumable if required. But please don't add in contingency. Okay, anyway, we have not agreed for that. We have given some recommendations for that. Anyway, we'll see. Till that order comes, reverse it, no? We will have to keep minimum amount in contingency. That is all my comment.
Paul, I have one comment. The sensors you have seen last IIT Delhi also SAC has proposed so many sensors. One side IAST as a long term, let us say, tie-up with HSFC project. They are establishing a lab and they are going for expanding the same thing. I'm quite confused because every meeting, one way or other, some sensors are cropping up. Do you think that these are all to be consultatively reviewed and some action has to be taken, because this was action by Chairman ISRO himself? We have discussed also as a part of indigenization committee. These sensors, I strongly feel that there is a lot of duplication of effort and resources being duplicated at a number of places. And we want for HSFC program, because let Vinod take a call on that one. Probably I think I can also talk to him. We have to take a consolidated view on sensors, not only for HSFC program, as by and large for the entire ISRO system. Please be careful not to duplicate the things.
Sir, that is the reason whatever this HSFC related, sensor related proposals are coming, forwarded it to, actually this was submitted by SAC also. SAC was
Sir,
also in this project. And that is why it was
sir,
this also.
actually, Dr.
Madam, just be, when somebody is talking, please be patient. Because let us not cross talk, let's not have it, madam. Because somebody is talking, please just have a patient for 1 minute.
So that is why it was referred to HSFC also. So they have taken care. Whatever all the projects we have given so far in various centers, no. So that is, there is no overlap for this particular project with those things.
No, I am not talking about overlap. I am talking about duplication of facilities.
Okay.
Sir, Sudhir sir, can I comment? Vinod sir's team, Ravi Shankar here. Can I comment, sir? Sir, actually, whatever you told, sir, the technology is different, sir. IIT Delhi, whatever they have proposed, that is surface enhanced Raman spectroscopy. This is 2D nanomaterial based sensing. And IAST, whatever we are proposing, no, that is electro-optical based sensors. So the technology is different, sir.
No, Ravi, you are not understanding my point. See, HSFC is a sustainable program. And it requires permanent effort so that tomorrow calibration, tomorrow even scaling up for productionization is very much required. So I am just suggesting you keep a view on that. Let us say wherever development happens, let the development happen. But ultimately, you have to consider productionization and scaling up also, and have a consolidated view. Get it reviewed at director level, director HSCC level, or you come to PMC. Let us have a consolidated view. That is only my suggestion.
Sure, sir. Sure, sir. Right.
Yeah, I think I fully agree with Sudhir, sir. I think I was also remembering ISC also this work was going on. So I don't know, maybe I thought that it is cleared from this thing. That's why I didn't point out. Okay, I think ma'am, you are telling.
So SAC has some points. She was.
Yeah, Dr. Abha, you were telling something? SAC?
Sir, yeah, sir, actually, almost more than a year back, Dr. Vinay started his discussions with SAC team, Human Space Technology team. And this is how, because our Human Space Flight team is responsible for developing the environment monitoring system for cabin and and also integration with electronics. So SAC subject experts Payal Sharma and Jayesh, both are available here. And with their discussion, this proposal was developed and with a novel concept of using the 2D nanomaterials. So I request Payal and Jayesh, they will elaborate on this point.
Good morning, sir. So this is Payal. Actually, sir, first I would like to differentiate between the technology which are being developed at the different places. So first is the IIST, sir. IIST is completely a MOS-based technology. Altogether, they are discrete sensors which we are going to use.
Payal, I think you are repeating what we already discussed, and I personally reviewed. I have personally reviewed ECLSS program. Jayesh is fully aware. I am only requesting whatever Sudhir ji pinpointed. At center level, you please discuss this. We are not objecting that. At consolidated form, it's a long-term project. It has to come out. Okay?
Okay. Fine,
So
sir.
we are fully aware that there are 3 different technologies. People are working on that. But we should have a pragmatic approach towards the solution. Okay? Okay, we leave it there. I think Gupta.
I have just a small observation and kind of suggestion as well. You have kept scales for all the 4 components 0 to 500 ppm. CO it's okay, but not for NOx and ammonium. So just see OHSA, OSHA standards for indoor air. So, and calibrate your scales accordingly, because certain things will be needed in ppbs and certain things in ppms. That is a suggestion.
No, I think he has given different range for all the. I think 0 to 500, 0 to 3200, 0 to that range.
No, but it's all ppm.
ppm.
You have to go to ppb levels, especially for ammonical nitrogen and NO2.
Sir, I have received a mail from SSC that they have developed this project. So they should be.
This was based on spacecraft maximum allowable concentration. It's a NASA standard, sir.
Yeah.
Okay.
Okay, fine.
COPI from both the agencies.
Yeah,
right.
If approved, we can.
Can I come in? I'm Dr. Parul here, sir. Sudhir Kumar, sir. Good morning, sir.
Good morning.
Sir,
Good morning, ma'am.
can
Please
I come in?
proceed. Yeah, please.
Yeah, sir, I do agree that yes, a consolidated view, this has to be there. And that's why internally with DK sir, who is our Deputy Director for HSTA, we have always been discussing with him that what all technologies which are there. And with Uma Maheshwaran sir also, when he was here for Gaganyaan, we had discussed. And internally it was felt that let different technologies, be developed, sensors through different technologies at different centers. And once it is developed, because we have a very short time, and then we'll be able to, find out which is functioning as best. So that's what was internally discussed, but certainly we'll again discuss it. But in internally here at SAC, we felt that we should try out the different technologies and then find out which one is going to, work, because now we have to seriously work towards our Gaganyaan, and we are closely in touch with our HSFC. So that way, this is what is like. We have also been discussing, because a lot of proposals are coming.
Arul ma'am,
and which is best we are trying to take up. Yes.
No, time is not there, because to cut the story short, please make this available, because when we sitting in the several committees, we'll get confused. When the direction comes from the centers, that will be very easy for us to execute. Please share such kind of minutes or anything, what kind of distribution has been there, and so that any meetings know, because we almost deal with the 12 to 18 institutes. Okay, we'll have clarity. Okay, thank you. Let us proceed to the next one.
Sure. Okay, sir. Thank you.
Thank you, Dr. Vinay. I think budget also we have commented. I think I request you to revisit and contain within 20. This is my personal request. I think I am finding that there are points, but I don't have time to go through one by one.
Okay,
I've just now assessed it. I'm thinking within 20 you'll be able to manage. Okay, we'll go to the third one. Dr. Priyanka.
Good morning, sir.
Morning.
Shall I share my screen, sir?
Yeah, please. Yeah, it's visible. Please proceed, Dr. Priyanka.
Sir, so the project is ISAT2 based ground photons retrieval in urban areas using the deep learning algorithm. And my team members are Dr. Basant Agarwal, Dr. Ankush Vashisht, and Dr. S. Srinivas sir from NRSC. So I will be discussing about the problem statement, introduction, objectives, and how it is beneficial for ISRO, the deliverables, timelines, and the budget. So briefly, I will talk about NASA's ISAT-2. So it carries a laser altimeter on board that produces geolocated photon events on various types of surfaces such as glaciers or oceans, land, and canopy of Earth. So, and the the product on this is called Atlas, which is a advanced topographic laser of altimeter system, and it functions on the concept of multi-beam approach that is beneficial for measuring the global heights. So there are three beams there. The instrument transmits a green laser pulse at 10 kilohertz as is shown here. So and the beams are separated at 3.3 kilometer distance from each other, and the distance between the strong and weak beams. There are three pairs of beams, and the distance between each pair of beams is 90 meters as depicted here. And NASA has made this data freely available on this using this National Snow and Ice Data Center. And this is how the data looks like. It basically has 21 products, ATL 00 to ATL 21. And these are the various names. So we will be employing ATL 03 photon data. This data, ISAT2 data, has been used for applications in research, which provides fundamental knowledge of how the product's data can be scaled, and it can be integrated to inform the various resource management or the planning or urban flood management. So these are the various applications. And alternatively, there is also this open altimetry site through which I have taken a screenshot over the area of Jaipur, which here you can see the single photon beam, and this side is the elevation profile of obtained from here. So this is how the data looks like. The ATL03 product that we are going to make use of data set from there, it contains the data of time of acquisition, the latitude, longitude, and height of each photon from the track, and other ancillary information which is needed for our models will also be obtained from other products. In addition, we will also be using very high resolution, maybe 4.6 meter satellite data from NRSC for extraction of building footprints. So the motivation behind this is that we need precise digital elevation models, given the scenario in Rajasthan from past few years, that there are cases of urban floods during very high rainfalls, and building height is basically very important for accurate estimation of concentration and distribution of population, and the other models such as the urban heat island effects, building energy consumption, and so on. So this is basically the motivation behind it. The challenges, technical challenges include the noise in the photons. The sensor which emits the photons, it's prone to collecting the photons which are not really coming from per se building heights or any other surface. So I am basically talking about only the building heights here. And then in order, in that, the challenge of how to identify the last photon or the identify the photon coming from the tree or water tank, given the urban morphology, the heterogeneity in the urban morphology, which is containing irregular patterns of houses or therefore the bird's eye view of this urban morphology is important. So retrieval of building height is one of the main which will enhance this. So the problem statement is basically to develop a noise filtering algorithm for classifying the ground and building photon. And second part includes the extraction of building footprint from very high resolution satellite data using the image processing deep learning techniques. And finally, from those footprints, residual DMs will be obtained, and then we will estimate the height from the ISAC2 data. So the objectives here are, as I said, to develop the robust algorithm for noise filtering and eventually identification of ground heating photons in the urban areas using the machine learning, deep learning techniques. And using these photons, we will create residual surfaces which will improve the existing digital elevation models for the parts of the study area, which I will be letting you know in the next slides. And the second part will contain the extraction of building footprints from very high resolution satellite data. For that, we will develop deep learning algorithm. And finally, using these masks, we will estimate the building heights from the ATL03 data. So the first objective will be fulfilled by this methodology. As you can see here, the data from open altimetry will be used. The elevation of photons plus the ancillary information of photons will be used as features. We will be employing both kind of machine learning, deep learning techniques, supervised as well as unsupervised. So in the supervised, we have proposed this LSTM, long short-term memory. And for the unsupervised, we will go for many algorithms like DB-scan, optics, transect, etc. And then we'll compare the result and see which is the best one to, which gives the classification of the photons. For the second objective, once we have identified the photons on hitting the roads in 10 by 10 kilometer area of Jaipur and Ajmer city, generate the residual surface using tools which generate the digital elevation models from the LiDAR data. And then we will calibrate the existing digital elevation models, which are for which we will use the help of CARTODEM.
Dr. Priyanka, can you speed up, please?
Yes, sir. So the third objective, which is development of image processing deep learning model for extraction of the building footprints. So for that also we will compare many algorithms like the CNN convolutional neural network, the multi-layer perceptron, deep belief network, or the segmentation models, and then we will choose the best one. This is the output. And then finally, we will estimate the building height. For this, we will be also using the conventional methods, statistical methods of least square fit, or to encounter such problems of multi-photons on buildings. And linkages. So this proposal basically wishes to extend the work which was carried out by Dr. S.S. Rao and Dr. Giri Babu at RRSC West in Jodhpur. This is the paper that, and these are the clips of their findings. So this project wants to extend this work for their routine activities like supporting regular planning activities, the disaster management, flood simulation, by giving them the deep learning algorithms, techniques that we developed for classifying the photons and estimating the building heights. So these are the publication strengths that our team has. And Finally, the deliverables, we will be the deliverables will include the models, the deep learning models, and the calibrated ground elevation models using the ISAT2 data, the deep learning model for extraction of image, building footprints, and estimation of building heights. So this is the timeline. First year will concentrate on hiring of the research associate, data pre-processing, noise filtering algorithm. Second year will concentrate on two things simultaneously. That is generating the bare earth photons using the previous noise algorithm, and then calibrating the DMs. Simultaneously, we will train the model, the deep learning models using the features extracted from high resolution data. And finally, the third year will include the testing and validation of this model, image processing, and estimation of building heights. This is the budget. So basically the budget is only for a research associate, and the equipment. In equipment, we require high processing GPU because we will be including image processing deep learning algorithm. So we have included one high processing GPU. The data that we require, satellite data, high resolution from NRSC, that cost is there. And internal travel for all the 3 years, contingency is 30,000 for 3 years. Overhead and total comes to 21 lakhs plus 20 lakhs, 14,560. These are the references that I.
Yeah, Dr. Priyanka, I think, okay, we'll move on. I think just to stick to that, 3 years, the Gupta, you feel that for image processing 3 years, and it's a very advanced research area. People are working left and right for every quarterly. We are getting progress in that, even digital elevation model development. Listen, I think 3 years is a too long a period. And I don't know whether you agree with me that quarterly I'm not getting any feel. 1 year, that is the kind of thing.
And a lot of work is being carried out in this direction also.
Yeah,
And
that's I'm not.
Somebody then we can just ask them what is new.
Anybody from NRSC?
What is new in this?
Good morning, sir. Myself, Dr. S.S. Rao.
Yeah, Dr. Rao, sir.
Yes, sir. Actually, we have generated a cartogram at the national level using the CartoSat1 stereo.
Yes.
It is performing very well in the rural areas, and we had a lot of challenges in urban areas because of the building and other things. So we have to improve those them and generate the Bay Earth model for flood simulation modeling and other things. So this ISAT2 basically a LiDAR technology. If you have the aerial technology, we can do, but we don't have globally this aerial LiDAR data. So using this ISAT spaceborne data, we are going to generate the differential surface model. So basically where the regular urban areas and the slum areas, and generate the Bay Earth model. And the second one is the generate the building footprints also. Here the two models are going to come up from this one. One is the using the machine language and building footprint extraction to the maximum with the accuracy. And second one is the Bay Earth model, where the surface model have been connected to the Bay Earth model, so that directly straight away they can use for the flood simulation model. So although under disaster management support program, we are facing in urban areas. So rural areas we have a good confidence, but in urban areas it's a big challenge where you need to have this type of accurate digital Bay Earth model. And this will give a good impetus and some algorithms, deep learning algorithms, A&M algorithms to improve the existing dams so that we can operate our DMS program and operationally across the country, particularly in urban areas, which is basically posing a big challenge nowadays.
Okay, just.
And second point, sir, as per you mentioned, 3 years, maybe I think we can reduce time. I think with the straight away they can start, and that is your observation is right, sir. I think time can be compensated.
Dr. Rao, just one point I discussed with Dr. Gupta also, Dr. Namta also. All of us very strongly feel that I think 3 years is too long a period. And yes, of course, the two models which are coming up is the deep learning model. I fully agree. Only I don't know what is the logic behind I set two into picture. We ourselves have radars based this thing imaging. No, why we have not adopted that? And Dr. Priyanka can take the support from there.
Yeah, basically radar things point is right, sir, but there are basically in urban areas, because of the building, other things, it is a noise. So we cannot do. Whereas LiDAR, basically, they look like a near nadir images. So we can exactly get the building road as well as building separately.
No, but
And
the problem,
area
Dr. Rao, the problem is our own spacecraft, so many images, so many resources are there. NRSC cannot tell that our model also to be tuned, no. It should be trained
Good,
so
sir.
that.
Good, sir. No, good, sir.
We are
Because
taking-
the building is there, building will overlap onto the road and other things because we have the perspective view. This is more or less a nadir view, and the LiDAR technology will give a more accurate digital surface model, particularly in urban areas compared to the rural areas. We don't have any problem. Cartodome is working very well. But urban is a big challenge where microwave and other optical data is failing, where LiDAR technology is going to give a better accurate and results, sir.
No, hypothetically, just last question from my side to both Dr. Rao and Dr. Priyanka. Tomorrow, hypothetically, suppose they pull down the services from providing you the data ISAT. How you are going to work for 2 years? Anyway, 3
Already,
years
sir,
is ruled out.
Already
yeah,
it is-
agreed, sir, madam. So already, sir, the last 4 years, the satellite is performing. We have a good data. Archives data is there. So that we can get it, sir. Yes.
Okay. I think Dr. Priyanka, all of us here feel that 3 years is a longer period.
Yes, sir, I'll reduce it. With discussion with Rao sir and other team members, I will reduce and compensate the time.
Definitely, because Rao sir and team, they are really working very hard to get all this. They're having expertise. They should have cut down. I think this should be restricted to 2 years. That is my proposal. And I think even budget also.
Accordingly, sir, it will come down to 15 lakhs, 15 to 16 lakh. Yes.
Yeah, that's what I was thinking exactly. So, Dr.
Yes.
Priyanka, I think it's a good work.
Yes.
Only thing is, I have only 2 reservations, which I pointed out, and Dr. Gupta and Dr. Damita also opine in the same direction. So, we'll cut down 2 years, and it will come down to 15 to 16 lakhs. We look forward for your new modules. Thank you very much.
Thank you, sir. Thank
Wish
you.
you all the best. Thank you. Any other member, any comments, please come forward. Dr. Vrinda? She was there in his track.
I think there is no.
Okay.
We can go ahead.
We can proceed for Dr. Patnaik.
Yes, sir, we can proceed further. The discussion has been very apt only.
Okay,
Thank you.
okay. Okay, Dr. Vrinda. No, I was thinking from his track experience whether my statement of ISAT was okay, or we can really ask ISRO to support for that. That's what I was thinking. Okay.
Sure.
Yeah, Dr. Patnaik.
Sir, we'll start, sir.
Yeah, please.
Okay. So, very good morning. And this is our topic that project proposal, development of ultra high precision sub-micron level measurement facility for measurement of coefficient of thermal expansion for dimensional stable composites. Myself, Dr. Amar Patnaik, and my co-investigator, Dr. Vikas Kutsal, and mentor from Vikram Sarabhai Center, that is Sri Kalyan Raman. So the main informations what we have received from the different research papers, that how we will find out the coefficient of thermal expansions, because it plays a major role to find out the new composites as well as in a different positions, different orbits or in a different space. So we followed that chromatic confocal technology, which will use it and to find out the coefficient of thermal expansions. And the ranges we will follow, that is 400 nanometer to 700 nanometers. And recently developed a few confocal micro-optical chromatic sensors that also we have taken into consideration. And this is our main objective, to find out ultra high precision measurement facility with sub-micron level capability for measurement of coefficient thermal expansion for dimensional stable structures. So there are few research papers we have taken into considerations while developing our own model. That these are few raw, and they have certain things they have developed by using this confocal achromatic lenses and LED, how the fiber couplers will work, and optic setups. All these things we have taken into consideration also, and we have modified our own. What we have planned, that we will develop our own algorithms, as well as our own setup for that. And these are the basic motivations behind it, that simultaneously will take it is auto average functions also, because it will take at a time 3 different readings, and finally it will give you the average of all these 3 different readings. So the design what we have planned, that this is the sample size is in the range of 1 centimeter to 10 centimeter, and width also 1 centimeter to 10, and thickness 1 centimeter. And the vacuum based the hot air oven, that is 12 into 12 into 12 inches, and the operating temperature lies it is 30 to 50 degrees centigrade only. And this is the means pro station that we will put it inside the hot air oven. And the counter plot that we will fix it at the upper surface of this oven only, and it will 4 different coils are exactly means equidistant from each other, so that we will measure our sample, because the measure important is that how we will put our samples, and is there any dislocations, or it will move in which direction. For that our measuring devices is that all these 4 coils are in the equidistance from each other. And this is our main plan, that how we will develop it, that is the source of white light, that is the LED light, then it will go to the fiber couplers through which achromatic lenses are there, and 50 to 50 50 to 50 the splitter is there, that it will 50% will come to the optics and diffractions, and then it will fall on the composite surface, and remaining 50% will go to the spectrometer. Once that is the arrangement is that the convex lens and the gating is the wall of the oven, and the collimator lens it is exactly in the wall only. We will not put anything inside the oven, so that as it is a vacuum, simultaneously the temperature is once is a major concern. So because of that reason, we will put our collimator lens exactly in the wall of the oven only, and that the main and the monochromatic light, once it is fall on the surface of the composites, then it will return after reflections. It will go to directly through the fiber couplers to the spectrometer. There it will analyze the frequency ranges of different as far as the VI, VG, YOR, that is the 7 different colors. Accordingly, the frequency range will fix. And what we will do initially, the initial length of the composite will fix it 0.1 meter, and we'll bring it to 40 degrees centigrade first in the initial conditions, and then it will make it 600 nanometer peak is detected through the spectrometer. And after that, we will increase to that temperature to 43 degrees centigrade. So that's why the temperature difference is constant as far as our record is. And based upon the frequency range, we will find out the distance also between these 2 ranges. So we will use that formula delta L equal to alpha into L into delta T. So through that, we will find out the alpha, that coefficient of thermal expansion. So these things already we have discussed with Kalyan Raman as well as his team also. And these are the procedures what we are going to develop for the instrument, because major part is the instrument development of the instrument. So the hot air oven is 12 into 12 into 12, and we will optimize the focusing the divergent beam on the composite surface will be carried out, and 3D printed module for supporting the optics and integrated parts of the fibers, light source and detectors. And our main part is the software and development as well as the development of the oven, and the preparation of the Gerber files to the PCB fabrications. Once we reach that level, then we will validate that instrument using ISRO's data and testing instruments at the ISRO centers, and varying the field conditions and analyzing the results, and validation of the instrument by testing more than 50 different samples what we have planned. And finally, we will go for the certification of either NABL or BIS. As far as our discussions only, these points has been included. And the linkage and relevance with ISRO is that the composite samples for ISRO are required for validation of the instrument. The samples will be tested using the prototype, and the results will be shared with ISRO. And finally, the instrument will be moved to ISRO facility, and the prototype will be tested by the experts only. Our expected outcome is that customized optical sensors and detectors and modules for supporting optics and detectors, and the hot air thermal chamber that we will also develop, and the software for data acquisition of CT and CME that we will study. And additionally, if permits time, we will go for also analysis of coefficient of moisture exposure of the hydroscopic structures. And this is the budget for consumable 10 lakhs and human resource 7.5. Contingency means consultancy work, that is fabrication of the lenses of Indian industries in related to consulting service, that is 5. So the fact by means the first year we are claiming the 15 lakhs and second year it is 11 lakhs only. And after last discussion with his team, they mentioned, as you mentioned, the fabrication component. Our fabrication component is 15 lakhs only. That is the cost breakup of the instruments and its development. Vacuum outbase, that is hot air oven and light source laser scheme, and goniometer and probe stand configurations, lens and diffraction unit fabrications, and other electrical related cost. This is the, in total, it is 15 lakhs only. And this is the milestones we have mentioned for the 2 years. As far as the milestones, we will complete our work. And this is the references through which we inspired and we have developed the works only.
Okay. Yeah, thank you, Dr. Patnaik. I think anybody from CMSC are there? Kalyanam? Okay.
Well, somebody will be there from BSS.
VSSC, anybody is there?
I'm seeing from Santosh.
Santosh? Santosh is there.
Ma'am, they're trying to log in, ma'am. Please allow them to present.
Please allow them.
Somebody is waiting.
Yeah, Santosh from BSS. BSS, somebody is there?
Ma'am, it will be like in the name of conference hall, ma'am. BSSC conference hall, like that it will be there. Please allow them.
Are you in?
Yeah.
Stop sharing. Yeah, please proceed. You are already in. Am I audible? Is it muted or? Am I audible?
Santosh?
Because check.
Other one, what enabled is ISRO headquarters conference hall.
CMSC also is there too. But CMSC, you are muted.
Vikas, you are not audible.
Santosh.
आवाज नहीं जा रही क्या? जा रही है. Nobody is replying.
Can anybody respond? We are audible.
Yes, please, sir.
You are audible to me, sir.
You are audible.
Sir, this is from CMSC, sir. You are audible, sir.
Okay, you heard the previous project about the measurement facility. Any comments?
Sir, this from CMSC, I'm the coordinating person. This proposal is very promising, especially since it is a non-contact measurement. So we had some queries and they have replied to that also regarding the concerns related to how good they can maintain temperature within plus minus 0.5 degrees centigrade and size of the specimens. So only thing, since here this bandwidth is limited only to 400 to 700 nanometers for a delta T of 25 degrees centigrade. If specimen size is exceeding 1 centimeter, then deflections will be exceeding 400 nanometers. So we request them to limit the specimen size to 1 centimeter.
Okay.
And, next thing, if specimen level it is working, we request them to extend the same thing for bigger projects. So there the sensor has to be changed to some other wavelength so that the bandwidth will get more. Because if we go for structures of 1 meter length, then our expansion also will be higher. So with 400 nanometer, we will not be able to measure the final expansion. So they can think of how to extend this for larger structures.
Okay, sir.
Otherwise, it is a very promising proposal, sir.
I have just two small query from my side to you. See the kind of material composite you are looking for and its application in the satellites or in the vehicle side. Range of temperature which you have given is 30 to 50, while we have very wide excursion, right?
But actually, in general, CT we need for geo very wide temperature, but mostly for camera structures, since thermal control is there, plus minus 15 degree only is the operating temperature. So we just want to characterize the material for this operating range only.
Okay, so you are restricting it to only for optical instrumentation, is it?
Correct, sir. Only main requirement is for a CT measurement of dimensionally stable structures. If this bandwidth is higher, then same technique can be used for the raw material CT measurement also. There we can go for higher temperature range.
Okay, so we'll quickly. Only budget perspective.
Yeah, manpower and all in different projects, different amount is put actually. JR means the 31,000 plus extra.
16%.
Yeah. No, 16%. No, not 16. No, 9, 18, and 27. Now HR is increased now. 9, 18, and 27 is the percentage. Here they have put only 3.75. That is very less actually. It will become almost double that. So budget will be revised.
Okay.
31,000 plus HR they will get. Yeah.
No, but just one small that 15 first year and 11 second year. If you just see last two rows, 26 lakh, he has split into two parts. First year 15 lakhs is asking. Second year is asking 11 lakhs.
Yes, sir.
So I am consumable once it is over on first. Second year it's only salary part, is it?
Yes, sir. This is the equipment part, sir. Because 15 lakhs nearly we have to purchase all these components only, sir.
Agreed. Patnaik, what I'm telling is 15 lakh first year seems to be okay.
Okay.
I'm finding almost everything is in line with including optics and that source, light source and all that. It's to the tune which we expect that. But second year, when all these things are ready, second year 11 lakhs to the same tune, why?
Sir, I believe that the procurement is split into 2 years, sir.
It is in two parts, sir. Procurement is in two parts because at a time we can't develop all these things. First, we'll go with the development of ovens and other things, and second part we'll develop it other.
But second year,
it is not.
Second year it is not. So I'm not very comfortable.
So your budget you have put a consultancy. Consultancy is not allowed under.
Consultancy means it is a fabrication of lens, sir. It is not
consultancy.
No, you don't
removed first.
Don't put it like that. Otherwise, it gets rejected.
Sure.
Internally, also you'll be reviewing and removing this consultancy part. Okay. Yeah, fabrication only is allowed.
It is fabrication only, sir. It is fabrication.
Not somehow
outsourcing. And what's your meaning? Outsourcing by consultancy.
It's because of, sir, there are in MNIT, I'm basically from MNIT, so there are startups are there. We are working with them.
Can you come little closer so that source listening voice can be heard?
So I will remove that word consultancy.
Yeah, you please explain if there is any specific reason for putting this head consultancy, because in research projects, as such, no consulting amount is allowed. So please explain as to what this consultancy really mean.
Sir, here that we are planning to fabricate a lens. So it is a fabrication of lens only, sir, but we will remove it, that concept. Otherwise, there is no other reason.
It looks it's outsourcing. Maybe a part of fabrication you are outsourcing because we don't have the facility. So
yes, sir.
Put it under outsourcing, not the consultancy.
Yes, sir. Yes.
To put us
charges. Fabrication charges.
Sure, sir. I will do it.
Like L1 or something like that. The procedure to be followed for the government of India service.
Exactly, sir. Exactly, we'll do it, sir. No problem, sir.
And I think 11 lakhs breakup I'm not able to see. I'm not very comfortable with the 15 and 11.
Breakup to be given properly.
Yes.
Sure, sir. That justification I will send.
Internally, I request Dr. Gupta and Dr. Namita to re-look and revisit this 20 lakhs. I think this is not okay. It's a too high number for second year. Already everything is smoothly conducted in first year, second year, many other things gets normalized. So I think whatever figure Dr. Gupta and Dr. Namita tells, that will be communicated with the appropriate correction. Okay?
Okay, sir. Okay.
Right now, I'm just from my side, I'm limiting to 2 years and 20 lakhs. I think final figure will come after their review. I'm just limiting to 20 lakhs. Okay, thank you. Thanks a lot. I think this is one of the good facility which may come up in case that. So try to complete it well within time so that you can take it up and enlarge the scope of the assembly and support VSSC, our composites.
Okay, sir. Thank you, sir.
Thank you.
Thank you.
Thank you. Good.
Okay, sir.
Thank you, sir.
Any comments from any other member? You please interrupt and offer your comments, please. Okay, we'll move on to next one. That is Dr. Ravi. Ma'am, this is action on you. You have to review this. And
Yeah.
It's one of our best researchers.
that no, it's very good. I think this is if that comes up. Dr. Ravi, are you there?
Yes, sir, I'm available.
The project 2 years back. Since then, he's working.
No, right now we have specific optical payloads. So there with this is really good. I was thinking he's also using for geo for larger that
Designed for seeking the higher temperatures, like
wider.
NOx and other things can be converted to medical applications inside the plant.
Yeah, just review it. I think Ravi is not. Ravi, Dr. Ravi, are you there?
Yes, sir, I'm available. Yes, yes.
Yeah, can you please start little?
Recording.
Share his slides.
Am I audible or am I visible?
Yeah, Ravi, you are audible. Please proceed, Dr. Ravi.
Yes, sir. Yes. So this is a proposal on integrated application of in situ monitoring.
Dr. Ravi, can you come closer to mic?
Yes.
Speak a bit louder.
Yeah, slightly louder.
Otherwise, I'll use my headphone.
Oh, that's okay.
No, it's okay. Now it has come out well. Yeah.
Okay. Yeah. So this is about collaborative work between IIT Jodhpur and MNIT Jaipur, and we also have the project collaborators from VSSC, Dr. T. Venkateshwaran and Dr. V. Anil Kumar. This project is about in situ monitoring for understanding the defects formation during additive manufacturing of Inconel 708 and 7075 aluminum alloys, where we use CalFAD modeling as a tool also to use for a prediction of this porosity and hot tearing defects during this additive manufacturing process will actually predict. Initially, this proposal was submitted for 3 years with a budget of around 28.95 lakhs. And based on the inputs we received from Dr. Venkateshwaran and Anil Kumar and their team, and we have actually reduced that objective. In fact, initially it is prediction as well as mitigation. Now it's only the prediction part that we will do in this project, and the timeline is actually reduced from 3 years to 2 years, and the budget also revised, and it has been revised to 22.84 lakhs. So only that part I am making presentation. So when you talk about additive manufacturing, metal additive manufacturing,
Dr. Ravi, just a minute. Dr. Ravi, just a minute.
Yes.
You are telling a budget is revised. You are telling in 3-digit figure. How much you told?
22.84 lakhs.
No, you revised it, right? 3 years became 2 years.
Yes.
And budget?
Budget from 28.94 to 22.84.
No, 3 years has changed.
Earlier it was 29.
Dr.
Now
Venkateshwaran, PSSC, based on our internal review, we have given us a recommendation to revise the budget as well as the years.
okay, fine. I think okay, there was some small correction here. Okay, go, yeah, proceed, Dr. Ravi.
Okay. Yeah. So when you talk about metal additive manufacturing, which has a huge potential in space research, space application, but again,
just a minute. I think there's some. Then the scope of the proposal also changed it.
yes, sir. Yes, sir. Objective I have minimus. Initially, it was prediction and mitigation. So now I am doing only prediction part in this project.
But here is shown both. It's a mitigation is removed now. It's only predicting.
Yeah, but if you can look at the approved document by Venkateshwaran and then Anil, in that even the document which I received, it consists of means the revised one only.
No, I think some correction is required. Okay. Even approval also it says scope is predicting and mitigating. Now it is he's only concentrating on predicting.
Mitigating plus we had added.
And also one alloy also we have changed. Initially it was aluminum 10 magnesium. Now we have told to change to 7075. That is more crack prone. So that also we told them to change.
Yes, yes, I forgot to mention.
Okay, then I feel there are 3-4 corrections are there. So I request you to immediately submit it to MNIT, the corrected form, because budget is changed, timeline is changed, scope is changed. So in all the 3 aspects, I feel a revised one should be submitted and that will go to our headquarters CBPO.
Okay, okay.
Okay, now you can proceed because scope itself is altered, so neither we can take the scope itself. Okay, proceed.
Okay. Okay. When you look at additive manufacturing, as I said, it has a huge potential in space research organization. But getting the repeatable microstructure and mechanical properties is a huge challenge in additive manufacturing because it has a lot of process parameters which we need to optimize. It's all interrelated, which actually is costly and time consuming. Traditionally, people do by trial and error method by doing optimizing the process parameter. That's the one way of we call traditional destructive methods. You make samples and do testing and finally optimize the parameter. So this is a way actually people are doing. It usually takes for any alloy around 3 to 4 years to arrive an optimum process parameter. So the alternate approach is through the mechanistic modeling approach, one can actually do the prediction. But the issue with this kind of approach is that you will get very small build volume information, not for the large size component you will be getting. And again, the simulation takes a long time. That's where actually we are trying to introduce the techniques called in situ monitoring technique that also will combine with this modeling technique so that can accelerate this entire process of defect prediction, and that would help us in getting repeatable microstructure and mechanical property. In this particular proposal, as I said, we are going to take Inconel 708 and 7075 alloy. Both the alloys are hot tearing prone alloys. So prediction of hot tearing susceptibility, in this case we will use non-contact pyrometer and thermocan dicto software. Then acoustics. This is the one approach through which actually we'll predict. This is also another approach where these two are different approach. Both are in situ monitoring combined with the modeling approach. We can actually predict the hot tearing susceptibility not only for an entire component, each layer also can be predicted. That I will just show the thing. Another thing is the solidification structure, because this actually has a huge impact on the final mechanical property of the material. So that also will be predicted using this non-contact pyrometer and thermocal, because the information what we get in non-contact pyrometers combined with the thermocal, that also can give us information about the what kind of solidification structure we will obtain. Another important defect which we usually encounter in additive manufacturing is porosity.
So that defect will be predicted using the acoustic emission. Acoustic emission is an in situ monitoring tool. Then we use certain signal processing technique to minimize the signal to noise ratio, so that you can actually predict the porosity during, not only predict the porosity and the location, precise location of porosity formation during additive manufacturing. This is the overall objective. If you look at this particular the methodology what we are planning to adapt is in a direct energy deposition experiment. It is a indigenously we developed a setup which I will show a little bit later. In this setup we will have pyrometer. It will be non-contact pyrometer. One pyrometer will be two wavelength wave pyrometer, another one will be a multi-wavelength. Two wavelength pyrometer is useful for inconel based alloys, and multi-wavelength pyrometer will be useful for aluminum alloys. Through this process, we'll get a cooling rate, and we also get a cooling curve. We'll get a cooling rate. Then once you get cooling rate, that can be given as an input along with the secondary dentate arm spacing in the CalFAD and DICTRA model. So that can predict the solidification behavior. That means the solidification curve, we can actually get it. At the same time, once we get this cooling rate and temperature gradient in the material, so with this one you can connect and you can get the solidification velocity. So once you get solidification behavior simulation, solidification curve through, again, if you are by using hot tearing model, one can predict the hot tearing at every layers. In fact, it is every layer is not possible. Maybe this process takes some time to get the data. So we can actually do every second or third layer, we can do the prediction. So another thing is once you have this composition profile and solidification curve, we can generate solidification map. That is what finally you'll get a solidification structures will be getting. While depositing, it's using this in situ monitoring tool of pyrometers. We'll be getting this hot tearing as well as solidification structure will be getting. At the same time, we can also use this acoustic emission sensors that can predict the porosity as well as hot tearing location, or hot tearing thing can be predicted, so that both can be validated in this particular experimentally. Also cross verifying with the microstructure we can verify. Also this acoustic emission in situ monitoring, it means during processing itself we'll get this information. So this is the indigenous setup that we developed for metal 3D printer based on direct energy deposition technique, which we developed for one of our DST project. This is a setup that we will use for this particular project. It's a completely open system where we can have a complete control over this machine. So we can put any sensor, actually we can actually control it. So in this setup, as I said, we need two sensors. One is a non-contact pyrometer. I'll show that how it will be connecting here. So we'll place a non-contact pyrometer that would actually continuously measure the temperature. From that we'll get a cooling curve, cooling rate and cooling curve. Other sensors will be integrated here as an acoustic sensor. It's a it's a two sensors we use, so that you can precisely locate the porosity locations also. Hot tearing location also can be predicted. So how we'll do the hot tearing prediction, which will I try to explain it here. Using this pyrometers, we'll get the we vary these parameters like scan velocity, this laser power and powder feed rate. So with that you can actually get the at a different parameter condition. We'll get maybe even at a constant process parameter also, for a different layer it goes through a different heating and cooling cycle, means it goes through a different heating and cooling cycle. So then you start getting this kind of thermoanalysis curve. From this thermoanalysis curve, one can actually cooling rate can be measured, and secondary dentate arm spacing is already available in the literature. Both can be given as an input to the CalFAD. So that would help us in generating the solidification curve which is very important, which can be used for many different applications. Through this process, for a different cooling rate, we will calculate the solidification structure. Then we use cow model, which can this model can predict hot cracking tendency of an alloy for different cooling rate. Means different parameter for a different cooling rate and different solidification rate, we can actually predict the hot tearing tendency of a system. Because in
Dr. Ravi, can you speed up, please? Dr. Ravi?
Yes, yes, sir. Yes, sir. So another thing is in acoustic emission technique also we can get this predictions using signals, so that we can actually predict the hot tearing. Similar way, as I said, we'll use a same pyrometer signals will be used and combined with the CalFAD and simulations of using COMSOL. One can get the solidification structure. And porosity prediction is something which is a little bit tricky. There you need a lot of signal processing because the size of porosities are small, so that you need to do a lot of signal processing because the signal to noise ratio will be somewhere around 4 to around 4 to 5. So you need to do a lot of signal processing so that you can get the porosity using this two sensor mechanism. So this is the current setup. Actually, we have already done some few trials using single wavelength non-contact pyrometer, which is actually it is already integrated with the system. And we also have for a height monitoring, we have this CCD camera, and for a low temperature material like aluminum alloy, so we have IR camera which can actually get the data. Currently, this dual wavelength and multi wavelength actually have funding, so that through that funding, I'm getting the those two more setup, which is actually required for this project, but it's I'm getting from some other project. So this is actually then acoustic sensor is the only one which I am asking as an equipment, major equipment in this project. So these are the preliminary work actually we did in this particular using this setup. Actually we did for aluminum alloy, especially for a 7075 alloys. Not with the non-contact pyrometers. So using, because we don't have that, we have used a simple contact-based thermocouple, and instead of adding powder, we for a laser surfacing we did this particular analysis. There we got this different cooling curve. Then these are the secondary dentate arm spacing we measured, and some of the secondary dentate spacing available in the literature. That these two information given to the DICTRA simulation, thermocal DICTRA simulation, that generated this solidification curve. From this solidification curve, we actually calculate the hot cracking index of alloy. You can see this in this particular system. This particular cooling rate gives the highest hot tearing tendency, that is experimentally validated. You can see that it gives a hot cracking tendency. But what we are finding it, there is a lot of variation in cooling rate. So that is what now we are trying to figure out exactly what could be the reason why there are certain variation in cooling rate for the same parameters. So that is what we are working on. So the linkage to space program is this particular additive manufacturing technology is being used for production of various components, and it will be used for already ISRO has a focus on developing passive and active launch vehicles and dooms and grids, and I think many more components and functionally graded materials using this metal AM process. So, but in those cases we need repeatable and reproducible microstructure and mechanical property with a minimal defect. This is actually for any manufacturing process which is essential, but it's more so with the additive manufacturing, because layer by layer process you're bound to get a lot of defect in this particular process. So this help this work will actually help us in optimization of parameters and identification of defect in a much faster way and smarter way. So what is the deliverable is the process know how to predict the porosity and hot tearing formation during additive manufacturing of this Inconel 708 and 7075 alloy. Identification of ideal process parameter for Inconel 708 alloy and 705 alloy without defect of hot tearing and porosity can be understood what kind of parameter one need to use, and we can generate skilled manpower, minimum 1 PhD and 1 MTech. This work can lead to 2 to 3 journal publication. Also, it can give patents if actually if we get time, I think this can be, some of these sensors can be made into product also. So that is a long-term process. So this is actually the revised budget. Initially it was 28.94 lakhs. It was for 3 years. There we had for equipment around 18 lakhs. We have put now some of the equipment we are also getting in another project. So what we thought is we didn't put any manpower in that one. Now in the revised budget we put a manpower, and this is the overall budget. And only the acoustic sensor is the only one equipment that we are asking in this particular project. The consumable cost is little high because these powders, what we use for Inconel 78 and 7075 for this particular project, it's a very costly material for additive. The powder cost is huge, so we are the consumable cost. Other than the powders and many of those consumable used for additive manufacturing is also costly. So this is the overall budget. So this is the timeline of activities. The procurement of materials and individual components. Only the one acoustic sensor we are going to purchase, so that can be done in 6 months time. The integration of pyrometers, which already we have done for single color pyrometer, which same can be extended for multi-wavelength and dual color pyrometer, and the acoustic system integration, something that we will do in 6 to 12 months, and then the porosity prediction using acoustic sensor, hard tearing through caliphate approach, which we already initiated for few layers, and hard tearing using acoustic emission. So these are the work that we will do in the next 24 months. This is
Okay. Thank you, Dr. Ravi.
Yes. Yes.
Take a comments. Dr. Yeah, I think from VSSC remarks.
This is Dr. Venkateswaran from VSSC.
Yeah.
Sir, this project is highly innovative, this project work, and it's a novel idea what Dr. Ravi was come up with, and it has been not attempted anywhere else in India. And this input is going to be a very valid, vital input for our, we are, as you have heard, we are going to get a DED machine by next year. The same model, all these things can be used in our machines, and it will be useful for producing parts. And as initially noted, there are few, this proposal was thoroughly reviewed in our MME, and we have suggested in cut in budget as well as the correct alloy also we have told Ravi to change it to capture it. And also that mitigation part also we eliminate, because this prediction itself will take 2 years. Because a lot of iterations he has to do to exactly capture the right type of cracks, especially in the acoustic emission of predicting porosity is a very challenging job. And also we told we will be supporting our expertise using our acoustic emission people also here. So concerning all this, we strongly recommend this proposal, sir.
Okay, Venkatesh, thank you very much. I think just only 2 points I wanted to touch upon. That Enconal powder, are we planning to use in our whatever facilities coming up in VSSC?
Yes. Already we have lot of stock of Inconal powders. Right now we are going outside facility using our powders. We are printing and bringing it, sir. Dr. Anil Kumar is extensively involved in the production part of it, sir.
Okay, fine. So another any aluminum alloys that you have incorporated. This Calfed, is it imported one module or software?
It is a software, sir, basically.
That's what
Actually, the point on here is actually a metallurgist with additive manufacturing. Calfed, Comsol, a very rare combination you can get in any institute. Dr. Ravi is a blend of person having this all type of combinations.
Okay, so I think no. Then why did you stop the scope after prediction?
No, actually, it will extensive work, sir. It will take minimum 2 years. So after that, if everything is properly predicted, mitigation we can come as because not the ultrasound equipment, some extra equipment to be added for that. So after seeing this, we can go for the next proposal. We can, that is the way we give the recommendation, sir.
Okay, fine. I have no issue.
That will be modified, right?
Yeah.
Right, it will be modified.
All three, scope will change, budget will change,
So
revised.
Revised proposal.
After their review, they'll send it to you.
Okay.
Okay, so I think they will be reviewing once again. So that, okay, thank you, Dr. Ravi. I think.
Sir, in the budget part also, sir, they have not added HRA, sir. Sorry, BA. So
Yeah,
please try to add.
That's okay. That is to be added.
Yeah, that I think Dr. Paul has pointed out. So he told that they'll discuss. That's why I kept it under review. Then only it will be taken up for the final one. So once Dr. Gupta and Dr. Namita review it thoroughly, then only it will reach there. At this point, it will be touched upon. I think this 22.84 may slightly go up. That's what I am feeling. Anyway, once they review it, will.
To be given, obviously, yes.
Yeah. Okay. Okay. Thank you, Dr. Ravi. We'll switch over to next one.
Thank you.
I again request to maintain the timeline up to 10 minutes, please. It's exceeding everywhere 2-3 minutes. Now we have already crossed 15 to 20 minutes time now. Yeah, Dr. Kanu Priya.
Yes, sir. My slide is visible, sir?
Not yet, ma'am.
It's visible now, sir?
No.
Sharing.
No, I think you need to be given the rights for presentation. Because please give her rights to present.
She has rights.
It's not visible actually in my screen.
No, maybe it's.
Is sharing.
Now she has got it. Now. Please, madam. Madam, please.
Yeah, we can see it now.
Now it's there?
Yeah, we are able to see it. We can proceed, ma'am.
Sure, sir. So, good morning, everyone. The project proposal is about the performance exploration of LTMO and vertically aligned multi-volt CNT on graphene material for efficient and sustainable sodium-ion batteries. The co-PI or the focal point appointed by ISRO in this project are Dr. Sujata S. and Shri Prabhu VR. Commenting about the background of the project, we all know that the LIB technology is well established and there is a successful commercial application of lithium-ion batteries. But the constraint of the security, constraint of the scarcity of these resources, and not only that the resources are scarce, the other problem is that they are concentrated geographically in very small areas, like a very few countries all around the world. So there is a much control over the production and supply of lithium as well as cobalt. These two elements are facing this. And hence there is a big need that these lithium-ion battery technology has to be replaced by some other battery. And of course, the batteries are much more needed in this scenario in lots of applications, which go from electric vehicle to big grid storage as well. And because the sodium and the lithium ions, they are in the same group. So the sodium ion battery is one natural and safer alternative candidate. They have comparable redox potentials and similar intercalation chemistry. But at the same time, there are many differences as well, which need to be addressed. And the sodium ion, advantages of going to the sodium ion is because the material is abundant and that makes it cheap as well. The working principle of the sodium ion battery is the rocking chair principle. And let me go to the significance of the materials which we have chosen for the proposed battery. So our cathode material is LTMO, which is the layered transition metal oxide. And this material is one of the favorite materials being chosen for the sodium ion technology. And the USP of the material which we have proposed is that it is cobalt and nickel free. So it is consisting of materials which are earth abundant and cost effective. It offers the advantage of large surface area and short ion diffusion channels. The Already large number of people have done work for the sodium-ion batteries, and it shows a high electrochemical performance with specific capacity ranging from 100 to 180 milliampere hour per gram and a rate capability of 89 to 110 milliampere hour at 1C. Now, these layered transition metal oxides, they show mostly two types of structures, which are O3 and P2. And these O and P, they refer to the position of the sodium ion, whether the sodium ion is at the octahedral site or in the prismatic site. And 3 and 2, these number, they refer to the number of the repeating units of the metal oxide series, metal oxide layers. So people have worked, large number of researchers have worked, and mostly they have used either O3 or P2 phase materials for the sodium-ion batteries. Recently only, it is seen that combining these two phases, because each phase has its own advantage, and we also propose here a biphasic material, which is a biphase of P2 and O3 hybrid material, and it offers the synergistic effect of the P2 phase. The P2 phase, by virtue of its structure, it offers fast diffusion of sodium ions and improved air stability and higher kinetics. Whereas the O3 phase, it gives higher electrochemical performance in terms of the energy density and coulombic efficiency because of the higher sodium content initially. And what we have proposed here is that we will be doing partial doping of lithium, because what people have done is they have combined, some researchers have combined P2 and O3 phases. They have synthesized them, grown them, and then mixed them. But instead of doing that, if we have a natural evolution of both phases simultaneously in the material, then it shows superior performance as compared to the mixed phase. So we propose addition of lithium, and it is seen that the partial doping of lithium leads to a biphasic material, and titanium is added to increase the resistance to moisture, because these materials are prone, they are very sensitive to moisture, and to prevent phase transformations. So compared to the lithium-ion battery technology, the sodium-ion materials have shown complex phase evolutions during charging and discharging, and there is a need to somehow restrain the complex evolution of phases, which gives you a better performance of the battery. So it is seen that adding titanium prevents phase transformation and makes it air stable as well. The anode material, so the anode which we have proposed here is a doped, vertically aligned multi-volt CNT RGO hybrid. Now, in lithium-ion batteries, mostly hard carbon or graphite is used. Now, this anode material, which is the proposed anode material, is expected, and even the literature reports are there, that it shows a better performance compared to the hard carbon anode, which is normally used for the sodium-ion battery. So what we propose is that we are going to grow a three-dimensional hierarchical structure, and it will be a doped vertically aligned CNT grown on RGO that is going to provide a high specific surface area and adequate pore spacing, which allows the movement of sodium ions into the anode and out of the anode. That means the intercalation and the de-intercalation during the charging and the discharging. Our group has good expertise on growing single layer, multi-layer, or a few layers graphene, as well as producing RGO on a large scale basis. And we have in-house a split furnace, CVD, which allows us to grow these materials as well as dope them. So we are proposing doping of heteroatoms, nitrogen, boron, sulfur, and phosphorus, which leads to increased electrolyte-electrode interaction. And we have seen that doping of these heteroatoms in RGO and as well as CNT increases the electrochemical performance of these materials. So the objective is to first prepare the cathode materials. And the cathode material, as suggested, is the mixed P2O3 phase of NaXMO2. And the material proposed is sodium with copper, iron, and manganese. So we have deliberately not included cobalt and nickel. So we want to make them cobalt and nickel free. These materials are abundant and they are cheap. And it is seen that addition of copper, because iron has a high redox potential, so it is useful to add there. And addition of copper makes the structure more stable as well as increases the stability with respect to moisture and air. In the anode, I think I've just explained the anode. This proposed anode will be fabricated using a split CVD, and which allows us to grow this material. And what we are going to do is that when we have this geo, which is synthesized by the usual Hammers method, then this geo will be doped with nickel in a hydrothermal method, and this nickel provides the growth of CNT, as well as there will be a one-step reduction of RGO in the synthesis of this material. Now, because the current collectors play an important role in the overall performance of the battery, so we propose that the stainless steel current collectors will be coated with single layer graphene. As I already mentioned, we have optimized the process of growing different numbers of layers of graphene in our CVD. So these current collectors will be covered with graphene, which gives us a reduction in the overall series of the resistance, as well as it gives us greater wettability. The polymer which we have proposed and which we are already using, because the group is already working on sodium ion supercapacitors. So we are using a gel polymer electrolyte, and this we have developed and optimized its concentration in-house. And this gel polymer electrolyte has many advantages. It does not have any free-flowing solvent, so it prevents these issues such as this leakage and the associated flammability of the batteries, which is like a big problem with lithium-ion batteries. And it also allows you greater wettability, and that is how it increases, and of course a wide voltage window as well. And then the next step will be to do the mass balance optimization. When our project was sent back to us with some recommendations and some queries, then we were asked for that what will be the mass loading for the anode and cathode material, and we have done that as per the performance of both the materials. So mass balance optimization is a key factor to gain the high energy and long life of the battery. So the motivation of this proposal is to overcome the main...
Dr. Kanupriya ma'am, can you speed up please? We are very slow.
Go to deliverables, sir.
Can you concentrate, otherwise
Let me go to the deliverable. Okay, I have already explained the materials and the methodology.
Right.
So I'll go back, I'll skip the methodology, and these are the characterization techniques and device fabrication. Yes, these are the deliverables. So before going to that, I would just want to mention that because the ISRO has an initiative of boosting the in-house or the indigenous production of batteries, so this proposal is in line with that initiative. And these are the deliverables which we will be providing at the end of the project, and of course during the project as well. So the output in volts of the SIB prototype will be 12 to 24 volts, which will be having 4 to 8 cells. The size is given. Then the ability to hold charge and depletion rates is 1% decay in a month. The life cycle of the prototype batteries should be not less than 1000 cycles. Energy density of the complete battery is 150 watt-hour per kilogram. When we look at the cathode and the anode level electrode performance targets, then the cathode should have a specific capacity of 200 milliampere per gram, with a stability of 90% at 500 cycles and a practical mass loading 2 to 6 milligram per centimeter square we have proposed. For anode, it is 300 milliampere hour per gram, and we are very sure of achieving this, much more than that in fact. And the capacity stability 95 to 99% at 500 cycles with a practical mass loading of 1 to 3 milligram per centimeter square. We will be providing the detailed technical report on the methodology, compositions, and the optimization process. That is also one of the things which we were asked for. And after successful completion of the project, we will be giving the anode and cathode materials of 50 gram each to VSSC for performance evaluation. Now, this was the budget which we had proposed, and this had on the equipment 14 lakhs, where there were two equipments which are needed for this project. One is the glove box, which is required for the assembly of the sodium ion battery because they are very much moisture and air sensitive. And the other is the electrochemical workstation. The other things are consumables and the supplies, some travel, contingency, and overhead is the mandatory thing. I wish to say one thing at this point, that we were sent, when we were sent the recommendation of this project, then in that the budget was reduced to 25 lakhs. And there was some amount which was reduced in the consumables as well in the contingency. So what I wish to point out here is that these consumables, because the precursor which we need to take for the anode and the cathode material have to be highly pure to give us the necessary performance of the materials as well as the battery. So these are quite expensive. Moreover, the GST has gone from 5 to 18% recently. Another thing is that to characterize all these materials, because there will be intensive experimentation involved in this experiment for optimization of the composition of the transition metals. So large amount of characterization will be required, and because characterization at MNIT is all we need to pay for this, all the equipment available are payable except the synthesis part which we have. The equipment for synthesis we have, but for characterization we are dependent on outside sources. So I would request not to cut the budget for this proposal. This is my request. This is the timeline which I propose, that of course first 6 months will be used for the literature survey, and then the 1 to 12 months, the first to 12th month we will be using for the procurement of the equipment, which is the glove box and the electrochemical workstation, and some small accessories which will be required for synthesis of LTMO material. Because sodium being sensitive to air and moisture, we need controlled environment for synthesis as well. And then we will be starting with the synthesis of electrode materials from the 6th month. After that, the material will be characterization. So after first year, the synthesis and the characterization will go side by side. And this is how we intend to deliver the deliverables which we are promising to.
Okay. Okay, Dr. Kanupriya. Thank you. I think anybody is there? Prabhuji or Dr.
Hello? So Prabhu is available.
Yeah, Prabhuji, please your comment. Your voice is breaking, please. Just a moment. Your voice is breaking. Can you correct it?
I'm audible, sir.
No, not yet.
Is it audible now, sir?
No, I think network is poor. You are not. We are not able to listen you. No, Prabhu, we are really not in a position to listen you. Anyway, please try to disconnect and connect in case in between. Just have a few query from Dr. Kanupriya ma'am.
Yes, sir.
I think in your total scheduling, whatever you have put it, I think when you have put up the proposal, I feel literature survey might have been over. So 6 months straight away we can enhance. See, you are not going to put up the proposal and then you start the work. This is my perception.
I agree with you, sir. In fact, after submitting the proposal, 8 to 9 months have gone and we are abreast with the latest developments which are happening in this area.
So I feel that 3 years can it be reduced to 2 years. That's my, because I will tell you one more thing. If you go back to the scheduling, the 3 activities you have shown in parallel.
Yes, sir.
And I think if you can redistribute that, I feel another 5 to 6 months you can gain there. So I feel 2 years is a good amount of time, because the kind of theoretical assessment and knowledge you have and expertise, I think with a dedicated effort, 2 years is really a good time. And the technology is changing so fast, it should not happen that your effort and finally outcome that should not go away. That's my
And the fifth row can go parallelly. Actually.
Yeah, that's what I feel it.
Presentation of.
You are the right person, Dr. Kanupriya. I think you yourself can compress.
I want to say something, sir, here. Even if I remove the literature survey, the experiment part, as I said, because the optimization will involve a large number of experiments, then we'll have to check these samples, come back to the lab. So this involves a lot of time. Moreover, yes, I wanted to say one more thing, that these methods of synthesis, they are also time consuming. So I would want if you keep it to at least 2.5 years, even if not 3 years.
Okay, I think that's fine, ma'am. But I'll just tell you, try to see that when we started with initially with NiCad battery, then lithium, hydrogen battery, and then we switched over to lithium ion. Technology is so fast changing that I feel that if we are not on the right track at right point, then it should not happen that effort from your side is not really fruitful to ISRO. So that's why I'm requesting you. I still insist, I request comment from Gupta, sir.
I'm very much with you in this comment. And she has already agreed to reduce it by 6 months.
Okay, so 2.5 is okay. Okay, so fine. I think 3 years, I think.
Automatically the budget for the person would come down.
Yeah, so.
Sir, I have not asked for any manpower, sir.
Yeah, that's okay. So it's
It is just for consumables, characterization.
No problem.
And this
no problem.
Is also to be reduced. Contingencies also, we cannot give 2 lakhs for contingency. It is only incidental charges. So now some 20,000 per year only we can project it, contingency.
That's a constraint given by the government agencies.
So in the contingency, we have included what we are going to spend on the characterization of these materials, sir.
So put
That
the
outsourcing charges separately.
Okay, so let's we put it separately. Fine, sir.
Put it under outsourcing for characterization, but contingency expenditures should be in a uniform way. Otherwise, it will be cut down by the finance department.
So shall we put it in others?
Yeah, others you put it that what is the characterization charges?
Okay, sir. We'll do that, sir.
So
what is the amount for contingency you are suggesting? Let me just know.
20,000 maximum. It is only incidental charges.
Okay, sir.
So per year, that makes it 50,000 total.
Okay, sir.
Okay, so I feel, ma'am, once again, Dr. Gupta and Dr. Namita may look at the figures and other thing, then you can resubmit it. So, yeah. So I think my sincere request is, can you contain within 25, because 25 it will be sailing through. Actually now, what figure I am here having on my page is 22.55. I think you again requesting 28, which is ruled out. I'm not.
Sir, the recommendation which I received, it said 25, sir.
I don't know. There is some.
I can show it to you, sir. I have
Sir,
it.
during BSc review, sir, that 25 was cut down to 28 was cut down to 25, sir.
This is the recommendation, sir.
Yeah, so 25, now if the timeline is cut down, whether 25 can come to 20, 22.5, whatever is told.
Whatever is coming, that
that will be coming.
6 months.
I think I leave it to Dr. Gupta and Dr. Namita to look at it appropriately.
Sir, my last submission, sir. So the reduction of time means we need to work very fast, sir. But the number of experiments are not reduced, sir.
Yeah, I appreciate that. I think that's
Thank you, sir.
okay, fine. Okay, I think I leave it to MNIT. I think they will review it and put it forward. Final one. Okay, thank you. Thanks. Any
Yes,
other
sir.
comment from any other member? JPMC?
So this is Prabhu, the co-PI. So whether you are getting my voice, sir, clearly?
Yeah, we are able to.
Yes, sir. So actually so this proposal, presently we are working on the next generation sodium ion system, and present aim is to increase the energy density and also find out the new materials which are having the high energy and power. So in this aspect, this deliverables which is proposed as part of this activity will give a very good result, sir. We are expecting. And also the indigenization of new materials is also the prime focus. So
Prabhuji, I
that
think
aspect,
I fully appreciate. Prabhu, I think I fully appreciate this. Really, it's an extraordinary work. I really appreciate it. I think from JPMC side, we are clearing it. Only small correction, and that will be getting reviewed within MNIT by Gupta sir and team. Then we'll get it back.
Okay,
Thank
sir.
you.
Okay.
Thanks a lot, ma'am. Thank you, Dr. Kanupriya.
Thank you, sir. Thank you so much.
Next one is not there, no?
Next one is not there. They
Yeah.
will respond formally.
Okay. So we will be minuting it that we are trying.
Yeah, since it is there on the agenda, we will write that the concerned person will.
Yeah. No, what we will put it in the minute that self withdrawal.
Self-withdrawal.
Okay. Or okay, fine. No, it should not come back as that next. Now we are withdrawing from. Okay, thank you. Okay, ma'am. Okay. Yeah.
Good morning. I'm audible.
We
Sir,
are audible.
Sir, just want to know about Dr. Nandakumar's proposal.
Yeah, Dr. Nand Kumar's proposal, he himself has withdrawn in writing to MNIT. So request has come and they have given some 2-3 reasons, and based on that, we are withdrawing this.
Okay, we are not aware of it because this was developed with SAC, and even SAC co-PI, Dr. Rajat Arora, is also available in the meeting. So at SAC, we are not available, we are not aware of this decision from the PI. We have communicated the evaluation also.
Ma'am, we got this very recently. In fact, I came to know today morning only.
Okay, sir. So because
yesterday late evening, this information has been communicated by our IIT Goa.
Okay, sir. Okay, fine. Thank you.
Okay. We'll proceed. I am sorry from Dr. Rajaji. Sorry.
No issues, sir. No issues.
Thank you. We'll proceed, ma'am. Dr. Namita.
Good morning, JPC members. I'm audible. Should I proceed?
Yeah, please.
So this is my proposal. This has been revised by Dr. Abha, Dr. Parul, and Jitendra Sharma ji many times. So we started with having a project of 2 years. Later it came to 3 years and with lots of scope, change in the scope. So what we are proposing developing a user-friendly chatbot as the interface for information extraction. So these are the contents because we have to restrict on time. So I'm quickly going for the introduction. So as data is growing at an exponential rate, but the question is, are we getting the information? That is a challenge. So for this, we need to have a knowledge base. So knowledge base is to be created for a particular domain that takes a lots of challenges. Like we have ambiguities in perception, in context, in semantics and structures. So basically this project is based on the natural language processing. So first we have to make a ontology, and the ontology is nothing but a hierarchical representation of the knowledge. So we have to develop a knowledge base. That is the main thing. Second thing, how do we do it? That depends on the structural or semi-structural data thing. As we have to work on the natural processing, that is an unstructured thing. Unstructured, we have to convert it into semi-structured or a structured thing. That is a first challenge. Later, we have to convert that into question answering, because we have to make a chatbot that is an automatic question answering machine. So if we keep on developing or accumulating the data set from the ISRO people, that is SAC people, they will be providing the data. And we keep on accumulating, making the knowledge base bigger, and mapping, merging, so many things are to be done. That is the first thing. And then we have to get the exact answer of the question asked by the stakeholders. Those are the SAC people or other ISRO people. So chatbots are basically the artificial intelligence bots to understand human question, process it, interact it, and provide the answer in a particular domain or the language. Sometimes we have to find that language is English or maybe Hindi or any other language, that we have to check it out. So objectives are to design a model for automatic development of knowledge base. That is important. Then accommodates structured. Structured will be given to us, semi-structured, and as unstructured, we have to convert it into semi or structured. Then secondly, we have to develop a user interface for information extraction in the natural language. The stakeholders may ask a question in their language, but we have to process behind the scene and then get back to them with a natural answer. So this interface will provide a user-friendly chatbot system to provide accurate answer with the help of knowledge base. So proposed methodology, electro-optic payload contains heterogeneous data like relational databases, JPGs, those are converted from text to JPGs like images, PDFs, that's a challenge. And then lots of information is available in terms of unstructured, that is tacit or explicit information to them. We have to process that into one platform. That is a first part of the methodology is this. So second is we have to make a uniform platform, that is XML schema with the computer technical thing, that is, then we have to augment the data in kind of mapping, merging, and sometimes repetition will be there in a different context or a same perception that we have to merge it. Further, the knowledge represented formally is exploitable by both machines and user. In the proposed work, we'll have an ontology with EO payload and then transformation of that EO payload into XML documents. And then this is the flow chart, something we will be doing this. I have done a lot of literature survey on that. And we have come to this conclusion that first of all, we'll take different kind of data set, then convert it into XML. Then that XML will be converted into knowledge base in terms of ontology. And then ontology will be queried by the natural answer. And if we don't find it, we have to use the deep learning model, deep learning algorithms. So ontology populated with data provides a knowledge base that can be further for different applications of information system and so for the question answering. So if the query is matched, then it's okay. If it's not found, then we have to find from the ontology. That is an important thing. So if I have taken examples, look at the example of this is a unstructured kind of thing. We have taken it from Wikipedia. Then a big ontology has been created, that is in terms of graph. And all the senses like are related in terms of RDF triplets. What is the subject, what is the predicate, and what is the object. So we keep on augmenting the data, and ultimately we'll be having a big data that is to be processed. For example, if we have a question from this text only we have taken, because so far we don't have electro-optic payload data. So although it's in the text, if you can see, there's nothing to do with the age of the Narendra Modi. Even the spelling is also not correct in the question. That we have to check it, that spelling is to be corrected first, and then the answer is to be extracted from the data given to us. So many questions. So ultimately, this is the question answer. We have to make a polite chatbot that if question is not found or if something has happened wrong, that we have to correct it. That is a chatbot thing. So these are the deliverables. That proposal is novel with the use of AI tools for information extraction. The major deliverables with the SAC consensus, we have reached to this one. The tool for knowledge base creation, knowledge base is to be given, and user-friendly chatbot system. These are the three. Then ISRO significance that the proposal has a strong linkage for developing research and knowledge management and EO payloads activities at SAC. Knowledge base created will provide more detailed and easy access of information besides the useful repository. The proposal is revised after several rounds of discussion with SAC team as per SAC requirement. So this is the budget. We will be having a project associate, as the MU says that the research should lead to a PhD. So we have taken it for 3 years, and it has a scope of 3 years. So this is the budget. Total is 25 lakhs. Mainly it goes for the JRF only, the person only. Nothing we don't have much about contingency overhead. One thing is that equipment we are asking for 5 lakhs. That is for recently in the Department of Computer Science, we have a fee stand from DST. We asked for 3 crores, but they have given only 1 crore. So still we are lacking for some nodes. So one node partly will be asking for the ISRO specific project. So that will have a GPU card and some kind of software management with the master node of the Department of Computer Science. That's all.
Okay.
This is my time chart, understanding of the domain, because that will be new for us. We have to understand each and everything. The data is to be processed, noise is to be removed, and so many things. Project staff appointment itself take a time. We have to advertise, post, and within 3 months we are supposed to do it. Then data gathering for ontology development, data gathering for question answering, pre-processing of data, model development, question answering system, chatbot development, validation testing, user mobile module generation, and report generation. And the conclusions, the proposed system is a framework that created an integrated knowledge based on this. I can skip it that. These are the things.
Okay, thank you, Dr. Namita. Dr. Parul, are you there? Or Dr.
Yes,
Abha?
sir. Yes, sir. We are here.
Yes, sir, we are here.
Jitendra Kumar
Kindly
Sharma
offer
ji is
your
also here.
comments.
All three of us are here. Yes.
Kindly offer your comments, please.
Yes, sir. Jitendra Sharma ji, please.
Sir, this data, whatever Madam was talking about, is generated for electro-optical payloads. We are having electro-optical payloads evaluation data in form of PDF, JPG, and tables. So we wanted to extract those information using natural language processing, so that if somebody want to get data, they simply type in a question that what was the temperature when some kind of failure has happened. Simply this kind of query should give the answers. So on that direction, we are proposing this. Only I was thinking that time they can if reduce, otherwise it's a good proposal, sir.
Yeah. Like we have these two components in this knowledge base in general, like what we have for electro-optical, it's very critical that we understand any failure that happens at any stage. So that for that it is going to be then, and along with that, all the knowledge that is generated as part of the research, which is conducted at SAC and through our sponsored and in-house research. For that also, many a times, like there are queries that, okay, for if such a subsystem has been developed or this component has been developed, what was the, specs which were there? So all such queries we want from the PDF files which are available. One should be able to extract such information. So for that also, the entire knowledge base, we want that this should, as a part of this, we'll be able to create through this, and then extracting in natural language. So the chatbot is also very important for us, that the chatbot that will be developed, and with the background of Dr. Namita Mittal, with her computer science and engineering, we hope that a good model output will be there out of this project. And as our Jiten Kumar Sharma ji has said, we look forward to quarterly, deliverables, so that, some component which is developed, we would immediately want to start plugging in and using. So at every end of every year, the deliverables we are we have defined that we should start getting that, and because whatever is developed, that will start plugging in. So that is what is the thing, so that some modification which is required towards the last phase, we can suggest, and final product will have once this project is over.
And all development will be, sir, on the open source tool. As per our SAC requirement, we have asked Dr. Namita ji for development in open source tool, so that for need not be restricted for some license thing. So that way, a very holistically for all these two major components, the proposal was several times discussed with PI, and that is how it has finally evolved to this today's presentation.
Okay, yeah. I think I was also having 2-3 apprehension. One was open source. So anyway, you pointed out. Another is I was just thinking whether you are planning to, you suggested for the platform independent system. It shouldn't happen that today you are on Windows, tomorrow you go to Unix or Linux, and third day you go to some other RISC based or IBM type of platform, and it becomes a problem. So this also must be relooked at it. I'm sure you might have seen it. The third part which I wanted to emphasize is, I'm sure that Dr. Namita might have looked at it, but this is a AI and MI based systems. So I feel more and more time is spent, bigger is the database, and that's how more accurate system it will be. And the way our information is getting gathered at SAC level, we don't have a limitation, and it is an enormous amount of data is gathered there. if you cut down the time, I'm talking the other way here, because this is a database based system. So if you cut down, tomorrow you should not have a setback saying that I'm not able to get the appropriate information. This is my perception. You people are the right people to comment on that.
That is why third year also we allowed, looking at this AIML concept only. We said, but we want deliverables at the end of first year and second year also, so that we start ingesting and let the model get populated with the data. Third year we have retained for that only. Yes.
I'm coming to that, ma'am. Here there is a small problem. I'm not sure whether headquarter or CBPO allows that quarterly. Then are you going to link it with the finance and schedule?
Yes, it is linked with that. Every year.
Then it will be difficult.
Every year.
Intermittent deliverables, what we are asking.
No,
yearly progress.
I think Dr. Gupta.
Yeah, they can have a intermediate exchange of.
But
linking it to the finances will be.
Then it will be a problem, sir. I am not sure. I think Dr. Paul.
Sir, informal discussions are always there, and yes.
No, ma'am, please understand one aspect. The moment JPMC clears and it goes in black and white, it becomes a binding at both ends. And tomorrow, if we want to violate that, then it has to go back to review and then pros and cons and all that. In my perception, offline interaction, that is a different thing. But you put on a paper and asking for.
Okay, no problem. No problem. No problem. No problem. It can be as offline. No problem.
So in first 3 months, nothing to do to be
Yes.
to the SEC.
Right.
And the second quarter as well, I'm coming back to that. We don't have much to deliver. After first year only, there will be something. First year, second year.
First year, not quarterly. Yeah.
Yeah.
Yeah. And it can be offline, no problem. No problem. It can be offline. No issues.
Okay.
Yeah.
So then last point, coming to your request for reducing time from 3 years, will it be a wise decision for AI MI based systems to?
No, we can retain 3 years, sir. We can retain.
Fine. We'll go ahead with it. Okay. Any other JPMC member offer their comments?
No, sir. Okay from my side.
Okay. Okay. Thank you. I think I feel it. This is okay. And the only thing is, this is a joint development. Somehow I am finding this particular proposal, more and more data comes from SAC, only the knowledge base becomes stronger. So it should
we'll
not
have a lot of data. We'll have particular.
Ma'am, you please understand, it should not happen that the query goes back from MNIT saying that I'm not getting this information, that's why scheduling is delayed.
And Professor, that is the very reason why our sponsored research data, which is in like open domain, only that so that we have taken care, sir. So that's why that has been made as a part of this, that for, demonstrating everything on our sponsored research projects. So that is all with academia. So that is what, sir, we are emphasizing. And we'll have sufficient data to PI. That will not be, sir, issue. Yes, sir.
And last point from Dr. Paul also, and I also felt it to point out, our strategic information should not be shared at any cost from SAC side.
Exactly. So that will retain internally. So that's what our strategic information will be here only. We'll be applying the models, but our sponsored research data, which is, with this, that will be shared broadly. So that can be there as a part of this also. That is the reason why we have merged both the things. Looking at this internally also, we had a lot of discussion on this, sir. Yes, sir.
And
yes, Dr. Paul.
In fact, I want to add, sir, that this is AI ML based modeling actually. So that kind of data itself can be simulated. Whatever data we are having, similar data can be simulated and model will be trained. And finally that model can be taken here and run and tested on the.
Sharmaji, please understand that this is only, I never wanted that they should do it and they are expecting you should share, and finally the outcome of the project after 1 year, 2 years, it becomes in lurch, and actually that should not happen. Please finalize the format and you are COPI, you people should decide what to share and when to share, whether knowledge base will be built up by ma'am herself here. I'm not sure about. Please finalize. Otherwise, I'm finding this is a joint work. Somehow I'm finding.
Data out of clarity should be there. What
Yes.
kind of data they are going to apply? Because
So
that,
our sponsored research data, we are very clear, we'll be able to share.
already
And these
our-
models which are developed, that will be implementing on our internal. So that data part, sir, we are very clear and we'll provide.
What you are telling and what you have projected in the proposal is totally different. You are talking about optical data and all those type of things, JPEG images and that type of things.
So there are two
image
databases. Dr. Paul, there are two databases which are going to go as a part of training. One is our all the knowledge base that is generated through our sponsor research. So a lot of PDF data, table, text, it is there as a part of our this thing. And plus we have all the optoelectrical, this is electro-optical sensors data which is there. So all these data will be provided, and internally we'll be testing on like all the testing will be done using our knowledge base which is there for the sponsored research data. So that's why data should not be any problem in this, and plus that will be implemented on our sensor data also, and that results will be sharing also.
Okay.
Provided data clarity.
I think Dr. Namita ma'am, what I'm no, that is because I think I'm finding that there's a linkage somehow getting into. I think Dr. Namita, are you clear? No, that input, what you are getting from them, what you are expecting from them, that understanding should be on same wavelength. It should not happen what you expect and what they give later on. That should not start. I have seen it with IITs and ISRO also, that problem. So there should be a clarity. That point I'm just
They
highlighting.
cannot give you the classified data. They
Yeah.
give you whatever they are saying, sponsored research data, but the model will be extended by them for application to other data.
Project report and all may not help very much. Project completion report.
Okay, I think we'll be very clear on that.
Yes.
Okay, ma'am. Only thing is, I don't know what is I'm not looking at it, but what is the sanctity of 25.05? It can be 25 or it can be. No, that's okay. Somewhere you. No, slightly adjust so that it comes 25 lakhs or something.
That's from contingency. Make it genuine.
Okay.
Just contingency 0.06 attack it.
Anyway, that's fine. Ma'am wants to look at like, okay, we are very realistic about the. Yeah, I think we can move on to next one. Thanks a lot to all the members.
Sir, just requesting Dr. Namita ji to kindly allow next proposal SAC expert Shilpi Soni to kindly come in the meeting because host has to actually allow. Yeah, thank you.
Just a moment, they are doing it.
Yeah.
Sony. Shilpi.
Is it Shilpi?
Shilpi Sony.
Yes, Shilpi Soni. Yeah.
Yeah. I think
she's joining online, and other SAC expert Shri Ramagiri Santosh Kumar, he is here available in the conference room with us. Yeah.
Okay. Fine. I think we'll proceed. Dr. Mohit. Are you there, Dr. Mohit?
Looking electro-optic payload data and what was the respond of our budget data?
No, I think.
Hello.
Dr. Gupta.
Am I audible?
Yeah, very much. Please proceed. And kindly restrict it to 10 minutes, please.
Thank you. So let me share my screen. Is it visible, sir?
Yeah, it's visible. Kindly, again, I'm requesting kindly restrict it to 10 minutes, please. Go ahead.
So I'll try to restrict and try to minimize the things.
You have to.
There is no, because we don't have time, we have to close at 1 o'clock. We have 3 or 4 more proposals.
Okay. So my topic is design and analysis of survey structures for QV bands traveling wave tubes. So outline of this presentation will be like this: introduction, then objective of the project, motivation, proposed methodology, then relevance with
Go ahead,
ISRO.
please go ahead. This can be.
Okay.
Outline can be skipped, yeah.
Okay. So TWT are basically specialized and essential component of satellite communication and are required in both space and ground segments. And uh, in TWT, slow wave structures are the most critical part, and designing is very crucial. This is a place where beam wave interactions happen, and it determines the many characteristics of the TWT. And it should have the large interaction impedance, flat dispersion characteristics, and easy fabrications. These things are desirable for the slow wave structures. And the research is shifting towards the QV band for the next generation satellite communications. And there is a high demand in this domain. And high efficiency of the proposed space TWT is very much required because there is a limited power available on board satellites. So we are proposing our TWT we are proposing various slow wave structures for TWT in QV band. One type of structures is folded waveguide structures, and it can be a promising slow wave structure with advantages of high power and considerable bandwidth. And the second one is the planar slow wave structures because they are nowadays becoming very prominent because of ease of fabrication and low beam voltage operation. So these are the type of the slow structure which we are talking about. Objective is we are targeting 37 gigahertz to 41 gigahertz with center frequency 39 gigahertz. It should deliver around 130 watt of power, 50 around 45-50 dB gain, 10% bandwidth, and uh, we are going to study various types of slow wave structure for this application.
Mohitji, I have a question here. This
Yes.
planar slow wave structure, will they be able to handle this 150 watts kind of power?
There might be some issue because we are going to have multiple um, two segments of slow wave structures, two stages, multi-stage can be think about it
But
for the higher power
130
and higher
watt
gain.
power, I think this planar will not do. You have to pursue only waveguide structure.
So we will study on this, and if it is not possible, then we will stick to the folded waveguide structures.
Yeah. Okay, go ahead.
We are currently taking both the designs. Mostly planar are more suitable for higher frequencies. So let's see. So
Higher
these are
frequency,
the things.
but what kind of maximum power they can handle, that study also you need to do.
Yeah. So I'm noting this down and will check in mine. Thank you. So VDs are important, and why particularly TWTs are important because solid state devices are not able to give desirable power in the desired band. That's why VDs are more preferred, and out of various VDs, TWT amplifiers are preferred because of high gain and wide bandwidth capabilities. And we cannot use the conventional helix type of slow wave structure because of the limitations of output power and fabrication complexity. And even at this frequency domain, so it's better to have some non-conventional slow wave structures. So, one is folded waveguide, and various it has been widely investigated in the literature also. So we have given some references, and people have proposed full folded waveguide slow structures with grooves and various other um, modifications in that. So these are but they have some limitations. Unsatisfying interaction impedance restricts the ability for higher power. So how to increase the interaction impedance in folded waveguide, that is important. So this we are going to target this domain, how to increase the interaction impedance so that we can have the higher power in the folded waveguide structures. So per period the gain is low. So there are some key points and crucial points in folded waveguides. We are going to deal with these to increase the gain and power, which are which are in requirement for our applications. Then in planar also, definitely we have the advantage of easy fabrication and low voltage, and we can produce at low cost. These are definitely at low cost product. But as you mentioned that if it is suitable for high power, so these things need to be explored. So, although various studies have been made, but particularly Q-band domain are less explored, and it requires more investigation in this domain. So we are targeting folded waveguide and planar inspired by metamaterials. So by using metamaterials, we are using as an absorbers. They are a good absorber. And also in folded waveguide, how to increase the interaction, we can use the multi-tunnel operations. These things
outside only one, no?
Double groove loaded and rectangular groove loaded. These type of modifications and innovations we are going to add into the folded wave flow structures. Then in as I said,
Two eliminate, two eliminate.
He will be the responsible. He will be the total responsibility to eliminate.
Material will be used to.
Dr. Mohit, your voice is breaking. I'm not able to listen you. Can you switch off the video so that bandwidth can be slightly
How to
accommodated?
increase the
Dr. Mohit, please switch off your video. We'll be in a position to able to listen.
Yes. So let me.
There is a provision in most of the video conferencing to go to a low bandwidth option. If you have that also, you can do. Your voice is breaking continuously.
I have stopped the video. And
now it is, yeah, slide better. Yeah, go ahead, please.
Yeah, thank you. So now I am coming to the important relevance to the ISRO. TWTs are crucial for space-borne payloads and many satellite communication link, Earth observation payloads, scientific mission probes, communications.
No, I'm not able to.
It's a recurrent problem.
I think all of us, Mr. Mohit, none of us is able to hear you actually. I'm also at separate connection. Mr. Mohit, are we audible to you?
Yes, sir.
You are not audible, Mr. Mohit. You can.
I'm changing my headphone. Maybe I will be better audible.
The voice is coming in pieces. Sometimes it's okay, but there's a lot of disruption.
Am I audible now?
Sorry? Can you just disconnect and connect again if that helps? And be sure that there are no two units in your own room which are keeping it on. That could be another reason as to why there's so much of interference.
Okay. So is it fine now?
Yeah, now it is much better.
Much better.
I will try to speak a little slowly, so probably it will be more better audible. So can I start, sir?
Yeah. Go ahead.
Thank you. So if the QV band are exploited, they could open up the new potential for wide range of products and services for both military and commercial applications. So now coming to the important part about this deliverables. The first deliverable is detailed design document along with all the drawings and analysis reports and fabricated slow wave structures. Third one is the simulation methodology along with the methods and test setup configuration for measurement and cold test parameters. And then fourth one is the cold test parameters of various slow wave structures explored as part of the project. So these are the expected outcomes and deliverables to ISRO. And this is about the budget. So this project is proposed project is divided into three parts, 3 years of span. So in the first year, we are expecting around 7.7 lakhs total budget, including the research manpower and some components. And these are the particular including everything. And in the second year, it is around 11.2 lakhs. And in the third year, it is 6.2 lakhs, and total is 25.1 lakhs. And coming to the time chart, so the complete project is proposed in 4 modules. So 4 work modules are proposed. In the first work module, which comes for the literature survey. So first 6 months, we are going to target this literature survey part. And then the 14th month, we are going to target the module 2, which actually deals with the design and analysis of a unit cell. It's a unit cell, and then we will unit cell means just one period of folded waveguide structure and planar slow wave structures. So we are going to study the dispersion analysis and these things. And then the second part is the cold test analysis, considering the complete structure of TWT, complete structure of slow wave structure, including n number of periods. Then the third work module, which is from 15 to 28th month, it will target the PIC particle in cell analysis of the TWT. And then in the last leg of the project, will target the fabrication and measurement. So which will be following from 29 to 36. So these overlaps are because we will do some parallel work during these phases. So these are some references.
Okay, Dr.
And
Mohit, thank you.
yeah. So one important thing I want to mention here, since currently I am doing the postdoctoral fellowship in UK, so when I submitted the project, I was the PI from LNM-IIT along with Dr. Shankar Bhattacharya as a co-PI from LNM-IIT. So Dr. Shankar Bhattacharya already now he is associated with IIIT Nagpur. So I have included Dr. Gopinath Samanta from LNM-IIT as co-PI, and we are proposing Dr. Rajendra Mithadwal from MNIT as PI, and Professor Gancham. So these two are already present. We are just We have changed one. Dr. Shankar replaced Dr. Shankar to Dr. Gopinath. So this type of modification we are suggesting because now my affiliation is I am currently in the UK for a postdoctoral fellowship. So I will be work in remotely, and after completing my fellowship, I will be
No,
back
Dr.
in
Mohit, I don't know whether this modus operandi will be functional or it will be appreciable by CBPO. I'm not sure. And moreover, 4 numbers, why do you feel that 2 co-PI, 1 PI and 3 co-PI? I'm not sure this is acceptable. And if a PI you wanted to change, let Dr. Rajendra could have presented it. At least we could have seen some kind of assessment over there. I'm not able to appreciate that, Dr. Gupta.
Let them revise the circular.
I think you should go by your policy. I'm not very sure, but it will be difficult, no doubt. And
Assess
yes,
based on his capability now.
Yeah, no, because
based on the
yeah.
So we'll have to
Sir,
reassess.
Dr. Rajendra is also present in the meeting. So
No, just a moment, just a moment. I would like to listen from Shilpi Ramagiri Santosh, anyone of them from SAC?
Yes, sir. I also feel that Dr. Rajendra should have presented this thing. And if he is there present in person, we can meet him in SAC and we'll discuss further.
Yeah, because now I'm bit reluctant, though I know very well that TWTA is really something breakthrough should happen country in country, and lot of efforts are going on from SAC side also, URSC side also, BHEL side also. A lot of efforts have already BEL side it has gone. So this would have been a really marvelous our major. Support, but I don't know. I'm not sure whether SAC has taken Dr. Mohit's background and then cleared this project, and now by change of that, whether it can be reassessed, relooked, and right now I'm not clearing this. I'm straight way, I'm just pointing out this point. I think it has to be revisited because a change of PI clearly indicates that there is a reassessment, and reassessment should be done jointly with ISRO PI also.
Yes.
Acceptable to us.
Okay.
Okay, so I think right now, can we drop this and you take it up once fresh comes jointly
Sir,
with.
from, yeah, what we can do is we'll have a meeting with Professor Rajendra also, Shilpi, and they can meet, let Professor share his background and the publications to us, his brief bio and publications. And Shilpi will have a meeting with the professor, and then we'll revert back, maybe within a week or before the minutes are finalized, we'll clear this, but this needs to be cleared.
Yes.
Very rightly said, sir.
Give some a week or 10 days time, sir. Yeah.
No, right now what I'm thinking yet, because presentation was today, I'm not getting real good clarity on this one. So I'm telling that it should be revisited. Whether revisited in a week time or month time and or year time, it depends upon your proposal submission and all that to CBPO and how CBPO takes. And that first it has to be
Now, from
cleared within
co-PIs,
this.
from co-PIs, this PI and co-PI, we can clear it from our side. Technically, we had cleared it, but this will send it to you. From any doubts which are there, we need to clarify. That is very, like it is required also, essential. So internally, they'll have a meeting and then we'll send you the feedback. You can take a call, sir.
No problem. But I request Dr. Gupta sir and Namita ma'am first revisit this entire proposal based on a PI change and interaction between SAC and MNIT. And after you are satisfied, and you, if you are submitting back to CBPO, let them take a call. Today we are not. No, I'm not sure. I think that has to be looked at. See, what will happen today in heat, they may commit. And after some time, if they find that, no, this is going to be a problem, we need a further discussion or change of scope or something, then I don't know. I cannot blindly clear this. So I request if you clear within a week time and all that, then you discuss with them and then we don't
From
have
our
any
side,
problem.
will not take more than 2 days.
There's no problem.
There is a good communication between the two
Yes.
collaborating institutions.
I don't have any problem. If you clear it, CBPO accept, then it's fine. Otherwise, right now from my side, I'm not clearing it. Okay, next.
Sir, thank you, sir. Can I leave or?
Yeah, you can.
Yeah, you can leave it. And I think, Dr. Rajendra, are you there?
Yes, I am there in the meeting.
What is your assessment, Rajendra? Last comment from your side.
So basically, if you see, this is kind of joint project. Dr. Mohit Joshi from LNMIT. So basically, we have a kind of complementary skills. So my area is computational electromagnetics, and basically most of the simulation part and the PIC kind of code which will be essential in this project would be written by me. So, I mean, if you see, there is a design part.
Rajendra, we lost you. We lost your voice, not able to listen, but I fully agree with you. For TWT development at the gun zone and then the collector end, I think the kind of expertise you have, really we require that expertise. But I think then you
Sir,
could
this
have.
project is for SWS, not for gun or collector.
No, but you have put it in, you mean to say S band only?
No, as slow wave structure.
Slow wave
This
structure.
That is okay. That's fine. Okay. Okay. Fine. So I think, but it should be revisited. So I think Dr. Rajendra again discuss it, submit the proposal back for internal review. Once they clear it jointly with the SAC, then let it go back and then only we can see. Okay.
Okay, sir.
Thank you. We'll move to next Dr. Amit Kumar Garg. Dr. Amit, are you there?
Yes, I'm here, sir.
Yeah, good afternoon, sir. I am Professor Vijay Janyani and Amit is also here.
Okay, fine. So I think we can start quickly and finish in 10 minutes, please.
Yes, sir. Okay, so am I audible, sir?
Yeah, very much.
Okay. I'm just sharing the slides. My screen is visible, sir?
Yes, sir. Go ahead.
Yeah. Okay, so good afternoon to all. I am Dr. Amit Kumar Garg, Assistant Professor at IIIT Kota. I've submitted this proposal along with Professor Vijay Janyani at MNIT, and I received several inputs from Sri Pranav Kumar Pandeyji, and then we modified the proposal and then submitted it on simulation analysis and implementation of SOP decision forward error correction course for high-speed free space and satellite optical communication. So basically, these are the outlines of the presentation. So first of all, I'll talk about the major scientific fields of interest, then motivation why we are utilizing this forward error correction course. Then
Amiji, we can move on this. We'll see the presentation down the line. Yeah.
Yeah, okay. So as we know, the demand from the satellite operators for ever increasing capacity during these years are increasing, and it leads to emergence of very high data rate system solutions. Okay, so one of the main challenge associated with the implementation of these high capacity systems is to feed the satellite in a very efficient way. So basically, we require the amount of transmitted power and at particular data rate to what we want to feed. And as basically nowadays, the RF bands are facing the saturation for the bandwidth. So the optical feeder links are considered as the promising candidate for meeting the next generation requirements. And the optical communication space division at SAC is basically actively working on designing and development of high-speed free space optical communication links. And recently, they have designed one inter-building free space optical communication link for 300-meter distance. So basically in this project, we will be designing a more reliable and energy efficient, or basically the power efficient optical communication link that will be operated at 20 Gbps by incorporating the efficient forward error correction encoder or decoder at the transmitter side. So that will increase the bit error rate performance significantly. And basically, apart from this, so we will simulate, analyze, and implement the SOP decision forward error correction codes, and we will design the FPGA-based encoder and decoder that can be utilized at 20 Gbps data rate transmission. So the motivation behind the forward error correction codes. So as basically we are moving on higher and higher bandwidth, or we can say for the long distance transmission. So the optical signal to noise ratio is basically deteriorating. So to maintain this optical signal to noise ratio at some particular level, let's say at the receiver sensitivity level, is one of the most challenging tasks. And when we talk about the free space communication, so there are several challenges like the atmospheric turbulence, scattering, interaction, absorption, and there may be the environmental changes like the rain or fog or haze. So basically this optical signal to noise ratio is further degrading. So as this optical signal to noise ratio is degrading, the power budget matching is becoming one of the difficult tasks. So receiver may not be able to detect the signal properly, and it may lead to the more bits in error. So basically to compensate for this optical signal to noise degradation, so VR performance can be improved by implementing the advanced forward error correction codes at the transceiver and transmitter and receiver. So basically the FEC code can improve the coding gain that is approximately by 6 to 10 dB. So this is one schematic diagram. So basically we are providing the data from the transmitter. So before it is transmitted to the channel, or we can say to the free space, so this data is modulated, and it basically encoded in some particular form. So by utilizing some particular kind of FEC encoder, and then basically, so by adding some parity bits, this data is having the capability to detect and correct the errors at the receiver side. So basically, again, there is some reverse process that is happening at the receiver side. So the received data is then again decoded or basically demodulated. Okay, so when we talk about the coding gain, so as we can say, this 6 to 10 dB coding gain. So 3 dB coding gain means the power requirement will be reduced to half. And when we talk about the 6 dB or 9 dB, so basically the power requirement for the transmission will be almost 1/4, or we can say it may further reduced. Okay, so just by employing the efficient forward error correction scheme, so we can reduce the amount of transmitted power significantly, or alternately we can say we can transmit the data for the longer distance and with the more reliability, or we can say with the less errors in the bit. And so basically this is one diagram which indicates when we are using the communication link without any forward error correction and with the forward error correction. So approximately 9 or 10 dB. So depending on what we are targeting, so we can avail this coding gain. And nowadays, basically, the soft decision forward error correction schemes are more preferred. Basically, as hard decision forward error correction codes, the decisions are made on hard bound. So if a particular signal value is beyond is greater than some particular threshold, then basically it is detected as 1, and if it is lower than that threshold, then it is detected as 0. But what happens in case of soft decision forward error correction? So basically, we quantize the detection level, or we can say the detection levels are granular. So basically, depending on that or the confidence level, so the decisions are made. So in case of soft decision, the chances of detecting the bits correctly are very high. So, and basically when we are transmitting, or we are dealing with the free space, so basically due to the fading in the atmosphere, so basically there may be the errors that are coming continuously. So those errors are known as the burst errors. So to deal with the burst errors, the interleaver and deinterleaver can also be used. So basically just to spread the errors in the time domain. So basically the advanced channel interleavers can also be used to deal with the burst errors. So these are the major objectives. So first of all, we'll simulate the advanced soft decision forward error correction code for high speed up to 20 Gbps data rate. And then we will develop the FPGA based encoder and decoder for 20 Gbps data rate that can be modulated for different schemes. So basically with our proposal, So this proposal will improve the coding gain by 6 to 10 dB. So we can say this coding gain can be used to compensate the amount of the transmitted power required, or we can say the BER performance and transmission rate. So this is the novelty of the proposal. So basically, we are implementing this higher order concatenated soft decision forward error correction code for the optical access network and definitely for the satellite communication. And use of the advanced channel interleavers will be there in combination with the FEC encoder and decoder, so that we can deal with the worst errors that are coming due to the fading. So our proposal is very well linked to the ISRO program. So ISRO's ongoing and future programs like for the optical communication link for GEO and LEO-based satellites. And
yeah, we can skip this, Amit ji. We can skip this. We are aware of.
Yeah. So these are the expected deliverables after completing this project. So we will deliver the final system layout of FEC encoder and decoder that will be operating at 20 Gbps, and it will be designed for different modulation schemes, including the on-off keying, PPM, BPSK, and DPSK. And then we will provide the FPGA-based designs of FEC encoder and decoder, and then SDL designs of FEC encoder decoder, and then the complete system design report and the simulation and test results with the implementation to with validation to its implementation. And then basically we'll also provide the satellite communication, satellite optical communication channel design approach for various FECs, and then we will also try basically. We are now focusing for the 20 Gbps, but we will also focus, or we will try to implement or comment on how we can reach up to the 20 Gbps data rates, as nowadays the high throughput satellites are there and that are operating at very high speeds. Okay, and this will be our methodology. So first of all, we will analyze the soft decision and hard decision FEC codes, and then we will also analyze different modulation techniques and then do some comparative study. Then we will simulate and analyze the higher order concatenated basically soft decision as well as hard decision FEC codes. Then we will implement the FPGA board for the proposed FTC encoder and decoder. Then we will do some kind the comparative analysis and result validation with the simulation and basically the designed FPGA based encoder and decoder. And then we will characterize our proposed system for the coding gain and BER performance or system cost, or we can say for power requirement, transmitted power. So these are the fund requirements. So basically for the research fellow, so it will be approximately 11.64, and by including the HRA, that is 18% current HRA, so it will be 13.73 lakh. And then we will be requiring our desktop to do various work. So it will be costing us around 1 lakh. Then basically, as our main focus is to design the encoder and decoder on the FPGA board. So basically, we are targeting for this FPGA VC709 Vertex series, VC709. It can be operated up to 40 Gbps. So that will be costing around 11.75 lakh by including 18% HRA, sorry, GST. And then we will be requiring the Vivado design suite basically to synthesis and burn the FPGA encoder and decoder. So that will be costing us around 2.5 lakh. Okay, so the equipment cost would be around 15.3 lakh. And then so for consumables, internal travel and contingency, we will be requiring some another 4 lakh. And then overhead, that is having the cap of 3 lakh. So we have written this for the first year only, but this overhead can be distributed for the 3 years. So the total cost for our proposal would be around 36 lakh. So
okay. I think there is a small issue. Looks like I'm not sure. Before you move to timeline, it's only shown here 32.7, and you are putting as 36 and odd.
Yes, sir.
So I'm not sure whether it has been appropriately reviewed internally by. No, that's what I'm not getting the clarity. Figures are not matching. Okay, you proceed. I think
Yes,
you
sir.
go to next timeline. I think this is not okay.
Yes, so this is our activity timeline chart. So basically we have distributed this 3-year duration in 14 tasks. So basically for the first year, so we will be performing the task A, B, C, D. So basically the task A is the procurement of the various components or tools, and then recruitment of the full-time GRF. And then we will be doing the complete literature survey associated with the project. And then we will also and then we will be simulating the higher order concatenated basically soft or hard decision FEC codes, and then preparation of the annual report. And after the completion of the 1 year, we will submit the compiled literature survey belonging to the appropriate FEC schemes. And then we will basically simulate this on the OPI system and or OPSIM. So both the tools are available at MNIT. So we will be providing the simulation files to this row. And in the second year, we will be performing the activity E2I. So basically then we will propose the suitable FEC code as per application specific for the different VER or desired VER. Okay, and then we will study about the various challenges and limitations available with the FEC, and then design and implementation of advanced FEC encoder decoder through MATLAB and Xilinx Vivado tool. Then we will implement it for the FEC code. And then after at the end of the second year, we will submit the annual report, and probably we will be submitting some research papers also. And then submission of application specific optimized FEC technique to this row. And we will also submit the MATLAB and Xilinx Vivado SDL files that we are created or for the implementation of the FEC encoder and decoder. And at the end of the third year, basically, so we will be designing the hardware, or FPGA board will act as the FEC encoder and decoder. So these activities are from J to N. So then we will just verify the performance of the FPGA design with the simulation analysis, and then we'll do the comparative analysis. And after that, we'll prepare and submit the research papers. And finally, we will be preparing the complete report and submitting it to the ISRO. So
okay, okay, Amitji. Okay, thank you. Anyway, I have a few reservations. I think we'll discuss it. Pranav, are you there? Pranav,
yes, sir. Good afternoon, sir. Pranav here from SAC.
Yeah, can kindly offer your comments.
Yes, sir. This was a very good proposal. Initially, it was for simulation and analysis purpose only, but this has a very genuine and physical application as per our ongoing programs in the field of optical communication. So we have modified the proposal to a meaningful deliverable that can be used, or the knowledge gained from that research can be used straight away to our ongoing programs. So it is a very good proposal, and that will whatever coding techniques Mr. Dr. Amit has proposed, they will be directly implemented in our optical terminals design, and it will give a lesser burden on the thermal and power systems of optical communication payload. And additionally, this coding gain can also compensate for the atmospheric fading losses and the burst errors that occur during this satellite to ground optical links. In this way, the error correction techniques and the interleaver for burst error corrections, both the things are quite in line with our present requirements. So it's a very good proposal, and it has been discussed at large with Dr. Amit also to tailor-made it as per our requirements. So we strongly recommend that this should be considered, sir.
Pranav, have you looked at it, the presentation? He talks about MATLAB and Xilinx, Vivado, that files and other things. It should not happen that we depend upon this kind of resource, whether it is available with you and or you are going to procure it.
MATLAB and some design softwares like Opsin and Opsys system, they already have. Only to realize that coding systems on FPGAs, they require some Xilinx board that that is a very good board for 40 Gbps optical transmission and Vivaldo design suite. So these two modules they require for the realization of this hardware. And that is indispensable. Rest of the things like MATLAB and Opti system software, they already have with their institute, I think.
Yes, sir.
I'm not sure about, I'll request Dr. Paul and Dr. Gupta to pinpoint. See, this is one of the almost 1/3 investment goes here.
40% investment is for infrastructure, sir.
Yeah, so whether that will be part of, yeah, that should be part of deliverable.
So that they can explore from their existing institutional infrastructure.
No, you are not understanding. You see, Pranav, see the cost which we are investing. I think we should look into this aspect also. First of all, these figures are not matching. It has to be revisited. 30 versus 36 lakhs. So that is that.
Sir, Sir, that mismatch is due to the initial proposal, what they have submitted and what they have corrected after the multiple discussions with us to made it as per a meaningful deliverable to assure that. So in that case, this 32, I think, was modified up to this 36.06. So 36.06 should be considered at the final value. Otherwise, it was 32 in their original proposal, which was altogether modified as per our requirement.
No, then if 40% of deliverables are there and that investment, why SAC cannot absorb it and then only put the cost as around 20 lakhs?
So this FPGA boards and all that suit will be required for this project continuously. So that they'll be needing it there only.
But
they
usually
cannot come to SAC and do that work.
Sir, in fact, the whole the scope of the work was also enhanced during discussion with SAC experts.
Okay, no, but somehow I'm not gaining the confidence. And by just FEC that technique, that correction, code correction, whether 6.8 dB really gain all that?
So 6 to 10 dB coding gain is a very considerable improvement in the link margin. It will give around 50% lesser load on high power amplifier EDFAs. In GZ29, we have struggled a lot to accommodate that high power amplifier. So 6 to 8 dB gain in terms of coding, that also for the low power section will give a very good leverage for this overall system design for power and thermal both. And in addition, it will also compensate for the atmospheric losses and fading. So we can trade off either for it.
Just a minute. I'm telling because of that only, because it's a considerable value, whether by this correction, whether that is the level it will achieve.
Sir, in our earlier designs and most of the space agencies that they have earlier flown their optical terminals that were without the coding gains. Now NASA's LCRD mission, they have also included similar type of subsystems in their LCRD mission, that is geo to ground relay link, in which they have implemented error detection code along with channel interleaver for burst error corrections. So this proposal is similar to in line with that requirement. Even in Messias satellite of China, they have not used any coding gain for the data transmission. So they have to transmit around 3 watts of power from LEO orbit itself to get a particular BER of 10⁻⁻⁶. So when we get leverage on this coding gain, that will have a considerable reduction on this power and thermal issues of the optical payload.
Okay, fine. I think.
Look, sir, I have a point.
Yeah, ma'am.
I have no doubt that this is a very good research work which is going to feed to our SAC and it's going to give more inputs. But I also feel like when you come to the estimation and all, it looks like establishing a very what is that, elaborate lab, or the equipments required are very expensive. And I hope we do have the confidence that whatever we are planning to get as a gain will compensate for this establishment. I also felt that equipment.
Okay.
That is
Okay. Okay, Dr. Vrinda, I think we'll take it up there. I think we'll go ahead with
Proposal, we'll have to get it.
Okay, fine.
It's the one we have not got.
Yeah. Okay, we'll, thanks, I think Dr. Amit and Pranavji and SAC team. I think thank you very much. We'll proceed with this. Okay.
Thank you, sir. Thank you.
Thank you. Yeah, we'll move to next. Kaisar, Mohammad Kaisar Raza.
Yeah, good afternoon, sir.
Yeah, good afternoon. Kaisar, I think if you can finish in little early, everybody will be hungry and they'll all come.
Yes, of course, sir. Yes, of course.
Yeah, I'm not the culprit. All the presenters are culprit here.
Yes, sir.
Yeah, go ahead, Kaisar.
Yeah, sure, sir.
It's a lighter side.
Hello.
Yeah.
Please upload your presentation.
So, is it visible?
Yeah.
You can make it full screen. Okay. Fine.
So, is it fine, sir?
Yeah.
Yeah, Kaisar, your time is running now.
Yes, sir. A very good afternoon to all. So, I am Mohammad Kaisar Raza, Assistant Professor from Department of Mechanical Engineering, BITS Pilani campus. And I am going to present on project proposal, development of space qualified vapor chamber. So, we have Dr. Majinder Singh, co-PI for this project. He is an Assistant Professor from Department of Mechanical Engineering, MNU. And we have a collaborator from SAC ISRO, Ahmedabad, Mr. Vivek Kumar Singh. So thermal management of electronics, including spacecraft avionics, is increasingly becoming a challenge because of the development of more powerful electronic systems, increase in miniaturization and compact electronic packaging. So these devices generates lots of waste heat during operation, and if the temperature exceeds beyond the permissible limit, it may result in the failure of the system or the entire space mission. So if you look in this plot, so here y-axis shows the failure factor and the x-axis shows the temperature. For every 10 degrees centigrade rise in temperature, the failure rate becomes double. So one of the major challenges associated with the thermal management is the hot spot in electronics, which is essentially a concentrated heat zone where temperature may be significantly high as compared to other locations. So in order to mitigate the problem of hot spots, generally a heat spreader is used. So this is basically sandwiched between the hotspot region and the heatsink device. And this heat spreader is essentially a thin metallic pad of high conductivity material, such as copper. So it takes the heat from the hotspot region and nominalizes it over a larger area at the heatsink site, where it is relatively easier to handle. So if you look in this typical plot of thermal conductivity, here y-axis shows the thermal conductivity and the x-axis shows thickness. So this red color dashed line is for pure copper, whereas this blue color shaded region is for diamond. So despite having this higher thermal conductivity, these solid state heat spreaders are not able to cope up with the demand of high heat flux dissipation in the hotspot region. So in this regard, two-phase heat spreaders are developed, corresponding to which the thermal conductivity is shown here by green color data points. So these are also called vapor chambers. So let's see what is it. So this is also a thin metallic pad, but hollow from the inside. And it contains a wick structure all around its periphery, which is basically porous in nature. And it contains working fluid. So whenever we have the hot spot, liquid evaporates and this vapor goes to the other side where heat sink is present. So the heat is rejected to the heat sink side and the vapor condenses. And that's why the top portion is also known as condenser and the bottom portion is known as evaporator. Then the condensed liquid returns back through the capillary action to the evaporator. So one of the major challenges, major problem with the existing phase chamber or the vapor chamber is their low heat dissipation capabilities. So these are the desired features of a heat spreader for the zero gravity application. It should be passive in performance. It should be lightweight and thin form factor to improve the energy to mass ratio. Its performance should be independent of the gravity. and it should be able to handle the high heat flux and should be able to operate at sub-0 degree centigrade temperature range. So these are some of the literature survey that we investigated based on this desired characteristic. And if you look in this table, the second last column is crucial, which is marked here by the circle, red color circle. So we can see the maximum heat dissipation capability, which is significantly low. So there are few studies which suggest a high heat flux of around 200 watt
I
per
think we
centimeter
can
square.
proceed with this. We can skip and proceed. This is a well-known
Yes,
fact.
sir. So based on this literature surveys, so these are our research objectives. So we wanted to develop a space qualified vapor chamber that should be able to handle a high heat flux of around 200 watt per centimeter square, and they should be able to operate at sub-0 degree centigrade temperature then. For that, we need to develop a charging station, and we also wanted to fabricate the experimental setup to for the thermal performance evaluation of the vapor chamber, and we will be investigating the effect of wick and the charge fluid, and we will be also using some fluid which has been investigated for the vapor chamber as far as our knowledge is concerned. So we will also be performing some experiments at various heater orientations to investigate the effect of gravity level on the thermal performance. So these are the preliminary calculations. Here, y shows the flux, sorry, heat transfer, and the x-axis shows the temperature. So in the case of vapor chamber, these two limits, that is capillary limit and the boiling limit, is the crucial. So this shaded region below this curved line indicates the operating regime. So the preliminary calculation suggests that for a copper vapor chamber with water as a working fluid, we will be able to achieve a heat flux of around 80 watt per centimeter square. However, this can be significantly altered by modifying the wick structure, working fluid, as well as the dimension of the vapor chamber. So this is the typical exploded view of the vapor chamber that we will be fabricating using a sintering process. So evaporator plate is shown at the bottom, and this is the evaporator wick, which will be fabricated as an integral part. And similarly, we will also fabricate the condenser wick and the condenser plate at as an integral part, and then we will join them in the vacuum furnace using diffusion process to prepare the final vapor chamber. So these are the graphite sintering die that we will be using for developing different pattern on the wick structure in order to alter the capillary flow of the liquid to enhance the thermal performance. So we have also planned for fabrication of this charging station so that we can fill the liquid inside the vapor chamber. After that, we will be doing some testing. So here, this is the vapor chamber, which is basically sandwiched between the heat sink and the hot source. So this is the typical heater assembly, as we can see. And this brown color is the copper block. And these are the cartridge heaters, which is connected to the DC power supply. So using the DC power supply, we can control the heat flux through this neck region, which essentially mimic the hot spot in electronics. And in the heat sink, we will use liquid circulated cold plate. And our primary objective is to maintain the temperature around -20 degrees centigrade. So these are the test metrics that we have identified so far. We'll be trying to achieve a heat flux of around 200 watt per centimeter.
Yes, sir, you can move on this you can jointly work it out.
Yes, sir. So these are the linkage and relevance with the ISRO. So
yeah.
ISRO is strongly determined to expand its presence in the space exploration due to the national interest. Sorry. So
yeah, move on next.
Yes, sir. Yeah, so the premature demise of the Chandrayaan-1, this was also primarily attributed to the onboard electronics overheating. So we believe that in this regard, the development
I think better not to comment such things. That was not the reason.
Okay, sorry, sir. So I got this information from the
I know what is the total reason. So don't make such a statement in the open presentation like that. Okay, you are not the authority to talk on that. Next.
Sorry, yes, sir. Sorry, sir. Actually, I got this information from the news channel. That's why.
That's what I'm telling. What comes in the media is not the right thing, and Google is not 100% correct. We don't accept the results as it is.
Thank you, sir, for this feedback. Yes, sir.
Yeah.
So these are the expected outcomes. So we will be developing a design code to assess the thermal performance of vapor chamber based on the various parameters such as heat flux, vapor chamber dimensions, wick parameters, and all those things. And we are also targeting to develop 2 to 4 quantity of space qualified vapor chamber at the TRL6 level. And we will also be preparing a technology transfer document where we will have all the minute details right from the fabrication of the vapor chamber to the testing and the validation. And we believe that these information will be very much instrumental in the development of advanced thermal management strategy for the spacecraft avionics. So these are the time plan. So the first column indicates various activities. So we have the procurement of equipment and in the initial half year, and we will parallelly start the development of engineering model for the vapor chamber. And after a few months, we will, means 1 or 2 months after that, we will start the fabrication of vapor chamber, charging station, test setup, all in parallel. All of these activities are basically in parallel in nature. So probably by the end of this first year, we will start the testing and the thermal performance evaluation of the vapor chamber. So our target is to at least achieve the TRL level 4 by the end of second year, so that in the last year we will have some enough time in case any modification is required in the vapor chamber after the space qualification, then we will be able to do that. So these are the budget requirement. So we will have one PhD student that he will be working on this project dedicatedly, and these are the equipment that will be required under equipment head. So we will be needing some recirculating chiller, some temperature and pressure sensor for the fabrication of the experimental setup, and consumables we need around 4,10,000 for the entire 3 year period. And we also need some support from the ISRO so that we can closely interact with the ISRO so that we will come to know what is their exact requirement, so that we can accordingly modify our design. So this is our research team. So myself, Mohammad Kassaraza, and
yeah, that's fine. I think Vivek, are you there?
Yes, sir, I am there, sir.
Vivek, have you heard the total presentation, right?
Yes, sir, I heard the total presentation. In fact, except that applications for ISRO, what he wrote, most of the things we have discussed once the proposal was submitted. Not me, but our division, means within the divisional level, we discussed and submit this proposal, sir.
Now, this is Vivek, just only one comment. This kind of chambers and spreaders are available at much cheaper rate now, and a lot of know-how is available now.
Sir, actually only one problem in the commercial chamber, as far as we searched in the commercial market, that they are the mostly the water-based chambers. So water-based chamber means we can use them above 10 degrees centigrade or so. So here we want to first of all target
Vivek, any water-based chamber, the moment we add methanol or something, we can go down to -5 depending upon the total composition. And we have gone up to -10. I myself have achieved it with in the Julabo unit. So I don't think there is any hidden things in that. And it's a very well-known technology. And the only thing is realization of this with the available resources. I think it's a good effort from if it is coming through typically for application what SAC is looking for. But I think in my opinion, this is already well-known things, and it doesn't take 3 years time. First of all, that is ruled out. I'm not clearing this project for 3 years. It maximum at stretched level, it should not cross 2 years. First is that comment. Second thing, budget also is beyond this thing. I think what are the additional thing is required is one is the centering, another is the Julabo for recirculating unit, and third is the test experiment like data analoger and all that. So I don't think this budget, this has been really reviewed internally with the SAC team. So I
budget
feel
part, sir, budget part, we have seen actually 1/3 of the budget PI is asking for the fellowship. So in fact, we requested the PI at that time also if it can be managed with the internal students, it will be better. But he was suggesting he will need a PhD student. So if we see the budget part, 1/3 budget is for the around more than even 1/3 budget is for the fellowship of the student. As far as equipment,
Vivek, please understand our objective from academia is to get the project and their academic support for the product realization, not for the purpose of anybody doing fellowship or that's not responsibility of ISRO. I don't think that is the objective of ISRO under this response. I think I request Dr. Gupta and Namita to review it critically. I'm not clearing it for 3 years, first of all. 2 years appropriately, if they can revisit the budget, and I think they can cut down the cost. Then based on recommendation from Dr. Gupta and Dr. Namita, I think appropriately from JPMC side, I'm not for this. It's a very long, and I have got a practical experience on this technology, so I don't think it involves so much. So, but if they reduce it to 2 years and it is job to order to SAC, and revisited proposal can be reviewed thoroughly, then this can be cleared.
Okay, sir, we'll do it, sir. Actually, 3 years we put it. There was a reason for that, sir. From PI and most of the work is only for 2 years. Third year we have kept it for the space qualification. If we see that up to the 2 year, majority of the work at PI end is only for up to 2 years only.
Vivek, space qualification SAC can do once product reaches to you. You fly in PS4, fly in any spacecraft as a piggyback, and you get the experience. If any,
okay, sir, that can be done. I think PI can look into this aspect. Actually, we can do it, sir. That's not a
our Vivek, our professors available at IIT, our NITs, they are guiding us for their technical academic excellence, not for your flight qualification. I don't think that should be the objective of.
Okay, sir, we will do it, sir. Sir, in that case, I'll request.
So
Dr.
one point here, we can reduce it to 2 years as you have suggested. Only thing is, this was as a part of our space technology incubation Yukti Sanchita we had done for indigenization, and
Right.
that is why we rope in our people, our academia, to up to the end. So although we can end for finance up to the second year, but we would like the PI to be involved even during the qualification and testing, so that they also get the feel of it, and then finally it is implemented. So you for finance you can reduce it to 2 years.
Okay,
But otherwise, we request that it can be kept as 3 years without any budget in the last year. Some travel only support. So that we would want him to be involved and his students to be involved for this testing, if possible for JPMC to sanction that way.
Yeah, and I'll also request, as sir also suggested, Dr. Kaiser can think of removing the JRF component. He can take from the institute itself and work on that aspect. It's a.
I think, sir, please look at it. I think there are.
Actually, proposal is from bits planning.
Yeah. No, we don't have any hesitation.
No, what I'm telling, so they have to take a call.
Dr. Kaiser, this JRF, as sir suggested, you can look into that aspect, and 2 years definitely what sir, madam and sir suggested is a good option.
2 years, JRF can join. No?
Yeah, just a minute, sir.
Well, I don't know about this kind of arrangement that the project is sanctioned for 3 years and financed for 2 years, but if you can make a specific proposal,
that will not be feasible, sir.
you can just make
Third
a
year can be only
specific-
travel or support, not much, but only travel support for PI to visit SAC for during the testing phase.
Next 3 years.
Yeah, only specific allocation if you can permit for travel support or
expert support.
No, that's it. I think, I think with a specific permission from center director, SAC can be looking into that.
Waited for
Our objective, see, most of the professors, if we contact them to visit us and guide us, they are very happy. They are coming at our premise and guiding us if we'll end up in trouble based on that. So I feel SAC can look at it, but technology per se is not worth for 3 years. That much I can tell you, because I have got first-hand experience. I don't talk about other things. I have already worked on all that personally. So I feel that it can be cleared, and but only thing is it should be reduced to 2 years. And as Dr. Gupta suggested, for travel and other support, if SAC center can support, it's okay. Yeah, I think that way we'll take it up. Okay.
But Yukti Sanchita, originally we had planned for this space qualified thing as an end output. So this will end at TRL4 as far as this RSCS project is concerned. We'll stop it there. So the PI, the thing only up to TRL4 his involvement will. That's in later on. It is in any case we'll bring it to space qualification. But like we thought that, okay, let PI be there for 3 years. So he feels that, yeah, he's part of it. But separate, we'll end it here at TRL4. Because in Yukti Sanchita, we had, accepted it as bringing it to TRL6 level. Just
Please,
that.
ma'am, try
It's
to
okay.
understand. We have a limited.
We can stop, sir. No problem. Only we'll
As
note
you
that
guide.
TRL4, the project will end in this RSCS.
Okay,
Yes.
I think a river. Yeah, thank you very much, Kaisar. Please proceed. I think it's a good support.
Thank you
Please
very much, sir. Thank you very
Thank you,
much,
sir.
sir.
Thank you, sir,
wish you
for
all
your
the
feedback.
best. Thank you.
Thank you so much, sir.
Yeah, Dr. Anand Darji,
Yes.
are you there, sir?
Yes, yes. Am I audible?
Yeah, very much. Please proceed, sir. Try to limit within 5-10 minutes, sir. We
Oh.
just want a briefing.
Okay. Let me try. I think I want to share. So please unshare the screen.
Mukhtar, can you unshare?
Yes, sir.
Okay.
Sorry, Kaisar.
Yes.
Sorry.
Sir, should I log out or can I stay here?
You can log out. Your session is over. Thank you.
Okay, sir. Thank you so much, sir.
Thank you.
Is it
Dr.
visible?
Anand? Yeah, very much, sir. Please proceed, sir.
Okay. So thank you very much for all jury members. Today I am here to present proposal onboard spectral pre-processing for multispectral image compression using FPGA. Myself, Dr. Anand Darji from SUNIT Surat, and my CI of this project is Amit Joshi from MNIT Jaipur. The outline will start with
Anand,
yeah?
sir, means make it move full screen, sir. I think it is not.
Okay. One minute.
Dr. Anand, we can skip the outline and other things. Straight away go to objective, deliverables, and schedule and fund. That's it.
Fine. So no need to discuss about the introduction part, sir.
No, we can skip it.
Okay.
Compression is a well-known field in the satellite technology. So I think most of the members will be fully aware of it.
Sir, just I want to give you idea about what I am going to attempt in this. So basically CCSDS 122 has DWT plus bitplane encoding JPEG 2000, which is bit old. And 122.1 has POT is recently adapted. So I'm planning to use this for hardware implementation. So that is the point. And so in fact, we go ahead. This all. So KL transform, which is the eigenvector based transform, and it is used in POT, and actually it is not AOT, it's AAT.
Yeah, that I wanted to point out. It is not AOT.
No, that is by yes, AAT.
It's okay.
KLT is selected to for spectrally decorrelating the image, and data from neighborhood pixels are highly correlated. So by this decorrelation, we get lot of compression. This is the flow input matrix, image matrix. Then we have to find mean of each band. Then we subtract the mean from original image, and we get the covariance matrix. After subtraction, then we get the eigenvectors for covariance matrix for image energy compaction, and finally eigenvector will be multiplied by mean subtraction matrix, which we achieved. So this is the flow, and we generally, this is a KL transform, and KL transform is used in POT like this way. So this block, let us say we have pairwise pairwise pixel we take from nearby spectrum images, and we have first level, second level. Means if you want to go multi-level, then we go by this. And this block, each block is the KL block, KLT block, and there is a possibility of balance and unbalance. Here you can see this is balance one where we get S2 and S3. In this unbalance, we get S4 output, and we'll have one output from S2. So like that, this is the line-based application of POT. Divide and conquer strategy is usually used, which will be more efficient in terms of speed. as well as we can use repetitively KLT blocks so that it is regular in design also. Again, this is the image taken from the CCS-DS 122.1. It is reversible, and so that it actually gives better coding efficiency with little bit higher complexity. This is AAT. AAT we have segmentation, and all the segmented image we pass through KLT and get the compression. So, and finally, to remove the spectral redundancy, we use 2D encoding, which is done through discrete wavelet transform. So ultimately, the objective of this project to develop hardware efficient spectral preprocessing architecture for multispectral image compression based on CCS-DS 122.1 standard, and various RTL blocks such as pairwise orthogonal transform, KLT used in the spectral transform, as well as floating DWT used in 2D encoder will be optimized for low power and high speed image processing. Implementation will be done on on Xilinx Kintex UltraScale SQU XCKU040 space grade FPGA. And proposed approach, we start with various techniques of hardware optimization such as lifting wavelet, multiplier-less floating wavelet, line buffer reduction, approximate arithmetic technique, canonical sign digit technique, sub-expression elimination, pipelining for this RTL implementation. We'll have functional simulation for bit equivalency model check with the reference. Then quality assessment will be done based on the parameters such as PSNR, SSIM extracted on different compression ratio using test bench. And after meeting the specification, the architecture will be synthesized and post-synthesized simulation and post-root simulation will be done for power analysis and delay analysis. Deliverable hardware architecture optimized for spectral transform and 2D encoder. Major deliverable is this RTL simulation and bit equivalency check with reference model, FPGA implementation, and deliver the final deliverable will be a working tested SDL source code in form of IP. This is the timeline. Usually, FPGA based project starts with optimization means algorithm. Then we have simulations, RTL design and simulation, and finally FPGA implementation and testing. Whatever the facility available in our institute, as we have software, Synopsys, Mentor, because we are part of SMDP program. So all Vivado recent version is also there. And in hardware side, we have low-end kit, Zybo and Basis 3 board. Spartan 3 is old kit. Now we are not much using it. We have video encoder decoder board as well. We have logic analyzer.
Dr. Anand, we can move on this.
Okay, fine. This is the budget which is proposed. So we have research associate fellowship. First year 31,000, second year also 31,000, and finally we have 35,000. So total 11 lakh 64,000. Equipment 5 lakhs 25,000. We are demanding one kit, Xilinx Kintex UltraScale FPGA KCU 105, and one desktop PC, workstation grade desktop PC with GPU capability, limited GPU capability. So altogether 3.5 lakhs here and 1.75 lakhs. We have equipment requirement of 5.25 lakhs. Then satellite data, we don't have any fund required. Consumable and supply, we have written 20,000, 40,000, 40,000 in terms of like some maintenance requirement. We have internal travel for conference or to attend meetings in SAC, and some contingency grant. So like that, total budget of first year with overhead is 11.48. Second year 5.90. Third year also 5.50. Now here the total budget overhead should not go beyond 3 lakhs.
Okay, fine. Only thing that research associate you have got, actually it is not research associate, it is project associate. Research associate means they should have PhD. Okay. So correct nomenclature.
I think he can
So
have
the
GRS.
terminology you can change
Terminology
to
be
project
corrected.
associate.
And they are eligible for HRA also, that also to be added. And your contingency also to be modified accordingly. So we will not keep more than 20,000 per year. Okay. These are some of the suggestions. Any other points we will discuss?
I think.
Sir, can you repeat? I could not see. First is research
We'll send
associate
you the
related
details.
suggestion.
Yeah.
Professor
With
Darji
HRA.
will send you the details. That it is project associate. We'll send you those details, and HRA and is also to be there. So what is applicable HRA for Surat, that we'll find out and let you know. Okay.
Okay.
And as Dr. Paul has suggested,
I
contingency need to be little reduced.
Now, whether SAC side review took place?
Yeah,
Yes, sir.
actually.
Yes, sir. In fact,
We have shared also the review comments also
and
all the details and
the original proposal. In fact, the title was also revised with the scope of the work. And Anirban Paul from our sensor development area, he is actually available here. As Jimit sir, he is traveling. Yeah, Anirban, you can offer your comments.
So,
No,
sir,
no. But
yeah.
why then? Why we could not address appropriately the budget slide?
There is a confusion at times that it is research or project associate. So we had told that it will be a research person. So that way, sir, it is there. We'll get the terminology, budget text, number wise, it is same, sir. Only that what it is called. Yes, sir.
Not that way. Please try to understand the moment you put it project associate, that then appropriate HRA will get added, all that, and contingency by no means you can cross 20,000. That has to be corrected. See this
Yes,
kind
sir,
of
that recent, sir, that recent guidelines are there from CBPO. So accordingly, so these were developed over part of like 7-8 months. So now we'll get the contingencies also reduced, sir. Yes, sir.
Second,
Recent guidelines are there. We'll follow that, sir.
Second thing is this compression, whether it's a lossy or lossless, whether somebody looked at
Lossless.
Lossless compression. I think
Actually, sir, this is a pre-processing before the actual compression algorithm. So the output of this spectral pre-processing will be input to the actual compression engine, which will be a 122.0 standard. So actually that standard will be dictating whether it's a lossy or lossless. But in the spectral pre-processing, the wavelet IWT and the POT, that supports complete lossless compression, while the AAT that does not support the yes, that is lossless. That is lossy.
AAT is lossy.
Because you mentioned AAT and which is lossy, that's why I raised that question. Second part is I'm just asking one more part is this FPGA space grade. I think
So actually this is not space grade. What we are the final. Yeah.
You're not looking. You look at the slide. He's mentioning space grade FPGA.
This is not. This is incorrect. Actually, this is not a space grade FPGA. KU060 is a different FPGA of this same family that is space grade. However, this is a commercial FPGA board.
Because then this tomorrow, if they say that JPMC has cleared this cost of space grade FPGA is almost 5 times. So then no time this budget will be adequate, and all that you'll jump that okay JPMC has cleared, you increase the fund. This is not a space grade. Please mention remember that, and both the things clarity should emerge. Okay, I think rest all is only one small thing which I wanted. I think timeline seems to be slightly longer. Of course, hardware, this thing is involved, but if SAC has reviewed and looked at it, I don't have much to comment.
Thank you, sir.
These are the references and acknowledgement. MNIT Jaipur, Rex here.
It's okay, that's fine. That's fine.
Thank you.
Thank you.
Thank you,
so we'll move to the last PPT.
No, sir. No, sir. Actually, this was put after the student projects because this was added later.
In the last.
Okay, so we'll break
So-
for the lunch then.
It's better to break for the lunch. That is what we wanted to announce.
Okay, fine.
And we are ringing up all the students to come after 2.
Perfect.
This
Not much of
project
time
will be
left.
presented
No, no,
by
she-
PAs only, no? That is staff only, no? Faculty only, no?
Able to come in half.
Who is going to present
We'll have-
projects?
100% will be able to.
Our side of-
Students only?
Yes, yes.
No, it is to be presented by PA.
PI will be there
Oh.
to help.
We student has
It will be the
to.
responsibility of PA or faculty.
Yeah, that is there,
He has
but
to take
the
the notes.
student has
Can
to
work in
make
that.
a presentation.
Yeah, 2:15 will join back.
We can,
Please.
Dr. Paul, Dr. Paul, SAC ongoing projects will be taken up after the lunch, after the trainees projects? As per the agenda only?
No.
Yeah, but everything is going about 45 minutes late. That is all. I mean,
So now we
we are resuming the student project evaluation, and thereafter.
Okay, so around 3:30 we'll join. We'll join
Yeah.
back around at 3:30. Yes.
Okay, that's fine. I think all others can join back at 2:15 sharply. Thank you.
Okay, thank you.
Also,
Yeah, 2:15.
they will not be part of student project.
Yeah, they will also be student. The students, madam, students project will be taken up immediately after the break. 2:50. 2:50.
Okay,
no?
so students, are they circulated to our different centers or they are independently going to present?
It will be discussed here only, presented here only. So we'll have to take all together, we'll have to take a call on those.
So you want us to be here for students' presentation? So we'll be there then in that case.
If you're interested in it.
Yeah, 2:15, ma'am. Thank you.
Okay, okay, fine, thank you.
According to India's email, in the schedule for your part 1. Just join at around 2:40. Actually, yeah, right now we are taking the lunch break. So around 2:35. नहीं एक बार कॉल करना ठीक तो मैं ये पहला ख्याल रखूँ को कॉल आप इनको बोल दीजिए वो वाला जो ऑनगोइंग प्रोजेक्ट बना ठीक है तो इसको नीचे से खोल सकते हैं सारे लोगों को Hello. Okay, so there was a little change in the schedule. So right now we are taking the lunch break. So we'll resume at around 2:15. So all the student presentation will be start after that.
Okay. Sir, after 2:15, what will be the sequence?
So sequences, first one is Miss Nilima Kolhare.
Okay.
Then second one is Dr. Alak Datta. Third one is Dr. Kunal Jaiprakash. Fourth one is Dr. Shilpi Gupta. Fifth, Dr. Majinder Singh. Sixth, Dr. Shravana Prakash. Seven,
Yes.
Dr. Rajendra Kumar Goel.
Okay, sir. Okay.
Okay.
Thank you, sir.
So everyone will get 10 minutes. So after 2:15, so you can add according to that. So whenever that time will come. Okay, thank you.
Okay, thank you.
Yeah, I think
Serial number?
No, there is no name as Nick. Okay, yes, yes.
PA is Nilima.
Nikhil Swarit.
College of Engineering, Pune.
Yeah, Nikhil Swarit.
Yes, sir. Sir, am I audible?
Yeah, yeah.
Yeah, good afternoon. Is it Nikhil?
Yes, sir. Sir, Nikhil Swarit Bidwalkar.
Yeah, Nikhil, I think is fine. You please don't go in more detail. We have gone through the submission and you please briefly tell in 3 to 5 minutes what is your objective and what you are planning to do. That's all. Okay. And timeline based.
Okay, sir. Sir,
Just
shall I share
3
the
to 5
PPT?
minutes. Yeah, please. It's visible. Just go in the full slideshow mode.
Okay, sir. Sir, is it visible?
Yeah.
Good.
Okay, sir. So we are basically trying to make a BAW filter, a bulk acoustic wave filter, and so in that way, our methodology will be in the first thing we'll see whether we want to choose a thin film bulk acoustic resonator or a surface mounted resonator. So we'll make a choice of that. Then after that, we'll do the individual characterization of an individual resonator before making the filter. So for making the characterization of the individual resonator, we will first use the textbook values of the parameters of the all the piezoelectric materials, the surface contacts and such. So we are thinking of using the ADS software, Keysight's advanced design system software, and then we'll do the characterization of the individual resonator. Then after making the characterization of the individual resonator, we are thinking of doing the actual parameter extraction, like the actual values, not using the textbook values. And if the actual values are matching with our specifications, then we'll go ahead and make the filter. So for a filter, we have a lot of structures. So the architectures are T cell, pi cell, or L cell, or the ladder architecture. So we'll select the architectures and the number of shift layers, again optimizing the process outcome, like the frequency band that we want and such, like the objectives. And for that, we are thinking of using the CAD tool such as LEdit. And then the final outcome will be the actual die, the actual wafer of the filter as per the specifications. And so for the budget, this is the budget that we have actually prepared. So for travel between SAC Ahmedabad and Pune for fabrication and testing and overseeing the process, we have allocated around 50,000 rupees. And for consumables such as wafers, the wafer carrying and storage desiccator, the wands, wafer wands, gloves and wipes, we have given around 35,000. And then we have allocated around 15,000 for the overheads and contingencies. And the timeline. For the timeline, sir, is the slide visible for the timeline?
Yeah.
Okay. So, sir, so in the first month, we'll just do the literature survey.
No need to explain.
I think your PI will take care and you are bound to finish in 1 year. Okay.
Yes, sir.
Just one small thing that you have written in your proposal. Fabrication of the device will be done at ISRO and on wafer characterization also will be done at ISRO.
Yes, sir.
Then whether this LEdit software is available with you in your institute?
Sir, I think the software's license key is not available. So, sir, we'll actually have to procure the license key, as far as I'm aware.
That's a problem.
Professor will be there. No? Professor, we can ask the
Yeah, I think Nilima ma'am, are you there?
Yeah, actually, I'm Dr. Vinay Kulkarni, and Nilima madam is not here today. There's a death in her family, so I will take the questions on her behalf.
Sorry. Anyway, I think I was looking for that LEdit which you would like to utilize it. Whether that software is available or in the institute or you are using.
So we have an alternative, like ADS, which can also do the layout. So LEdit may not be required.
No, you are committing that. That's what in write up also it is there, and you just now that student also mentioned it. It's a CAD based this thing. That's why I asked. I don't have any problem.
Right.
Otherwise, we can proceed. Only there are few issues are there. That's why I wanted to highlight it. You please proceed. I think we'll go ahead, sir.
Just be careful about the legal copies only to be used. That's one thing. Second thing is you have put 30,000 rupees as institute overheads plus contingency. If you could separate the two, it will be better. And that is all. Yeah. Wish you the best.
Contingency and what is it? But here they have given some other value in the proposal.
There was
Proposal consumable is 50 is okay, and internal travel 20,000 and contingency 15,000. Others 15,000.
Then it's okay.
That is okay.
Then
That
it's
is,
okay.
I think that will be the correct this thing.
He said some 30,000.
We can modify it accordingly. I think this will be all right. Consumable they require more.
Okay,
sir.
Nikhil, all the best, and continuously work on so that it gets completed.
Yes,
only your statement was if that matches, only you will proceed for this thing. But if it not matches, what happens? That part you have not told. Anyway, we'll proceed. Okay. Thank you.
Yes, sir. Thank you so much, sir. Yes, sir. We'll do it, sir. Yes.
Thank you.
No, you can quit now.
Thank you.
Yeah, next.
Thank you.
Yeah, Gaurav, are you there?
I'm here. Am I audible?
Yeah, Gaurav, just 3 to 5 minutes. Kindly unshare Nikhil.
Yes, sir. Unshare.
Video on color.
Nikhil, you can leave it. You can log out. Yeah, Gaurav, please proceed in just 3 to 5 minutes. We don't want any introduction or something we have gone through.
Okay, sir.
You please tell the objective and what is your focus on deliverables.
Sure, sir.
Full screen board. It's visible.
Yeah,
otherwise.
yes, sir. So, sir, as per good afternoon, sir. I am directly coming to objective then. In that case,
Just a minute.
हमारा रिसर्च प्रोजेक्ट जो हमने ठीक है
नहीं होगा
गौरव तिवारी से
नहीं, I am talking Gaurav Niranjan.
no, sir. This is Gaurav Tiwari, sir.
No.
Yes, sir. Sir,
Actually, we are going to students project. Gaurav Niranjan.
Yes, sir. I am here. Am I audible?
Dr. Gaurav, your turn might come after around 50-60 minutes, maybe.
Okay, no problem, sir. We will wait in the lobby.
Sorry for that. Yeah.
Thank you, sir.
Gaurav.
I think
Yes, sir. Sir, my screen is visible?
Yeah. Gaurav, just 3 to 5 minutes, please.
Okay, sir. I'll quickly go through the presentation. So, sir, the topic of our research is investigation of efficient deep learning techniques for hyperspectral image analysis. And the principal investigator for this project is Dr. Alok Dutta. So, sir, hyperspectral images are captured by remote sensors over hundreds of narrow and contiguous wavelength intervals across the electromagnetic spectrum. They have very wide applications like in crop analysis, mineral exploration, defense research, and many other tasks. Our research focuses on efficiently classifying each pixel of a hyperspectral image with its type using deep learning techniques. The objectives of our research are to tackle the current problems pertaining to hyperspectral image classification, like high dimensionality, high spectral and spatial redundancy, and less number of labeled samples available. The methodology that we will follow includes deep learning concepts of deep belief networks, convolutional neural nets, and recurrent neural networks. New and improved deep learning architectures like inception network, ResNet, and SqueezeNet will be applied to our task. Existing and popular hyperspectral image datasets will be used in order to better evaluate our methods. Some of these are shown here in this slide. Transfer learning and data augmentation reduce the demand on training samples, and this can be helpful in tackling the problem of less number of available labeled samples. And also unsupervised and semi-supervised feature extraction will enable the use of unlabeled data that we have to extract useful features. So, sir, the main aim of our project is identification and analysis of different types of crops or vegetation on Indian pines dataset and land cover mapping on Pavia University dataset.
Yeah, Gaurav, this is fine. We are aware of that.
Okay, sir.
You go ahead next.
Okay. Okay, sir. So the outcomes of our project. So, sir, after completion of the project, we will look forward to publishing our research in reputed journals and conferences. Computational details and the code will also be made available.
Yeah, Gaurav, what is not
Sir,
clear
here is pardon, sir.
No, what is not clear is deep learning where you are adopting in the hyperspectral imaging.
Okay, so sir, we want to learn features from hyperspectral images. Like we want to classify each picture, and for that we could have used machine learning, but what learning does is that does not see extraction by hand. So sir, by using deep learning, we will find out features from hyperspectral images in order to classify the image or a patch or a pixel, depending on our task.
It's a multi-classification kind of a thing, or?
Yes, sir. Sir, it is multi-class classification. It will be.
Tried other methods earlier. Have you studied about them?
Pardon, sir.
Support vector machines and other older methods for transformers.
Okay, sir. Sir, currently we have already applied SVMs on it, but sir, SVM does not give a good performance. Sir, that's why, sir, we will be using deep learning because it will not require feature extraction.
What about transformers?
Sir, transformers, sir, we will actually be looking into it, but sir, for starting we will be convolutional.
I think.
It's student or BTech?
Yeah, it's a BTech. 7 semester. Okay, Gaurav. I think you can proceed it. There's no problem. Okay. Thank you.
Okay, sir.
Just maintain the timeline. You have to finish it in a year. Okay.
Yes, sir. Yes, sir. Definitely.
Yeah. And thanks for maintaining the time during presentation.
Thank you.
Thank you,
Karthik.
Anyone Karthik?
But
Gaurav, please log out. Gaurav, please log out. Yeah, that's fine, but this presentation should go out. Priyanka, are you there?
Yes, sir.
Yeah, Priyanka, you can proceed, please.
Okay, sir.
You may have to close down your video. Your voice is breaking quite a lot.
Sir, now this is fine.
She's here only, no? Here only, Jay could have come here directly.
Actually, I was thinking
We didn't allow any of the students to come over. So,
And not.
yeah, please switch off your video, Priyanka.
Yeah.
Switch off the video to increase the bandwidth.
Screen. Share your PPT.
Yes, ma'am.
Your voice is breaking quite a lot. That's why we are advising you to put off your video so that hopefully there will be a better connectivity.
Okay, ma'am. Sure, ma'am. I have switched off my videos.
Now it is fine. Now it is fine. Now it is clear.
Okay. Yes, sir.
Yeah. Please go ahead, sir.
Yeah. Yeah, sure, sir. Just give me a second.
बच्चे नहीं लगाते, टीचर तो लगाते हैं टीचर, बच्चे नॉर्मली नहीं लगाते.
So, very good afternoon, all members. Myself, Priyanka Singh Chauhan, I'm going to present you the topic additive manufacturing of carbon fiber and rice reinforced polymer nanofibers for aerospace under the supervision of Professor R.K. Goyal from the
Priyanka, your slide is not visible.
Yes,
are you presenting something?
Yes, sir, I'm presenting.
We can't see you.
No, we are not able to see anything.
Just give me a second.
Unshare and share.
Now it seems you are putting up. Yeah, now she's
emanating. Sir, is it visible now?
Not yet.
प्रॉब्लम है NIT वाले कहेंगे तो अच्छा है।
मेरा भी कंप्यूटर हैंग हो रहा था यहाँ पे।
जानती क्यों ऐसा नहीं कर?
कल मुझे मैं प्रेजेंट कर रहा था, मेरे को लगा मैडम क्या सोच रही होंगी कि इनका लैपटॉप ही नहीं चल रहा है।
ITI खड़गपुर में। We can't see your slides.
Priyanka, I think if we
can come here.
Shika, can you come down here?
And
Are you in NIT right now, Priyanka?
Yeah.
Yes, sir, I'm in NIT.
Yeah, please.
So NKN1 जानती हो ना? Please come quickly.
First floor, Baba 1, NKN1.
ठीक है.
Okay.
We'll move on to the next.
Yeah.
We move on to any other
Yeah.
person. How are you?
Anyway, Karthik, are you there? Okay. Durga, are you there? Udit Mathur?
Admit कर लीजिए जो भी।
20 लोग पाइपलाइन में हैं, देखना पड़ेगा।
Ankita Kumari?
विकास हमने एडमिट कर लिया ना सबको?
Yes, sir.
Ankita, can you proceed with the presentation? Priyanka should. Oh, people are.
Priyanka, you are supposed to log off now.
वो कर दो ना।
आप for simply बंद कर दीजिए।
Sir, she is trying from my computer.
Okay, now we can see the slides. Go ahead.
Okay, sir.
Which one you are?
कौन किसकी है अभी?
Is it Ankita?
Yes, sir. Sir, myself Ankita Kumari Sinduria. Sir,
Yeah,
is my slides are visible?
Yes.
Sir,
Ankita, just take 3 to 5 minutes to briefly tell us on what topic and what is the objective. That's it.
yes, sir. Sir, my topic is design and development of highly reliable SIC GAN-based power supply unit for space mission. Sir, basically, in this project, we are going to make a DC-DC converter, which will have, we are going for 3.8 to 24 volt and up to 10 watts, low power and low noise and high efficiency DC-DC converter. Sir, we are going to use the soft switching, hybrid packaging, and the SIC or GAN based switch. If we will, if the cost will not permit, then we will go for the SIC based switch, because GAN based switch are costly than SIC. Sir, these are the some of the topology. We will go for one or two switch forward converter, one or two switch flyback, two switches push pull. Sir, we will go to the detailed literature review, and we will comparative analysis. We will choose the which topology will best suitable for our project. Sir, and after that we will choose the which PWM technique. We will go through the detailed literature review, and we will choose the which PWM technique. Here only few are listed. Which PWM technique will best suitable for our project, and simulations we will do in MATLAB. And sir, in this EMI 461E standard testing will be done, sir. Only like CE102, RE102, some of the tests which equipments available in our MNIT, we will do those tests. And for the higher level test, suppose we can go outside, or we will require help from ISRO for some other test which comes under EMI 461E standard. And this is our budget. The main expenses will with the switches, the PWM controller, the digital controller, gate drivers. The main our DC-DC converter part will take the most of the expenses, and the other fabrication etc. Will take up to 10 to 15,000, and overhead is 20,000. And this is our budget chart, and this is the time chart. And first we will go through the literature review. After then we will start the simulations in MATLAB. Then we will start the hardware fabrication, and after then we will do the verification testing, and last we will the test report writing or paper writing will be done. And these are the some important references.
Yeah. Okay. Thank you, Priyanka. Priyanka, how do you ensure two things? One is the EMI EMC protection is done for the DC-DC, and second part is how you are going to do the full complete testing so that we can adopt it for spacecrafts.
Sir, two tests CE102 and RE102 we can do at MNIT. Spectrum analyzer LISN. Some antennas will be required that we can get here, but some tests which comes under EMI 461 standards, sir, we can't do here, and we can go outside for this. Outside test services are available, or we can get help if ISRO will help us. Then
yeah, that's what I wanted to tell you. We are having a facility. You please write it once the unit is ready. It can be done at ISRO centers. Okay.
Yes, sir. Yes, sir.
Very good. Very good. I think nice effort. Keep it up. Thank you. Thank you. You can log out and unshare the presentation.
Yes, sir.
So Priyanka here, should I start?
Oh, Priyanka, where are you?
Sir, I'm here in the lab with RK Goyal, sir.
Okay. Share your screen.
Sir, I was Ankita.
No, Ankita, you unshare and log out.
Yes, sir. Yes, sir.
Sir, should I start?
Just a moment, because you have to do the sharing, no?
Yes.
Unless the first one goes, the second will not be able to.
Yeah. Oh, now Rajendra.
Yes, sir, from Professor RK Goyal, sir.
Okay. Fine.
This computer now she is logging. Go ahead, please.
Okay, thank you, ma'am. So my screen is visible now?
Yes.
Okay. So good afternoon, all committee members. Myself, Priyanka Singh Chauhan from the Department of Metallurgy and Materials Engineering, going to present you the topic additive manufacturing of carbon fibers and rice-ash reinforced polymer nanocomposites for aerospace heatsink applications under the supervision of Professor RK Goyal from Department of Metallurgy and Materials Engineering, MNIT Jaipur. Now, firstly, I'll explain that what is the heat sink. Heat sinks are generally safety devices which are used to dissipate extra heat of some electronic equipments or in aerospace industry to maintain the equivalent or safety temperature of the device. And additive manufacturing is a technique which is used to create very intricate or complex part which cannot be created by the conventional machining techniques like injection molding and rolling. Our main objective of the proposed idea are, first one is to produce the heatsink of low density polymer matrix nanocomposites for aerospace applications using additive manufacturing or 3D printing. Second one is to characterize the 3D printed product for the thermal conductivity by using thermal conductivity meter and for the coefficient of thermal expansion by using the dilatometer. And third one is to check the reliability of the product at ISRO Research Center. Now, why we are using polymers? We are using polymers because they are easy to process and they have low density. But some problems associated with them that they have higher CT and low thermal conductivity. And these problems can be overcome by the reinforcing them proper reinforcement. And there are some literature review which I have taken from some research papers that firstly I'll explain that if we add 68 volume % of the diamond powder in pure epoxy, then its thermal conductivity will increase up to 4.1 watt meter per Kelvin, and the neat epoxy has 0.2 watt meter per Kelvin thermal conductivity. And CTE can be reduced 4 times as compared of the neat epoxy, like I mentioned here, that 180 into 10 to the power minus 6 per degree centigrade for epoxy, and 48 into 10 to the power minus 6 per degree centigrade for the composites. The polymers which we are using, that first one is polyether ketone which we will use as a matrix. We are using polyether ketone as matrix material because it is a high performance polymer that it can sustain up to 250 degree centigrade temperature. And we are using filler as a short carbon fiber or rice-ash because these are the two reinforcement which can increase the thermal conductivity of the neat polymer, and rice-ash can decrease the CT of the polymer because it contains more than 90% of the silica. and silica has very good thermal conductivity. We are not using ABS or polylactic acid to manufacture the heat sink because these are the two polymers which will degrade at that much of aerospace in environment temperature. What is the effect of silica on thermal conductivity of polymers? Generally, we are using Rice's ash to extract the silica because it contains more than 90% of amorphous silica, and the silica will increase the thermal conductivity of polymers, neat polymers, up to a significant limit. The example I'm telling you that silica coated multi-wall.
Priyanka, don't read all the things. Just tell us the gist. By this time, we have read your slide.
So next
Okay,
slide.
sir.
And try to be very quick. Within 2 minutes, you have to finish off.
Okay, so the first one is I'll explain you why a table I have plotted. That from this table you can clearly see that by using silica coated multi-wall carbon nanotubes, we can increase the thermal conductivity up to 51% from 0%. And for polyurethane, we can increase 26% thermal conductivity at 0.58% of multi-wall carbon nanotubes. And if we increase the quantity of carbon nanotubes, then thermal conductivity surely will increase up to a significant limit. We are using carbon fibers. Generally, carbon fibers have very much higher thermal conductivity, around 1000 to 1200 watt per meter per Kelvin. That's why we are using it as a reinforcement in our polymer matrix. The methodology which we'll use, firstly we'll prepare rice husk ash in our laboratory by heating the rice husk at 700 degrees centigrade for 12 hours. Then we'll mix it with then we'll coat it graphene to increase the electrical conductivity and thermal conductivity as well. And then by using an extruder, we'll make the filament to feed in the 3D printer. We have Credboard Peak 300 model in our laboratory. And then after performing
Go to next, Priyanka.
Okay, sir. And so generally, ISRO is working on the spacecraft and whose main objective is to reduce the weight. We are using polymer; they have low density, so overall weight of the vehicle will reduce, and we can increasing by thermal conductivity and reduce the CT as well as by using proper reinforcement. This is the
Okay.
project which I am.
Okay, Priyanka. I think it's understood. Very good. I think keep it up. You're on the right track. And I'm sure that this will come out nicely for a space application. Okay. All the best.
Okay. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Please log off and remove your presentation.
Okay.
Udit, are you there? Udit, are you there?
Yes, ma'am, I'm doing it.
Durga or
Called me, Dr. Kunal. So he's saying his student is sick, so he want to bring. He's online.
Yeah, he can present. Kunal can present it, no problem. Question number 3, that Kunal.
SCL, who is it?
No, SCL is
Dr. Kunal, serial number.
Okay. Is it Dr. Kunal?
Yes, sir. Good afternoon, sir. Am I audible?
Yeah, very much. You please proceed.
Sure, sir. Yes, sir.
And only 5 minutes are given, please.
Yes, ma'am.
Sitting near me is a student.
The student is there, but not just having throat infection.
Right.
Okay.
So better to sir. So COVID is affecting throat as well as GIT.
Yeah, good afternoon, respected panel members. I'm Dr. Kunal Borse from the Department of Metallurgical and Materials Engineering, and along with my student, Mr. Adari Karthik Vinay Kumar from BTech final year. We are here to present the proposal titled Development of a Novel Method for the Synthesis of Printable CIGS ink for Solar Photovoltaic Applications. So this is the outline of our presentation.
Please skip.
Dr. Kunal, straight away you go to our basic objective and what you are planning to do. That's it. Only 2 slides.
Yes, so existing method for CIGS have limitations. Say those are costly processes and complex processes, and one can get non-uniform coating if you go for larger substrate. While for non-vacuum based techniques, we need to go for two-step processes, out of which second step is salinization process, which is a complex process, and one has to go for more than 150 degrees Celsius temperature to achieve it. So the major objective involves novelty in the synthesis of printable CIGS ink, where we are proposing to prepare the synthesis the CIGS ink in single step, and the temperature would be lesser than 80 degrees Celsius. So the main objective is to develop novel method for synthesis of printable CIGS ink, and we have divided that in 4 sub objectives. First one is to optimize various processing parameters such as concentration of precursors, pH, and temperature for getting CIGS ink. Second objective is to characterize CIGS ink using sophisticated characterization techniques so as to confirm it. Third thing is, third sub-objective is to characterize CIGS ink for its printability, and fourth one is to optimize its parameters so as to get particle size lesser than 1 micrometer and viscosity lesser than 20 centipoise in order to make it more printable. So this is the proposed methodology where we have already started simulation studies using GROMAX software, which will help us in determining suitable temperature at which the reduced atoms can get arrange themselves in tetragonal crystal structure of CIGS ink or CIGS compound. Second stage involves synthesis of CIGS ink. So basically here we will take one, we are planning to take one solvent. Here we are proposing DI water, where in which we mix, will dissolve the salts of various constituents of CIGS ink. Then we'll optimize the pH and temperature, and using those optimized parameters, having vigorous stirring, we will add reducing agent to it so that those atoms, those ions will get reduced to respective atoms and having sufficient energy to arrange themselves in tetragonal CIGS crystal structure. Third step involves characterization. We'll confirm the presence of CIGS using XRD and UV visible spectroscopy. And finally, we will do its printability check, and we'll make try to achieve the particle size lesser than 1 micrometer and viscosity lesser than 20 centipoise. So this is the linkage and relevance with ISRO. The use of solar panels is inherently there to power the space application, but currently multi-junction 3-5-way solar panels, say gallium arsenide, are used.
Yeah, Dr. Kunal, this you skip it. We are fully aware. Now, only my alert to you is anyway, I think the solar cells, what is being adopted, at what temperature they function it, because you mentioned about the viscosity and formal printing. I think be little more careful while making it a comment to ISRO applications. Okay. Otherwise, it's very good. Usually the temperature at G1 LEO missions, it touches almost 60 to 70 degrees Celsius itself. And before that itself, from 30 to 40 degree onwards, the power generation starts with the efficiency varying from 15 to 27. So you please look at it and then you please. Okay, good.
Yes.
Thank you.
Sir, this one is the last slide that event and prior experience we have right now successfully.
This is fine. This is fine. I think we have gone through that. Okay.
Sure.
Okay. Thank you. Keep it up and get well soon, Karthik.
Thank you, sir.
Thank you. I think be away from your faculty. It's a COVID time.
I asked him to wear mask, but it's fine for the
No
present.
problem. You are not wearing mask. That's why I alerted. Okay. Durga, thank you. Please log out and share.
Yes, sir. Yes, thank you.
Durga or Udit Mathur?
Yes, sir, I am here. Udit Mathur.
Yeah, I think Udit ji, can you please proceed? Just 3 to 5 minutes. We want just what is the objective and how you are going to achieve it. That's it.
Yes, sir.
Your voice is very feeble. Can you come closer to mic?
Yes, sir, I am audible now.
Yeah, now it's okay. Please proceed.
Sir, is the screen visible?
Yes. Go in slideshow mode, please. Slideshow mode. Yeah, now you proceed fast.
Good afternoon, all of you. Myself, Udit Mathur, and I am pursuing MTech in Thermal Engineering under the guidance of Dr. Manjinder Singh. So my short-term project proposal will be on the topic diode heat pipe for the electronic cooling in satellite and spacecraft. So first we have to start with what is a heat pipe. So heat pipe is a heat transfer device that employs the phase transition to transfer heat between the two solid interfaces. So in the heat pipe, we use a wick structure to transfer the liquid working fluid from one place to another. But here we use the concept of the diode heat pipe to transfer the liquid working fluid from one place to another. As shown in the figure number 4, that we have a taper cross-section capillary. If we see this figure from the left side, we get a converging cross-section capillary, due to which we get a concave shape meniscus, due to which the liquid imbibes into the capillary. And if we see this figure from the right side, we get a diverging cross-section, and due to which we get a convex shape meniscus, due to which the liquid working fluid will come out of the capillary. As shown in the figure number 3, that we have a micro heat pipe. So in the mid section of this micro heat pipe, we have a vapor flow from the evaporator section to the condenser section due to the vapor pressure difference between these both section. And at the outer section of this micro heat pipe, we have a liquid flow from the condenser to the evaporator due to the different radius of curvature between these two sections. So our objective of the project is to design, fabricate, and experimental analysis of the diode heat pipe to obtain the one-way heat transfer for the electronic equipments used in the satellite and spacecraft. Now moving forward to the methodology. So in the first stage, we will fabricate the micro heat pipe channel with the help of the electronic discharge machining, in which in this we will decide what will be the material of our micro heat pipe and the dimension of the micro heat pipe. In the second stage, we will do the airtight bonding between the multiple micro heat pipe to form an array. In the third stage, we will fill the working fluid inside the micro heat pipe. But before doing that, first we have to evacuate the non-condensable gases from the micro heat pipe, so that it does not flow along with the vapor phase of the working fluid, so that it does not hamper our heat transfer process. Now moving forward to the experimental setup, we have a micro heat pipe. The left side of the micro heat pipe will act as a evaporator, and right side of the micro heat pipe will act as a condenser. So we will provide the heat to the evaporator with the help of a resistance heater, and we will provide the liquid cooling bath to the condenser with the help of a cooling unit, in which the coolant is filled and it is pumped with the help of a parallel pump. After taking the heat by the coolant from the evaporator, this coolant will be cooled with the help of a Peltier cooler, and all this data will be recorded by the data acquisition system and stored in the desktop or PC. This whole setup will be enclosed in a closed chamber, so that no convective losses will be occurred to the surrounding. Now here is what we can deliver to the ISRO. Here are the some list of the electronic equipments which are used by the ISRO in their satellite, and their operating range are given as follows. So we will fabricate the prototype of the diode heat pipe for the experimental analysis to provide the passive, reliable, and low maintenance.
Yeah, Udit, you can move on.
Yes, sir. Here I have the budget for my project. So I have cost of rupees 40,000 for the equipment, 35,000 for the consumable and supplies.
I think that's fine. Which equipment you are planning, Udit?
Sir, diode heat pipe, to fabricate the diode heat pipe for the to obtain the one-way heat transfer process.
No, just a minute. What did you tell? I could not pick it up.
Sir, we will fabricate the diode heat pipe to.
No. What you want to procure instrument? You have written no 40,000.
Sir,
what do you want to buy?
Sir, pump for creating the vacuum inside the micro heat pipe, and for creating the vacuum inside the closed chamber in which the whole setup will be enclosed.
Udit, you go through little more technically, okay? Already these things we have realized. I am heading this particular section. I'm just telling you this. All these things, what you call it, what is the working fluid?
Sir, working fluid will be, it will depend on the temperature range of the electronic equipment.
What is a planned working fluid, Udit? I think you just concentrate little more on that, okay?
Sir, if we take the water, we will get the temperature range of 1 degree Celsius to 325 degree Celsius. If we take.
Have you not heard about 4 degree issue with the water?
Yes, sir. I have heard.
Then how 1 degree we can adopt? Okay, you work on that, okay?
Okay, sir.
What is the difference between satellites and spacecraft? You picked up the title like that, no?
Yes, sir.
What is difference between satellites and spacecraft?
Sir,
there is no word in English like spacecrafts. Okay, you just correct the title appropriately. It just keep satellites or just keep spacecraft.
Okay, sir.
Okay, and working fluid, you right now I am recommending you take ammonia. Okay.
Okay, sir.
That will be having a spacecraft application. Okay, you log out. All the best. Okay. Thank you.
Thank you.
Durga Prasad, are you there?
Yes, sir. I'm there. Yes, sir.
Yeah, please, you try to finish it off in 3 to 5 minutes. Concentrate on what is the objective and straight away how you are going to achieve it. Only 2 slides, please.
Sir, is my screen visible, sir?
Yes. Durga, straight away come to only 2 slides. Give me
Yes, sir.
objective and how you are going to fulfill it.
Yes, sir. My topic is polarization tunable circularly polarized antenna with graphene for
Slides are not
KM
visible
application.
yet. So please share your slides.
Sir, screen is not visible, sir.
You move on. Your slide is not changing.
Sir, yes, sir. No, sir.
It is not visible itself. Your name itself is coming on the screen.
Sir, now I changed,
These
sir.
are not properly shared still.
After this,
Please reshare.
after this new project, one pending new project, or after this?
One
Four
more new
ongoing and
project.
one pending.
Yeah, but which one we are going to take up? First project.
New project.
So one is pending.
That you will after.
Sir, now, sir?
Because others can.
Yeah, now it is visible.
Yes, sir.
Go
sir,
ahead.
Sir, mainly my main motive is the
Take it in full screen or show slideshow mode. Press F5, full screen,
Yes, sir.
slideshow. Yes, now go ahead, please, quick.
Yes, sir. My project is polarization tunable circularly polarized antenna with graphene for Ka-band application. The main motto is that to increase the frequency tunability by changing of Fermi level. The Fermi level is changing by applying the DC voltage bias applied to an external electric field. The main objective is that polarization tunable graphene antenna for Ka-band application and fabricate and test the antenna return losses and polarization tunability and radiation patterns. The main we are going to the first literature survey. After that, we are going to the graphene antenna prototype in CST and circularly polarized through the antenna, which is the taking as the return losses, and it is desired to be if it achieved, and we go into the fabricate the return losses and check the antenna and return losses and test the antenna radiation pattern. If optimized, we go into the further process as the finalized design. And the main expected outcome is that the study report containing study results and other techniques and after that we are going to the CST simulation antenna design and fabricated antenna and publications. These are the budget we are going to the expected, like the total amount will be the 17,500. And these are the time schedule we are going to the first we are going to the 2 months we are going the literature survey along with the antenna design in the formation of 2 to 6 months and antenna development, and again we are going to the experiment setup and validation report. These are
Okay.
Yes, sir.
Very good, Durga. Just
Yes,
one small query.
Yes, sir.
This material, whatever you picked up, graphene.
Yes, sir.
Is it suitable for Ka-band?
Sir, actually, it is suitable for terahertz. We are going to the implement in the form of Ka-band, sir. That is our motto, main motto.
But then this you are telling it's a tunable, no? The polarization.
Yes, sir, tunable, sir. Like we are going to the RHCP to LHCP and LHCP to RHCP, sir. Like we are going to tunable.
But is it a circular also? Polarization is possible?
Yes, sir. Circular polarization is possible, sir, here.
Because you are aiming circular and you are telling RHCP, LHCP.
Sir, mainly in the circular polarization, the two are there, no, sir.
No, what is your objective? You are going for circular polarization, right?
Yes, sir, circular polarization.
Okay, fine. I think it's okay.
Yes,
That is fine. Only thing is look for the characterization because it all changes because of the polarization. Okay.
Yes. Okay.
The
Thank
power.
you.
Just
Yes,
concentrate on that. Thank you.
Okay. Thank you, sir.
Thank you. Good luck.
Pending,
Please log out and unshare.
Usually we need one more copy from MHIT.
Please, there.
There it's there. Okay.
Yes, explore all the PDFs and not found it.
Got it. Okay.
Dr. Alok Amar Patnaik.
Okay. That is why yesterday I checked with VSSC. They told it is on.
Gaurav Tiwari?
Yes.
Yeah, please share your screen. Yeah. Please go ahead. Try to restrict yourself to 8 to 10 minutes. You can skip introduction to a good extent, and rest of the things can be covered then. Please go ahead.
We are not able to hear you. Have you muted?
Are you able to hear me, sir?
Yeah.
Okay. Good afternoon, sir. Myself, Dr. Gaurav Tiwari, and I am here with my co-PI, Dr. M.D. Goyal. So we are presentation on the design and demonstration of empty and form filled honeycomb structures for energy absorption during crash and impact. So as a background, like the crashworthiness is the ability of the structures to protect its occupant during an impact, and commonly it is used for the safety purpose for the aircraft and vehicles, and improvement in the crashworthiness of the structures can be achieved by the good energy absorber. So as per the application in the automobiles, here I have shown with respect to the schematic diagram. So if the structures of the energy absorption during the impact, if it is weak, then the complete reaction force will come to the occupants. If it is very stiff, then the complete reaction force will come to the occupants. So in that regard, in this context, we want some balanced structures, so which should absorb the more and more energy, and it should be the deformation should be the stable, and it should be low weight and high specific energy absorption, and reaction force should be minimum. So in this regard, if suppose we see the literature, so mainly the 4 different type of structures has been studied, like a tubular structures, lattice structures, sandwich structures. Similarly, the honeycomb structures with the different materials, okay, and the metal forms and non-metal forms. So if we will talk in terms of the comparison between these 4 type of the structures, then in the literature it is found that the honeycomb absorbs the most maximum energy if you will talk in the identical weight, and if suppose we will talk in terms of the form, then it is excellent energy absorption capacity. It's a roughly isometric, and different metals and non-metals forms has been used in the crashworthiness application. When we crush any sandwich structures, then this is the complete load versus the displacement diagram, and we can divide the complete energy absorption process during the collapse of the any structures in the 3 forms. So first is the pre-crushing zone, the second is the progressive crushing zone, and the last one is the densification zone. So here, if you will see the maximum energy absorbed in the progressive,
you can move on. I just for your information, Chandrayaan 2 and Chandrayaan 3 both are using this crushing honeycomb structure for the landing. Okay, so we are fully aware. Just go on.
Okay, sir. Then directly I am coming to the objective. So here we are proposing the this crushing response of the form filled aluminum honey.
We lost you, Gaurav. Gaurav, are you there? Gaurav, please confirm if you are there.
Otherwise, you'll have to bring him up.
Gaurav, we lost you. Can you start from beginning of this slide? We are not able to listen you, Gaurav.
Which propose the structure can sustain safely and effectively, and to study the different type of core geometries. Okay, so these are some objectives out of the proposed study. And regarding the scientific and technical needs aspect, so proposed sandwich panels with the 2 different type of forms we are using in the proposed work, and it will helpful to minimize the effect of the impact on ongoing vehicle and the scenarios. So further, it will enhance the passenger safeties by providing the enhanced energy absorption during impact. And this is the methodology we have proposed, that First, for conducting the analysis of the aluminum honeycomb panel, conventional as well as the foam filled one. So we are going to use the first mechanical test for the characterization. So we will get these diagrams, stress strain diagram and Hopkinson bar test. So stress strain behavior under the quasi-static and dynamic loading. And we will conduct the experiments by drop weight impact tester and static compression test. So here the schematics I have kept. Similarly, we will see the parameters for the mass and velocity of hammer, honeycomb cell size, cell wall thickness, cell expanding angles and foam materials. Again with the non-metals and metals. And finally, after analysis of all these parameters, we will develop the foam filled honeycomb panels with the best probable way. And after that, some prototypes will be provided to the ISRO. So this is overall plan regarding the work, and this is the facilities which is available in a VNIT. So one is the pressure gun, pneumatic pressure gun, and the right side Hopkinson bar test is there. So its velocity range is 20 to 150 meter per second, and licensed version of these numerical softwares are also available in VNIT. So Abacus, LSDANA, ANSYS is there, and highly computational facilities are also available, workstations. For some of the characterization machines like Instron, UTM and compression testing machines, they are also available. Other than that, we are able to access some experimental facilities which are available in IIT Roorkee, IIT Delhi and JNRDC, Nagpur, to carry out the experiments. And expected, yes.
Yeah, move on. I think it's known. Yeah.
Okay. What are the expected deliverables are there? So it will provide the guidelines to develop the lightweight structures which will offer the better energy absorption before collapse. And we will get the most influencing parameters of the foam filled honeycomb panels regarding their densities of the foams, regarding the wall thickness, regarding the cell size, static and dynamic loading, again in the out of plane and in plane directions. And a proof of concept of the product capable of the withstanding a design crash and impact load with the improved the parameters will be proposed, and outcomes of the proposed study, possible establishment of a startup by the student in a near future under the Atmanirbhar Bharat Abhiyan. This is the overall work plan through the Gantt charts we have proposed from almost up to 24 months. So procurement of the specimens first 4 months, and similarly material testing and material characterization. Then experiments regarding the longitudinal lateral directions of the honeycomb, foam filled and conventional honeycomb. So we will do in the 8th through 12th months. After that, a numerical simulation of the proposed work, and at the end, publication and report writing for the ISRO guidance. This is the overall budget we have proposed for the proposed study. So consumables 8 lakhs and travel is 1 lakh 50,000. Similarly, 5 lakhs for equipment and 50,000 for contingency. 3 lakhs overhead and total overall cost is 18,000. This is the again subdivision of the budget regarding the different time periods. This is the milestone of the budget requirement, that the justification of the budgets we have proposed. So we have written like in the different manner for the characterization, for the conducting test, for the simulation purpose. And at the end again, like what are the social impact is there for the outcome. Similarly, what are the marketability is there for the startups, and similarly the how it will help the students to become the future entrepreneurs.
Yeah,
So
yeah, Gaurav, that's it. Venkateswaran, are you there?
Yes, I'm here, sir.
Can you offer your comments?
Yeah, actually, sir, this is the reason for the starting proposing this or Yukti Sanchita in proposal is to have the first thing is to have a clear understanding of our how aluminum foam or a honeycomb foam filled honeycomb structure can be employed, and that design how it can be done. So that is to have a generalized design so that it can be extended or upscaled for the our vertical landing vehicles of VSSC in the future also. And another thing is for the manned missions where we need energy absorption in both bidirectional way for the crew seat. So this is the main reason for which we started this proposal, and where our professors have already presented. and our basic understanding of the system and its theoretical modeling will be made. That is one objective. Another thing is, once a prototype in a modular fashion is there, it can be scaled to any requirement in the future. That are the observations. I feel that our my ideology of our presentation is, whatever presented is fine, sir. And further you can decide, sir. Thank you.
Dr. Gaurav, I think you made a statement that material overall is isometric, is it?
Yes. Approximate isometric, sir. We have written.
No, not
isotropic, sir. Aluminum foam. Since
not.
holes are.
It is basically anisotropic material combination when it comes to. I think Venkateswaranji will correct it if I'm.
Yeah, it's basically an anisotropic substance, but because of its structure. But since the our properties, since the holes are almost randomly distributed in all the directions, sir, by test it has been shown to be approximately isotropic.
Yeah, that's fine. And second thing is that core dimension, core configuration is highly important for this kind of design, which you have not shown. Probably you will be addressing all that in more detail. So I think we don't have any problem. Only thing is the simulation. Anyway, you have the appropriate tool.
Right.
So
Yes, sir.
I think Abacus is there and Storm there. I think it's a good idea. We'll proceed. I don't have any issue. Any comments from any other JPMC members?
Sir, Venkateshwaran here. Just one point to Dr. Tiwari.
Yes, sir.
That equipment you are listed for the 5 lakhs and the expenditure you have shown for the first 6 months. That can you just elaborate? I think I missed.
Sir, some of the add-ons we want to improve in the existing facilities, and for that we have asked about this money.
Yeah, I mean the next page that because okay, first quarter itself, first half itself, you want to spend the 12.35. Okay, that's what I missed that point. Okay, thank you.
Venkateswaranji, I have not gone through this in detail, thinking that you have reviewed it.
Yes, sir. Reviewed only that. The doubt was that 5 lakh was only seen, and the second page, I think that display was not coming properly. I saw suddenly 12 lakh. Suddenly, that's what I was having a doubt.
Fine.
It is actually correct only. Thank you.
Okay, thank you, Dr. Tiwari. I think you can proceed. Be little more careful because honeycomb modeling is very carefully we have to do it. Okay, thank you. All the best.
Thank you, sir. Thank you very much. Thank you, Dr. Venkateswaran. Thank you, sir.
Thank you.
Yeah.
Next.
Ongoing projects.
We have covered.
Ongoing, I don't have anything. I want a status very clearly. Yeah.
So वैसे भी सर हमने 20 मिनट कवर कर लिए हैं.
You are requested to leave.
So now you're only 20 minutes late. Not 45 minutes.
Yes. Go this available.
The server is available.
Second.
Please ask them.
He has already.
No, Tiwari ji, please unshare and log out, please.
Yes, sir. Thank you, sir. Thank you.
Thank you. Yeah, Dr. Sarkar,
Yes, sir.
are you there?
Yeah, I am here.
Okay, you can share your presentation. Because it's an ongoing project, I want to review only the status and have you reached the milestone which you have claimed and committed to ISRO. That's why. And what about the status of the financial expenditure?
Okay, so shall I skip the introduction and objective parts, or shall I directly jump to whatever done so far?
Yeah, that is better. And you come closer to mic, Dr. Sarkar.
Is it okay? Is it better?
Slightly better. Or can we increase the volume for that our end?
Increase the volume further.
Yeah, Sarkar ji, go ahead.
Yeah, is my screen visible?
Yes.
It is visible, right?
Yeah.
Okay, shall I start, sir?
Please proceed.
Okay, so my project is based on my project is nanostructured carbon electrodes for high voltage hybrid ion supercapacitor, and I am the PI of this project with the co-PI Dr. Manoj Kumar from MNIT Jaipur and Dr. Sujata S from VSSC Trivandrum. So shall I skip the introduction part?
Yeah, definitely.
Okay, fine. So our main idea was to develop some novel nanostructured carbon materials for hybrid ion supercapacitor, which is actually a combination of a battery electrode and a capacitor type electrode. In this scenario, we have proposed different procedures to develop novel nanostructured carbon materials from different sources. Like these are I am now depicting the slides. Those show the carbon materials that we have developed so far. So first carbon material was derived from a ZIF, which is zinc methyl imidazole framework, which is a metal organic framework. We've synthesized this metal organic framework through chemical route, and we pyrolyzed that synthesized material to generate nanostructured carbon. So the left hand side is a left hand side is the nanocube carbon that was prepared with the addition of a surfactant, and the right side image shows you the same carbon, but it is polyhedron shaped. So we have created two different shapes of carbon materials with the different sizes, shape, and different properties. So this is the one procedure we followed to prepare carbon morphologies. Second procedure, we used a biomass. It is actually moringa gum derived carbon material. We use the biomass as a source to derive carbon. We simply pyrolyzed that biomass to derive the carbon, and further we have activated the carbon using a material called the potassium hydroxide. So the left hand side is the ACM image, scanning electron microscope image, that shows the nature of the carbon, that is before the activation procedure, and the right hand side image shows you the activated carbon, which was activated using KOH. You can see that significant change in morphology, where you can see that after the activation part, after the activation, the surface area increases significantly, just can be visible using this thing. And we have actually further characterized this carbon in aqueous electrolyte, because the other method is not available here so far. So this is some of the electrochemical property of the biomass derived carbon in aqueous electrolyte. So the material shows a capacitance of around 120 farad per gram at 1 ampere per gram, and it shows a very good retentivity, because there is a negligible capacitance drop when you increase the current density by almost 10 times. The material also shows a significant structural stability. We have cycled the materials over 10,000 cycles, and you can see that there is no decay in capacitance. So material is highly stable for this kind of electrochemical analysis. And when you measured the same material inside a full cell, that is called the 2 electrode cell, we can achieve a potential window of 2 volt almost, because this potential window is limited just because of the aqueous electrolyte, which can sustain a potential, which can sustain within 0 to 2 volt. So our idea was to use this material to achieve a voltage of around 4 volt using lithium ion based electrolytes. So this is the deliverable of our project. We would like to develop a prototype for a high voltage hybrid ion capacitor. The output voltage should be around 4 volt in hybrid cell configuration, specific capacitance around 50 farad per gram, more than 50 farad per gram, energy power density in excess of 100 watt per kg and 10 kilowatt per kg, and life cycle of the prototype hybrid device using lithium electrolytes, lithium based electrolytes, is more than 10,000 cycles. So these are our objectives, but we have only achieved almost 0 to 2 volt just because of the unavailability of a certain required system that is required to assemble the lithium ion based cells. And what is the relevance with the ISRO is that if this kind of hybrid ion capacitor being developed, then these hybrid ion capacitors.
Dr. Sarkar, you leave relevance. You leave next.
Okay, sir. Okay, and this is the budget details. This is the total amount of budget that was sanctioned, and main part was in the equipment, which is under process and almost finalized. And the right hand side table shows the total released amount for in the first quarter only, where the equipment part is almost utilized and the consumable internal trouble contingency part are completely utilized, and we haven't received any fund after the first quarter.
Second year money to be released.
Yeah.
Okay, so it's been almost a year now, but after the first quarter, we haven't received any fund.
Yeah, we know that.
Okay. And sir, there is a additional fund requested.
Just a minute, Sarkarji.
Yes, sir.
Yeah.
So your second year grants of 4 lakhs to be released, right? 4 lakhs. 4 lakhs is pending.
Yes, almost 4 lakhs.
Yeah. And some balance of the first year.
Sorry?
Some balance amount of the first year and the 4 lakhs for the second year is pending.
Yes, sir. Yes, sir.
Yeah,
yes.
Correct. Yeah.
Okay.
Okay.
Sir, apart from this thing, I had already mentioned there is some need of additional fund because we have already almost procured the globe box that is sanctioned under this project, but just because of the budget limitations, we couldn't have this moisture sensor for the globe box, and we need a coin cell crimping machine that is necessary to assemble coin cell inside the globe box. So I request to consider this amount, almost 4 lakhs, so that we can procure these minor equipments and to start assembling the coin cells inside the globe box and to achieve our proposed objectives.
Just a minute, Dr. Sarkar.
Yes, sir.
Sujata ma'am, are you there? Sujata madam?
Sir, Sujata ma'am, she's not able to meeting. So she has, this is Santosh from VSSC.
Okay.
Yeah. Santoshji, 2 aspects I want to ask you. One thing is he has given in his write-up the activity which is completed in a year. And
yes,
expenditure also, basically the expenditure has almost 90% gone towards the equipment only. Equipment is still not there. And in addition, now this fund is coming. Was it not discussed at length what is the end output and what is required for producing that kind of product? We have no means by JPMC clearing the additional fund. By no means we can clear it. Was it not discussed at length?
No, sir. In the beginning, this part was not envisaged, sir. It was the total amount mentioned for the, the equipment was 21 lakhs, sir.
No, but Sarkar, you please understand, Dr. Sarkar, you are telling that unless until this fund is given to you, you will not be able to complete the project. Is it so?
Yeah, it will be helpful if I receive the fund from this project only.
Sarkarji, my question is very pointed and focused. I am asking you, you had a written proposal. In that proposal, whatever is the objective, without this fund, whether that objective can be met or not. That's all I want to know.
Yes, it can be met.
That's all. So I think, Paul sir, we will not add this in the present. Okay? No. And I am not having any authority to increase the fund right now. Whatever is approved only. Okay. And Sarkarji, I have another just last point to tell you.
Okay, sir.
Because I hope our activities are going on because you have even taken the XRD spectrum also, and you ensured that already you are getting whatever desired property was there in the nanotube. So I feel you are already on the job, and in remaining time, you'll be able to complete the project. Yes or no?
I will try my best, sir, and I think we can complete the project objectives within due course.
Thank you. I think you can proceed it. We will recommend to provide this budget at the earliest so that you can do that. This additional fund we are not having an authority to clear. It is being questioned at a different level, so we will not be able to clear this. Okay,
okay, sir, I got your point, sir.
Thank you. Thank you. Any other member, any query? Gupta sir. No, sir. Okay, Paul sir will clear. Okay, fine. Thank you, Sarkarji.
Okay, sir. Thank you.
Please log off.
Sarkarji, can you log out and unshare?
Yes, sir. Sure, sir. Sure.
Yeah. Next, who is there?
Sir.
This one, I mean, Dr. Rahul sir called me and he was not available, so he will present. But
No,
he told that he has already joined, but I can't find him. He just
Dr. Umesh or Dr. Rahul, are you there? Dr. Umesh?
Rahul sir is inside, but he told that Umesh sir is already there.
No, but Umesh is not responding. Dr. Umesh, are you there? Can you respond, please?
They are all from here only, no? Community only. All courses.
Thank you.
Is it Dr. Umesh?
No,
He's not able to hear us.
This one not in participant.
No, this conference table itself is ISRO's conference table. I can take it out. Okay, fine.
कृष्णा कुमार सर कृष्णा कुमार को ले लो
जो भी जी को भी उसको
Dr. Rahul Singhal was seen sometime back in the meeting. He was there in the meeting sometime back.
Yeah, but now he's not there, ma'am. I think he requested that Dr. Umesh will take over.
Okay,
But,
sir,
Dr.
SAC
Umesh-
PI is Dr. Hegde and Bhuvaneshwar Semwal. Both are here in the meeting.
Correct, ma'am, but
You can call their counterpart.
they can contact Dr. Umesh if they can.
सर आप पूछिए डॉक्टर पूछिए
Okay, I think we have called him. They'll be joining shortly.
SCL people are also there. It's connected to SCL actually. This project, yeah, it is a coordinating center is SCL, one particular project. First one.
The first one.
Not SAC. It was taken up.
So take Dr. Bulchandani.
Yeah. Is it Professor Bulchandani?
Yeah, I am here, sir.
I think you can show the presentation and start. We want to just discuss what you have achieved and committed. Where is the gap, and if everything is fine, what is your commitment for the duration now, pending duration?
Okay, sir.
No, which one is?
You have the right to share.
SCL participants, SCL.
No, but he has to.
I think when you will share it.
Okay. Now he shared. Yeah, okay. Fine.
Sir, my screen is visible.
Yeah, visible, Mulchandani sir. I think just concentrate on only two aspects, sir. We have very less time now.
Okay. Sir, my project is on charge pump PLA frequency synthesizer. So I am skipping all the things and I am coming to the specifications that were given to us in conversation with SCL Chandigarh, sir. So this is the block diagram and these are the different blocks. That is phase frequency detector, charge pump, low pass filter, VCO, and the divider circuit. The purpose is to generate an output frequency which is as stable as the reference frequency. This reference frequency is a crystal frequency and generally a low frequency, whereas this output has to be multiple of this so that we are able to cover a very wide range. So these were the target specifications, sir. That is input frequency range 5 megahertz to 65 megahertz. This was a loop divider. Output frequency range, this is a very wide range, 140 megahertz to 1.82 gigahertz. This is quite critical and we have designed the circuit so that this output frequency range is met. Block frequency range 50 to 100 megahertz. Phase alignment error should be less than 100 picoseconds. Settling time for step charge 250 nanoseconds, less than. Locking time less than 500 nanoseconds. Loop bandwidth 1 megahertz. And another critical point here is the VCO phase noise has to be less than minus 85 dB C per hertz. And the supply voltage was 1.8 volts. So, sir, we have done the front end layout for this. These were the objectives. I am coming to the methodology that we had adopted. From design specs, we have a different specs which I had shown to you. And then
Professor Bulchandani, I think this we can skip Because already you adopted and arrived at certain configuration.
Yeah,
And
yeah.
we want to look at the status, present status, please.
Okay, sir. So I am skipping the theoretical part. Behavioral modeling also we had done on the MATLAB, and we had arrived at a loop bandwidth and the RC, that is the loop filter constants for achieving our specifications. This was the starting point. That is through behavioral modeling, we reached to a certain design values. From there, we built up our circuit. So these are the different blocks diagram outputs, sir. Target specification was 5 to 65 megahertz. We had achieved that our phase frequency detector is working from 0.2 to 20 megahertz. These are the results which confirms that our circuit is, this PFD block is working very fine.
Yeah, fantastic, sir. Fantastic. I think we can move on. I think you have achieved a great.
And this was the phase, that was the phase error that we had calculated. It was minus 162.66 for this. And then, sir, we designed the charge pump and low pass filter so that whatever is the signal we get from PFD is converted into a voltage, and that error voltage drives the VCO so that its output frequency is same as that of the reference frequency. That was the circuit for the loop charge pump.
I think all this is skip. You tell us the status present.
Okay, sir. This was a log time that we have got. It is 458 nanoseconds that we are getting. And this was a VCO that we have implemented. And this is a differential ring oscillators which we have implemented so that the phase noise is less and we are able to get a wide frequency bandwidth.
Very good. Yeah, I think excellent piece of work, sir. Very good. I think come to status, I think you have achieved a lot.
Leave all these technicalities because these have been already evaluated.
Okay,
Yeah,
okay, sir.
back at
I'll come to the. This was again, sir, our ring oscillator. That is, this is the control voltage, and this is the wide frequency range we are getting it. Sir, the actual range given to us was 140 megahertz to 182 gigahertz. We have achieved 37 megahertz, which is lower than 140 megahertz, and 2.79 gigahertz, which is greater than 1 point. So this is a wider bandwidth which we have been able to achieve. Further, the noise specification was given as minus 85 dBc per hertz. We have achieved minus 102.2 dBc, which is a better noise, phase noise, because this is more negative. And this specs also we have achieved.
Still skip it. You have done more than.
Professor Mulchandani, this forum is looking for the clearance for the coming year, the financial and status. That's
Okay,
it, only two objective. Technical criticality, our PI might have looked at it and reviewed it.
Yes, sir. Another thing that they in the review had suggested to do the PVT analysis, and they had asked us to do the process variation, that is process variation, voltage variation, and temperature variation. This they had mentioned in their review. What was missing was we had done from the temperature minus 40 to 100 degrees Celsius. They asked us to do it from minus 40 degrees Celsius to 125 degrees Celsius. And we see that when we do this variation, our oscillation frequency still is higher, that is more than the above specification. Our phase noise is still better. So under the process variation, voltage and temperature variation also.
The financial part, we are all convinced that your technical output is wonderful, but that has been told more times.
Next, can't you want?
Where is the gap now?
Sir, whether it is ready to hand it over to HCL for fabrication or?
No, sir. I'll tell you. But these are all the circuit diagrams that we have done. I am coming to the files.
Everyone is fully convinced about these results. Please.
Yes, sir.
They have to take a flight.
Professor, your contribution is enormous. That's what it looks like. But only thing is we want to assess.
Yeah. Sir, these were the target specification. These are the achieved specification. And sir, this was the project schedule. I am coming. We are here, sir. Our project started on 29th November 2021. And we are right now here. That is 9 months after 29th November. That is, we are standing on the September, and we have completed all this. Literature review and behavioral modeling has been done. Front-end design simulation has been done. Layout design, we are on the way, sir. We have started our layout design by the end of 10th month, that is, say September end or early October, we will finish this layout design also, sir. And our post layout simulation will be over by November end, sir. That is 1 year.
Okay, nice.
Okay.
Okay, nice. Anyway, Jetana from SCL is superannuated. So who is interacting with you now? Ashutosh Yadav, yeah?
Dr. Ashutosh is there. Ashutosh is there. And
please minute it, because earlier Jetana was there. So he is
now he is retired, sir. Deep Sehgal, Mr. Deep Sehgal and Mr. Ashutosh Yadav are now our co-PIs, sir.
Okay, fine. So your supplementary grants will be released. Okay.
Yeah, sir. We request that our manpower grant is running in negative, sir.
Yeah, that you will release.
Okay, thank you, Professor.
Nice to hear your voice again, because I was used to interact with him a lot.
Okay.
Good. Yeah, you can log off now.
Okay, sir.
Very good amount of work is done.
Yeah.
It's very tough spec was given.
Yeah.
Very systematically.
Just
2 slides, that's all.
and already ahead of the deliverables and require grant because running.
Professor Bulchandani, please log out.
Yes, sir.
Next is.
हाँ वही बताना चाहिए ना इसलिए बस everyone is fully convinced कि बहुत अच्छा करा है.
Next list.
Fourth one. Rahul.
So Dr. Rahul Singhal, we just talked to him. He's not well. Probably he's in hospital, but he has informed Dr. Umesh Trivedi will be presenting here in today's meeting. So if Dr. Umesh is available in the meeting.
Ma'am, not yet joined. I'm also continuously looking for him. Once he joins, we'll take it up. Till that, I think we can take Professor Upendra Pandel. Are you there?
Krishna Kumar. Dr. Krishna Kumar is there.
Krishna Kumar is there? Krishna Kumar at least? Krishna Kumar. Then let him present this, because I think you're going to identify him as a...
Okay.
Yeah. So that also can be minuted. One more copy they're adding.
Okay.
Yeah, because unfortunately there was an untimely death.
Oh.
Co-PI Nitin Sharma ji, he is available here with me in the meeting.
Okay, ma'am.
Yeah, Krishna, go ahead.
A student is there, so you join the student.
Yeah, we'll finish that, Professor Pandey. I think that, sorry.
Pandey.
तुम्हें समझ गया तो मैं एक मिनट वापस करता हूँ है ना देखो फिर सिग्नल कट रहे हैं यहाँ
सीधी को फोन कर रहे होंगे ना अपने लोग.
Yeah.
Dr. Krishna, please start. Dr. Krishna,
Last slide, period number 4.
please share the slides.
Slide share कर लीजिए आपकी.
Yes, ma'am. Okay.
Sir, is it visible?
Yes.
Yes, full screen करिए और go ahead.
मैं भी कंप्यूटर में ऑनलाइन जुड़ गया हूँ.
Sir, since it is ongoing project, we are just looking what is the current status and what is planning for the coming year. That's all, sir. Only 2 slides.
Only for 2, sir. Okay, sir. So, good afternoon to all of you. This is an ongoing project under the PI of the project is Professor Upendra Pandil. He is with me, sir. He is here.
Hello.
So as you told me that I am showing you the what is the status of the project. So I am directly going to that. First is our project topic is the coating of high entropy graphene oxide nanocomposite to increase the thermal and electrical conductivity of CFRP.
This one today
And
only in this meeting.
our objective is to synthesize the high entropy alloy with graphene oxide to graphene oxide and use this composite coating over the CFRP to increase the thermal and electrical conductivity, so that we can use it in the use it for the aerospace application like fuse legs to for the RF application in the aerospace. So actually
Dr. Krishna Kumar, we don't need any of these things. Already it has been reviewed and project is ongoing. We want to clear the fund for the coming year. So we want to know present status. As per the plan, are you on time?
Yes, sir. We have coated this high entropy alloy over the mild steel substrate, and we got the EDS analysis. From that EDS analysis, we have the all 5 elements in that high entropy, and after that we are one more thing that we have advertised 3 times. We have advertised given the advertisement for JRF, but this time fortunately we got one student as a JRF. He will be joining the institute within 10 days. Yesterday we have given the offer to him, and this is the project budget. We have only allotted the first quarter project budget, and we are looking for the budget for the next year or for the next quarter.
Dr. Kumar, just one point, because you pointed out, it means that in your total budget, if JRF was there for 1 year and you have not got them, can we deduct that amount?
Yes, sir. Actually, we got as per the institute support, we got the 3-month project assistance for my PhD student who is working. Rest of the money you can deduct.
Yeah, please take it. Okay. Now, the results after coating, did you get the result and the thermal conductivity and electrical conductivity? Was it reviewed by SAC?
Sir, we have not tested it for thermal and electrical conductivity. Still, we are in the phase of getting the all 5 elements in the high entropy with the graphene oxide. We will, I think, in the couple of months we will go to ISRO center and we will test it for the thermal and electrical conductivity.
No, but milestone wise, after 1 year, what was you were supposed to complete? Have you done that?
Sir, I have done bimetallic coating on the CFRP successfully.
That's what you aimed in 1 year?
Yes, sir. Because we were not having any project staff, so we are not able to complete the work over the CFRP. And recently, I think 4 or 5 months back, Jamin Desai sir has sent me the CFRP made from there, ISRO center, and we are started working on that.
Okay, Desai sir, are you there?
Sir, Nitin Sharma, he is available. Now he is looking after this work at SAC.
Yeah. Actually, sir, so far they have taken trial on metal only. Now we have provided CFRP, bare CFRP samples. So trials are going on CFRP. So after coating, we will conduct all the tests in consultation with the MNIT.
And last month, sir, Nitinji also visited MNIT and met the Professor Upendal and his team there. So now SAC team has close interactions also. And in fact, sir, this project has actually started from August 2021. So actual work has started since August 2021. In November 2021, we had reviewed at our SAC level. We have our annual sponsored research review where this project was reviewed. So and there are close interactions going on between SAC and the PIs.
No, I'm not sure. I'm not getting the. See, you wanted to coat the CFRP with the typical combination of the material. So if metal is already there, where is the question of electrical conductive test? It will be already conductive, no?
No, metal is conducting, sir, but CFRP is not very high conducting. That's why we are facing problem to make it.
So the focus is only CFRP and then coating, right?
Yeah, yes, sir. Coating over the CFRP to make it electrical more.
Yeah, now you come to the point. CFRP you supplied now only.
Yeah, sir. Just now
So,
today.
one year, what was the work done?
1 hour back, I talked to Nitin sir. He told me that by Monday I
1
will.
year, just a minute. Last 1 year, what is the work done if CFRP you have given now?
Actually, sir, they were struggling to activate the CFRP surface. So last month's my visit, we discussed with for various methods, and now they are able to activate using the copper activation on CFRP. So I think now they should be successful with the CFRP samples. They have already exhausted the earlier supplied samples. Now we have given new samples. We are going to give them new samples also, sir.
So I think if I read it correctly, I think 1 year we only did the struggling, is it? No, nothing is, that's why
I think many trials were taken by them, sir.
No, but you could have quarterly, you could have reviewed it as that CFRP is available with you, with VSSC, with composite, with URSC. From anywhere you could have taken and given them so that 1 year could have been utilized. Time has
CFRP
lapsed.
samples already given, sir. For 20 samples were already given. Now we are giving new samples because already those samples they have exhausted in trials, sir.
So
samples were given 6 months back.
Just a minute. Samples were there with them, but they could not succeed it. Are you saying so?
Now they are able to do, sir. Earlier they were not succeeding, but now they are able to activate the CFRP surface.
Okay, fine.
Close interaction is required.
I think I am finding only 1 year time is left, and a close follow-up was not there. I think 2 more years.
Sir, 3 years project is there.
Very close interaction is required. Otherwise, next time funding will become a problem. That's what is my observation.
Sir, yeah, you are very right, sir. Actually, sir, this proposal was actually proposed by Dr. Duchania. Unfortunately, we lost him due to COVID, sad demise of Professor Duchania. And then later on, Professor Pendle, he took over. So initially there were again discussions with the SAC team, with the new PI who has taken, Professor Pendle. And PI has developed in the past, like the progress report which we had received from the team, they had developed a specimen of the nanocomposites with the graphene oxide as reinforcing on the mild steel substrate. Then later on, with intervention from the SAC team and visit of Nitinji, then now the samples have been provided, and we believe now the work will progress very fast, sir.
Let's hope so, and we'll proceed. I think we can request to proceed with the fund. I think close interaction is required. That's what I feel it. Okay, ma'am, we'll move to the last project for today. Dr. Umesh, are you there? Okay, I think Dr. Krishna Kumar, can you log out and unshare?
Thank you, sir. Thank you.
Thank you, sir. I think here at MNIT level, quarterly review doesn't take place.
So Neelam Kumari, we can see she is the student working in this project. If she is going to present, we are not sure because we can't see Umesh Trivedi ji.
First level screening, that is
Neelam Kumari.
No, Umesh is there now. Umesh ji, are you there?
Yeah, now we can see him.
Okay.
No problem. Umesh ji, can you proceed? We are not able to listen you.
Yes, sir. Now, sir, I am audible?
Yes, very much.
Yes, sir. Good afternoon to all respected.
Kindly share your presentation, please.
Yeah.
And kindly focus only on 2 slides. What is the present status and what is the expenditure, financial expenditure? That's all.
Rahul's to hospitalize.
Sir, is it visible now?
Yes.
Yeah. Good afternoon to all respected committee members of JPMC meeting. This project development of novel cobalt ferrite and CCTO polymer composites for EMI attenuation. The present status, you can see objectives. We have achieved synthesis part. You can see here purchase of consumable and other accessories including chemicals and synthesis of CCTO and CFO we have completed now. And development of polymer composites, we are it is in the process. So this is the status, and we have characterized samples.
Thank you, Dr. Umesh. I think it's excellently put forward. We wanted that table only. This is all will be reviewed by your centers. I'm not interested in this right now.
Yeah.
About the budget part.
Budget part, you see. Very nicely you have summarized. This is was planned and that, yeah.
Yeah.
We had given actually what is planned.
Budget, sir, we have received only first quarter. We have received only first quarter of the said budget.
But how much have you spent in equipment and others?
Sir, we have not proposed any equipment. We have just proposed our consumable and testing part and contingency and others. And we have already consumed first quarter budgets 100%.
Sir, they have received only 22.22 lakh only the first year, that too only the 1 quarter grant. So in fact, in their progress report also they have mentioned and also mentioned to the SAC team, actually they had initiated the work in July 2021. And yes, SAC co-PIs are also available. And in November 2021, we had reviewed at SAC the progress of this project also.
Yeah, I think, ma'am, it's very clear from the write-up and status, whatever you have shown. I think we request to release the fund. I think very good progress is there.
Yeah, that will be a help, sir. Thank you.
Thank you. Thank you,
Our
Dr.
JRF.
Umesh.
Okay, thank you, sir. Thank you.
Thank you very much. I think keep it up, sir. I think this is the way each project should move, then we don't have any issue. All the best, sir. Thank you.
Thank you. Thank you, sir.
I don't put 2 columns. What I do is objectives and color them. This is over, this is going on, and this is remaining.
That's all, no? Thank you, sir. You can log out and unshare.
Your target achieved.
Wonderful.
No, that's all. Now, what is the?
यहाँ पे बिल्कुल नहीं और इसमें ज़्यादा जरूरत भी नहीं है.
नहीं वो sir
You are giving enough time to new projects, which is more important. That is the most important aspect.
No, ये एक दो लाके students gets motivated. Actually, tomorrow they will.
Yeah, correct. I was thinking about it. Yeah, 1 or 2 they have given, but not in a large scale like this.
Can you
Sir, Alok sir, just one thing we want to just point out regarding the student projects which we were discussing. The first one, actually that time we were trying to reach out to you people, but I think there was some audio issue. Our voice was not audible there. This first student project, which was the fabrication performance optimization of thin film BAW filters. Actually, this work is being carried out at SAC, and the student who was showing this, Swarit, he has mentioned in his presentation work to be carried out at SAC and Pune, but they have not discussed with SAC team. In fact, I had the subject expert also here that time. It has not been discussed with SAC team, and moreover, this work is already being carried out at SAC. So I just want to inform regarding this because we were not aware of this presentation also.
Right, ma'am, just I wanted to highlight only one point. These are all very small, chota projects, which I feel we want to encourage students. So
definitely, sir.
Whatever work is already completed at SAC level, if you have already, I request you sincerely, you can guide after discussion with the students. So you can give him little more extra delta so that it come out nicely as a joint work. So I will request Dr.
Sir, I would request RACS coordinator to kindly share the student presentation with us so that properly, because the student was showing that work to be carried out with SAC, but as here our team, and we are also not aware, so we were also like, what work the student is proposing, let our people guide him for this student project, sir.
In fact, I highlighted that point, but somehow, because no response came from SAC, so I thought we'll move on. So I think.
No, sir, we were there, but our voice was not reaching to you, sir.
Oh, yeah, no problem. Dr. Namita is here, and she'll coordinate with you, and she'll share the presentation. I sincerely request you to give little more advantage to the title of the project so that it becomes advantageous.
Yes, sir. It seems that they have picked up the topic, the project topic from our research area of SAC, which they have picked up from there. Yeah, we'll make, if they need SAC support, we'll make it more focused for the student project.
Sure.
Connect with
These projects now already.
Connect the students?
Already discussed now.
No, not.
Anyone else, ma'am, out of 7? This is the only one from SEC or anyone else?
Yeah, this particular one. Yes.
Okay. Thanks, man. Thanks a lot for being with us from morning. Thank you.
That's it.
No, but as per the, you are to sum up.
Oh, acha. Okay.
Thanks, ma'am. I think she can.
Let us want to have some discussion on the new
Sir, I am the response coordinator from SAC, sir, Dr. Abha.
No, Abha ma'am, you can be here. I'm just asking JPMC members.
Okay, sir.
What I'm telling you want to
Our SAC co-PIs may kindly log out.
That's better, yeah.
Okay.
No, you PIs are requested to log out.
Response coordinators, PIs can leave now. PIs and co-PIs can leave.
Abha ma'am, you can be there, please.
Yes, sir. Yeah, no, I'm just requesting my SAC co-PIs who are joined online to kindly log out.
Log out. Yeah. Other than JPMC members and RAC coordinators, others can leave, please.
PIs and co-PIs, they can leave.
Or can we log out? No, but so many are there.
So many are there.
All are JPMC.
No, all are not JP. Umesh Kumar Devedi is still there.
Sonal.
उनको हटा दीजिए ना तो नहीं यार उनको धक्का मारो
Vikram Hall, Ramana sir is there. Nitin ji can. Krishnaiya is our member.
Krishna is our member. He's a response coordinator.
Then Kanu Priya.
She's JPMC. From MNIT.
NIT.
From MNIT.
Okay.
Like this is Hawla.
Okay. So Jagannath is.
Okay, Kumar-ji is also there. Okay, now I think.
We had in the screening part, so they all.
Okay. Good afternoon to all of you. I hope you are able to listen us carefully now. Only JPMC member and our coordinators are there. So I just want to take these things. Narayanan sir, are you there? Dr. Vrinda ma'am?
She is there. She is there.
No.
Vrinda madam is there.
No, that should be there. Dr. Brinda ma'am, you are muted. Are you there so you can unmute? Okay, I think she is not there. Anand Padmanabhan sir, are you there? Sunil sir, Dr. Sunil, are you there? No. They will log in, but they will not be there.
They will not be sitting.
I face this problem every day last 2.5 years.
Here means they will sit. If in the station.
Dr. Ramana?
They will be.
Okay, so I think only. No, not there.
Okay, now we can discuss.
Jagannath.
No, it's not.
Okay, no response coordinators are there. Okay, we can.
Okay.
Yes, sir. You can still summarize.
Okay, I think let me thank all the members who are now present or who attended this meeting from beginning. I wanted to, before I leave, just I'll take another 5-10 minutes only to discuss the 13 projects. Out of that, project from IIT Goa is eliminated. So I just wanted to give the briefing what we felt it, and all the members can offer their comments freely so that we can conclude and minute of the meeting can be prepared accordingly. The first project, I'm quickly going through, I'm not going to spend much time, already we have reviewed it thoroughly. The first project was development of high entropy alloy components for aerospace application. I found that it's a good project, and I think budget only was supposed to be reviewed. Timeline, anyway, we found it's suitable. So I think enough query we made from our side. So we will clear this project. So first one.
Be reduced to
Budget should be restricted to 25 lakhs. Second was detection of trace elements using microsensor array in human space flight. This also, it was okay, the project per se, but based on the review and other things, I very strongly felt that the budget can be limited to 20 lakhs and time limit 2 years is okay. But Sudhir ji has put up Sudhir ji has put up this point. Abha ma'am, you want to say something?
Yes, this is Dr. Parul here. I have discussed this with our Payal, who was trying to put her point across, that this project was discussed earlier with SAC with quite some time, but finally it had gone to HSFC. And the specs which are now developed by HSFC, the product that will come out will not be of use to SAC. So SAC will not participate in this project. Because these specs are not usable for the sensors, those thermo aspect and all that, thermal aspect and all, because what we had, Dr. Payal and all, they had developed, did not, that was not presented. So she was trying to tell that only during that time, but Sudhir sir was little bit in a hurry. So will not be participate in this project.
Ultimately,
Because that
it will not be
it will not be usable. Whatever deliverables
with the electronic.
I fully agree with you. I fully agree with you. There are 3-4 concepts are there, and when I was reviewing the Gaganyaan, I remember the SAC action items and SAC deliverables, as well as the ISC deliverables, as well as our HFCC. So I think I request that ISRO co-PI focal point for second project SAC can be eliminated. Okay, thank you, ma'am.
Yeah, and sir, one point should be flagged that whatever outcome is there, even if it is developed by HSFC, finally SAC will not be able to make use of it. So as even although we are whatever specs they have done, it is not as per the requirement.
Ma'am, I think I'm very confident and certain about my opinion. I think that part let us eliminate.
Okay,
fine. We will not put any such statement, ma'am. It is for ISRO and ISRO.
Sir, correct. No, sir, why I am flagging it that finally, because this activity, SAC is responsible for all the cabin. So later on, that as a part of our STC, we have, funded this and it will be developed. It may be developed wherever, but finally, as part of project, it should not be that SAC, ISRO has funded. So this should be now used, because this is not addressing our technical specs. Just that I just wanted to make it clear. So even our HSFC friends should be flagged for that. Just flagging.
Ma'am, I think I'm not for it, and I think only from your side, if you want to write a mail to Dr. Vinod, or in my next review, which I am having shortly, I will convey this to Vinod and Sudhir.
Please, just that.
I will not put in this minute. It's not good from our part, ma'am.
Only thing you will remove.
Okay, no issues.
Okay, thank you. Please don't take it negatively, ma'am, because it's all technical.
No, sir. No, I'm not taking it negatively, sir. It is because in the project, then these things we try to implement. So it should not happen later on that it comes on our JPC, that you all have funded. Because it is finally, we are all one, sir. Whether you
Yeah,
or
true,
us,
true.
we are
Yeah.
one only, sir.
True,
Yes,
sir. True,
Yeah.
true, ma'am. True.
Yeah.
Third one is ISAT based ground. This also, I think, both the points, we are approving this project, but time is reduced to 2 years and budget should be limited to 15 lakhs. And that's how only 2 parts were there. So that's how we are restricting it. Coming to fourth project, development of ultra high submicron level measurement facility. I think this is also an excellent project which is going on for the thermal expansion of dimensionally stable composite. I think I requested only the budget to be reviewed because I felt it is really high for the instrumentation and other things. So it should be limited to 20 lakhs, less than 20 lakhs. That also we have approved.
The specimen size to be reduced to 1 centimeter.
Yeah, that is a specimen size. Now coming to fifth project, integrated application, all in situ monitoring CalFed. I think here we had a lot of debates. Time is not appropriate. It should be reduced to 2 years. Budget has to be appropriately reduced. And scope also has been modified. So ultimately, I requested that all these 3 changes should be appropriately done. Then should be reviewed by our Dr. Gupta and Dr. Namita here. And once that is done, then only corrected proposal. If it is falling within appropriate budget, then only it should be taken here.
Sir, we have informed Professor Namita regarding the budget, regarding the data.
No, this is from VSS.
No, this is from VSSC, ma'am.
Okay, sir. Yeah.
Coming to sixth project, performance exploration of LTMO and vertically aligned MWCNT on graphene material. I think this we have cleared. We don't have any problem. Only thing is timeline and budget both are incorrectly shown, at least the sheet which is given to me.
2.5 years to be reduced to 2.5.
3 to 2.5 years and budget I think 28 lakhs they were looking for.
Budget
so that is
revised accordingly.
Budget to be revised accordingly.
2.5 years.
That was 22.
22.55. Then
Yeah.
make it to 2.5. We'll have to see how much variation
Yeah.
has come. And everywhere that JRF part will be taken.
She said that it won't vary because she has not asked for any project staff. So no salaries.
Much reduction may not come because of that. Okay. Much reduction may not come.
Yeah.
To see that. And JRF part to be taken care everywhere. Okay.
There's no JRF in this.
No, other else.
The uniformity should be maintained at HRA also. Okay.
Then seventh is
we have to keep 20,000. In contingency also we have to keep 20,000 for this project, sir.
Yeah. Right.
Seventh is withdrawn. Eighth is developing a user-friendly chatbot. I think we have cleared it. And I have requested a SAC not to have any kind of strategic data. And second point was independent data which is available in the platform wise, because JPG, PDF, all that has to be, what is there, that should be provided to PI, Dr. Namita ma'am. So appropriately correction to be taken. Then
It's done already. Action taken, sir. Yes, sir.
Design and analysis of slow wave structures for QV band traveling wave TWTA. Not TWTA, only TWT. So I am not sure. A means EPC should come.
This is the one.
So this I am not clean.
Change, it's PI change.
That's
These have got the PI has got change.
Yeah, because PI got altered, it has to be reassessed in the light with the SAC team, and once it is done, then only should be done.
Yeah, we'll send that.
Yeah. 10th is a simulation analysis and implementation of soft design forward. I think this was perfectly all right. Only problem was here was budget. It was should be appropriately. It is shown 37 lakhs, but against 32. So should be seen. Timeline is okay. So next is 11th is development of space qualified vapor chamber. I think this was, I felt is time should be reduced to 2 years, straightforward, and space qualification should be looked at SAC. And third year, whatever is small assistance is required, center can look at it. So
to 2 years. That's it.
Yeah, that's it. Appropriately, budget should be revised. Then 12th project is onboard spectral pre-processing for multispectral imaging. I think this was found to be satisfactory. Only
Budget to be slightly more.
budget should be modified. Yes, yes. And the last one is design and demonstration of empty and foam field. Anyway, this is, I think, VSSC has taken it appropriate correction. So I feel that I think this is okay. We can clear it. That's all. All student project 7 we have cleared it, and it's a status of the ongoing project. I think everywhere we have released the fund, except the one where I think last one, no, I think very close interaction between SAC and is required. Otherwise, we'll be slipping it. So that's the only my recommendation. Any other comments from any other member?
Dr. Paul, sir, actually for both the SAC ongoing projects, kindly amend in the start date as Dr. Rahul Singh's project in July 2021 and Professor Pendle project in August 2021. Actually, they had started during that time. So kindly, kind request for that change.
We'll have to see when the fund were first, funds were released.
Yeah, that is that's date is according to what PI has reported to us in the progress report also, and from the first, as we always say, from the first expenditure.
No, that is okay. That was the earlier status. Now, hereafter, once the fund is released, that date will be considered as the project starting date, because they cannot delay further after 3 months, 4 months. They cannot start it. Okay. Now
so once the fund is available, you mean to say? When the fund release, you mean to say?
Once the funds are released, then it will be that will be the starting date.
Okay.
So that they can, yeah, that is for them to see when the fund is released. But then accordingly, kindly change the date so that they start, unnecessary will then say 3 months extension, 4 months extension. It doesn't at the end. So just for that. Yes.
Probably from RACS side, they can amend the start dates as per their records. The start dates.
Okay. I think some question from ISRO headquarters.
Any comments from anyone else?
Yeah, Ganeshan here.
Okay.
Okay. Yeah, Ganeshan, please go ahead.
So I would like to add 1 or 2 comments.
Yeah, please go ahead.
See, I was listening to a couple of these presentations.
Yeah.
Okay, not to discourage, but when people talk about deep learning algorithms and segmentation and classification and so on, see what is the novelty in the method that they're trying to do is not coming out. Okay. See, we say, okay, all these tools are generic methodologies today in AI. So what the professor is planning to implement, there is not even an outline which is presented. So how these reviews can be, focused enough to either clear them or not clear them is not very apparent to me. That's point 1. Second is on validation, how they plan to do is also not indicated. Okay. See, then we had some discussions on DEM, okay, digital elevation models, where some flooding related studies were also asked for.
Yeah.
Okay, where will they have the data sets available to them, and how they were, whether they have done any sort of a prototype study initially to show that this is an applicable method? I am not sure, because I checked with somebody in NRSC. They're saying no, this DSM, DEM, all this, they are all available, but they're coming with their own limitations on what can be the focused outcomes of these projects. Okay.
Ganeshan, I think let me just answer this particular question. I think it was ISAT, and I asked this question very specifically.
Yes, this is related to ISAT only.
Yeah, Dr. Srinivas Rao, and he has already supported, saying that they are in the urban area, there is no problem, but rural area.
Rural area. No, rural area, no problem, but in urban areas, they have a problem.
Side. So already they are in touch with, and I requested that appropriately data, and I also highlighted that very cautiously that instead of ISAT, whether we can take our Indian satellite, all that things I pointed out.
Yes.
So I think it is jointly done. So because it's being discussed along with our ISRO PI, so I have not discussed much, thinking that it has already been reviewed. Coming to your first question about the deep learning, if we just look at it, whatever 13 projects were there today, except one project, I think there were no project where deep learning was there involved.
I think that's the reason why I thought deep learning, AI, ML, all these topics are so wide nowadays
Yes.
that depending upon the professors and joint work with the PI, our ISRO PI, I think I'm pretty sure that regular routine will not be appreciated by ISRO. There should be some novelty. Then only ISRO is also going to accept it.
Yes, accepted. But what I would add as a point of precaution is there can be some intermediate checkpoints to see whether the professor is delivering in the right direction.
Exactly. So for that sake, already I have put that action. One
Okay.
thing is that our people should quarterly, they can at least interact. But the problem is I cannot put it on the recommendation here. The moment I put the quarterly recommendation, it should not get linked to the budget. And then we will end up in reviewing every quarterly the budget aspect, and if his status is getting affected, then work, because you also have worked so long, Ganeshan.
Yes, yes, I am aware. I think without a progress approval, it is not getting linked to budget sanction also from Dr. Paul's side.
Yeah, okay. I think we will.
So the last point is,
Yeah.
I have a last point. See, on sensor related projects, especially on HSFC, we see several groups in the country working on this, either under STC or under Respond and so on. Okay. Again, the methodologies have to be very clear.
I think this also, Ganeshan,
This was also pointed out in the morning, I remember.
Yeah, Sudhir
But it
has
should get
pointed
minuted.
out clearly. Okay, I request Dr. Gupta to say a few points.
I won't say anything because the flight time for Alokji and Dr. Paul is approaching fast. But I'm thankful to all the JPMC members to have contributed online and offline both, and especially to the energies of Dr. Alok and Dr. Paul in sitting and patiently asking questions from every presenter, and our own team, which is doing a tireless work. So thank you all, and let's hope something really meaningful will be generated out of these projects. Thank you.
Thank you.
Thank you, sir.
Thank you.
We
Thank
had
you, sir.
an excellent review, and I think many these new organizations, new institutes have joined our RSES. That is really great. And for the first time, we could be able to take up some short-term projects. In the RSES, it started some time back, but we could not take up any short-term projects. So it's the first time. So I thank all the members, our co-chairs, and our madam also, and Respond coordinators, all our co-PAs, everybody, for the wonderful coordination and your effort for bringing it, for taking this forward. Okay, thank you. Thank you
so much. Dr. Namtan, say something.
So we are hoping to get mostly all the projects have been done. That is the main point for me. And thank you very much for coming here personally and spending time and efforts. Thank you very much.
Thank you.
Thank you. We are
This is
thankful to
Kanupriya. I just have a
RSCS
small
MIT
request.
team, Dr. Alok sir.
Thank you, Alok sir.
Alok, Dr.
Thank
Alok
you,
sir,
Dr. Alok.
it's always a pleasure to hear your voice. We always hear you during our launch time. Once again, it was pleasure to hear you today, sir. Thank you so much.
Thank you.
Kanupriya, I have a small request, sir. Can you hear me?
Yeah, thank you. Yeah, Kanupriya ma'am. Yeah.
Yes, sir. Yes, sir. The request I have is that please include master science students also in these short-term projects.
That you will take it up. Yeah, will take it up.
Students are allowed to apply.
Yeah.
Thank you so much, sir.
This has been said many times since beginning.
Thanks a lot. Thank you.
Thank you so much, Nanda.
Okay, thank you, madam.